Okay, everything else is not too important. If AFL thinks something is important, it will highlight it in red for you. So it's found some crashes. This is highlighted in red as an indicator that something might be wrong. In this particular case, nothing's wrong. It's just we're fuzzing an extremely trivial program, which is sort of out of the norm for what AFL considers should be the usual case. You can find out all about this data screen in AFL's docs, which we're going to come to. They're really good for learning about the interface and indeed how to use AFL. Yeah, so just to recap, important stuff under process timing, important stuff under overall results, findings in depth, somewhat interesting, stage progress. We're not too concerned about the first two bits, but the total executions and the execution speed, very important. Everything else, largely ignore unless AFL tells you to pay attention to it by making it red. So now is a good time for questions about that quick start process that we just ran through. You also might want to consider some of these questions. In particular, what would have happened if AFL didn't have that head seed file? You can experiment with that if you like, just delete the file, move it out of the inputs folder and rerun AFL. See what different behavior you get. Will it still be able to find the bugs associated with the head functionality of the program? And if it can, how will that differ? And then if you look in the vulnerable source code in the vulnerable.c file, you'll see there's an Easter egg in there. How might AFL ever find that? Is that something we can find with fuzzing? What are our options there? And don't worry if you don't have time to consider these questions, we are going to come back to the answers to these later on. Okay, let's talk about test harnesses. So most programs that you want to fuzz, you won't just be able to do what we did with the Quick Start program, which was compile it with the AFL compiler and then run AFL fuzz on the program. Because AFL has some particular requirements on the format of the program, how it behaves, so that it can get its test cases into the program to be properly executed. Most of the time you're going to have to write a test harness for that program, which is like a wrapper around the code that you want to exercise, that you want to test, that will allow you to hook up AFL to your program. So what does a harness have to do? It has to do all of these things that are listed here on this slide. So first of all, it has to run in the foreground. Your program can't fork off and run in the background because AFL will lose track of it. It has to just run and remain in the foreground like most programs do. Then it has to do some kind of processing on data it receives, either from standard input, like the vulnerable program did, or from a file, which is another obviously very common form of input. And you have to be able to specify the file name like on the command line. Once it's got the data from the file or from standard input, the harness needs to ferry that data to the part of the program that you want to test. Be it the whole program, you've just modified the main file, the main function to change where it gets its input from, or maybe it's just a function or a specific API within the program. Your harness will call that API with the data it's received from standard input or the file. Once the program has finished processing that data, the harness needs to exit cleanly, so it just needs to quit. It can't just hang around, and it can't crash because AFL will interpret that as a problem. Interestingly, so if there's a bug in the program that you're testing that leads to a crash, then fine, AFL will detect that. we can do some fancy stuff that we'll cover a bit later, where you can actually trigger your program to crash if you detect some kind of bad condition. So your harness can do that for you as well, but we'll cover the kinds of things you can do there later. If the program you're testing has checksums in it, or some kind of integrity checks, like it does a hash over the input, or it expects the input to be signed in some way, you need to bypass or otherwise disable those checks. Or maybe conversely fix up the input to pass those checks. It's usually easier to bypass them. So maybe create an if-def and make all those checks go away in the program. Because otherwise, the fuzzer is going to spend his entire time, most likely, generating inputs that get as far as that check within the code. The check will fail, and that's that. And the fuzzer will never be able to get past that check, because it's never going to generate a file that happens to have a valid signature or a valid CRC or hash in it. And then finally, your harness wants to use some of the cool features that AFL has to make it run faster. So these are the deferred fork server and persistent mode, which we're about to explain. It doesn't have to use these things, but if you do, you're going to find more bugs because it'll run faster. Okay, so this is the harness walkthrough. So here we are in the harness folder. I'm just going to read through this README file. So this library that's in this folder has a crash in it, but that's not really what we're going to focus on. We're just going to focus on how everything works. So this diagram here shows us all the different component parts. We're down the bottom here. We don't quite fit on the screen. Okay, so let's see, starting with us. We start off by writing a test harness for our target. We create this little bit of code, this little harness around the target. We compile the harness and the target using the AFL compiler. So this is the AFL modified version of GCC or Clang. Ideally Clang if our target supports that. And that produces an instrumented binary. And it's not exactly the same as an instrumented target, the original target file, because it's got our harness in it, our harness modifications around it. So there's our harness. It's an instrumented binary that we can run. And we should see its behavior is very similar or potentially identical to a normal target if we just run it in the normal way. Down here, we're going to collect or create a number of input files to make our input corpus, stick them in a folder, often called input, and AFL is going to use these as its initial set of test cases. It only uses them to start with. After that, it does its own thing with the test cases it generates. So as it runs, it takes a test case, spawns an instance of the instrumented target, runs that target with the test case as its input, gathers the coverage information that the instrumented target produces for AFL so that it can learn whether that test case was an interesting test case or not. Obviously, if the harness crashes, AFL records that by putting that test case into the crashes directory. Otherwise, any test case that triggered a new state transition within the target gets saved into the queue folder. And then it's this queue folder that is used as the source of all the test cases that AFL is going to use throughout the fuzzing run. So originally you would expect all of the input folder files, the seed corpus, to cause new state transitions, so they will all end up in the queue, and then anything that it mutates that leads to a new state transition within the program will also end up in the Q folder. And AFL obviously has its UI that we monitor. And that's the overall flow that we've seen. Okay. So let's run through this process for this example library that's in this folder. So there's a header file that tells us that this library has two functions, an echo function and a multiply function. It's got some documentation that tells us how they behave. So we want to fuzz one or both of these parts of the library, the echo or the multiply API. How do we fuzz it? So at the moment this is just a library. There's no executable associated with it. It's just a library file that we can use in our programs. So we have to make a program that is actually executable. That program has to be instrumented so AFL can learn about these basic block transitions and see how different inputs lead to different behaviors within the program. So for that to happen, we have to compile it with one of our instrumenting compilers, one of AFL's compilers. And then this executable program actually has to take the input either from standard in or from a file specified on the command line and get it into this API. Otherwise nothing will happen. And AFL will tell you, incidentally, if nothing is happening. If it sees no matter what inputs it produces, the program always does exactly the same thing. It'll warn you about that. Okay, so let's start with a minimal little harness that's going to try and call these APIs. Zoom in a bit. So here's kind of the minimal program you might imagine that uses this library. We have some data, we echo it, and we do a multiplication of 1 times 2 and print that result. So we're using both of the APIs from this library in some basic way. We can compile that. Here's the command line to compile it. Fine, we have a harness executable. And if you run it, it will print out some input data, and it will hopefully print out the number 2. We can't fuzz this because this program does not depend on any external data. It just does the same thing no matter how you run it. So we need to modify it to take its input data. We're going to use standard in. That's the kind of easiest one, in my opinion. But we could have done this using a file name instead. So here's a modified version. We have a fixed buffer size. Picking the size of this buffer is kind of interesting. So this program is now going to read in up to 50 bytes of data from standard input. It could be that we only hit bugs if we allow it to read in a gigabyte of data, but that's going to really slow our program down if we can read in arbitrary sized amounts of data. So this is a judgment call to decide how big you want it. Like obviously most programs are going to want inputs much bigger than 50 bytes. In this case we just picked 50. We happen to know that that's a good choice for this program. Okay, this is an important point here. So the input variable that we're going to use, we zeroize. We make sure that it's all 0 before we read the data in, because otherwise we might have some uninitialized data getting processed, which will introduce a level of randomness that we don't want in the fuzzing process, because we'll lose reproducibility. Because it means the library is not actually testing just the data that the fuzzer gives it. It's also testing potentially some arbitrary other changes. So it's pretty straightforward. We read in from standard in into this input variable up to 50 bytes. We actually get this many bytes, length bytes, and then we echo it. We can see previously we were echoing this fixed data, the length of this data. Here we're echoing the data we've read in and the amount that we've read in. So now we are actually processing the input data. And in a more complex program, AFL could go to town on this and start discovering lots of different interesting paths through the program. This library, if you look in the implementation, is extremely simple, so it won't find many new paths. But if you run it for long enough, it will eventually find a crash. The library does one thing other than echoing the data, and that is crash with a particular input. So you can do that if you like, but it's not our goal here. One thing that's worth noting here, when we talk about in the text here, is that the printf call that the library relies upon to do the echoing is not instrumented. So we are using the standard libc shared library, which we didn't compile using the AFL instrumenting compiler. We only compiled the library in our harness using that compiler. So whilst printf does lots of different stuff for lots of different inputs, AFL won't notice any of those because it won't see any changes in the basic block transitions within the program. If we wanted to fuzz printf, you have to compile libc with the instrumenting compiler as well. Often that's not worth doing. You really want AFL to focus on the behavior of your program, probably not the behavior of the underlying C library. So that's why we don't do it here, and I wouldn't recommend you try it for most of your targets. Okay, let's move on to fuzzing the multiplication function. So this is slightly different. So with the echo function, we could just read our data in and stick it into the API. But the multiply API doesn't look like that. It takes two numbers in. Now AFL can only dump a byte stream onto your target. It doesn't know that your target wants two numbers. It's just going to throw bytes at it. So our harness has to read that input stream and parse out two integers. So here's one way we can do that. This time we're having 100 bytes as our potential input size. Have a bit of argument parsing logic. Our harness can now handle echo as well as multiplying. So you can run the program in two different ways. And so in the multiply case, we initialize our two integers, and then we've decided to read in 4 bytes, making an assumption that this machine has 4-byte integers. So the first 4 bytes of the input are going to be the first integer, the next 4 bytes are going to be the second integer, and then we're going to multiply those. And that's it. So we don't need to tell AFL that that's what we've done. It doesn't know that we're multiplying numbers or that the harness is treating the data in this way. The instrumentation behavior will learn this essentially. It will learn that only the first 8 bytes are of interest, and that any modifications it makes to data after that never leads to a change in the target program. But we do need to run the fuzzer in a different way because our harness now has 2 different execution paths. Well, 3 if we look at these 3 different cases here. So here's the usual AFL fuzz command line, but we also append what function we want the harness to do, what function we want it to exercise. And of course that was just a design choice we made. We could have made the harness do both at once. Read in some data for the multiplication and do some echoing at the same time. It depends what we want to do. Now I said earlier we've used standard in here, and you could have designed this harness to read input from a file. If you want to experiment with that, then here's the steps you need to follow. Take the file name from the command line, open it and read that content into the buffer instead of reading it in from standard in, and then pass that buffer to the target just like we were. And then the final detail here is, so we're fuzzing libmul, and we'll hopefully find some crashes, if there were any crashing bugs in this function. But what we're also interested in, if you're fuzzing a multiply function, is it correct? Is it functionally correct? So question there is, how can we use a fuzzer like AFL, which doesn't know anything about the intended behavior of our target other than it thinks it shouldn't crash? How can we use that to test for functional correctness? So that's just a food for thought. We will come back to how you can actually do that later. Okay, brief aside about the AFL documentation, it's pretty good. I recommend reading it all if you're going to spend a significant amount of time fuzzing. If you want some pointers to the best bits of the documentation, they're here. These 3 files are definitely worth a read. Possibly worth a skim through during this workshop. When we come to our next practical, up to you. Ultimately, you don't need to read any of this. Like I said at the beginning, AFL is a batteries included tool which doesn't have too many knobs to tweak. So you don't need to know anything more than we're actually going to work through in today's workshop. But know your tools and all that. If you're going to do it, use it a lot, then it's worth a read. Okay, so now we've got 5 different features or so of AFL to cover that are gonna allow you to really tackle most of the real world targets you're going to come across and find real bugs. And then once we've covered those, we will go on to the real challenges, the main challenges. Right, first feature, LLVM mode. So AFL comes with a GCC compiler, a modified GCC compiler, and a modified Clang compiler. Where possible, you want to use the Clang compiler because it allows you to use LLVM mode. These are the 2 features I just mentioned, deferred fork server and persistent mode, both of which allow you, with most targets, to significantly speed up your execution. So deferred fork server says to AFL, only fork off a new process once you've reached this point in the program during the startup of the program, which means that any significant work the program does to start up, reading in config files, initializing variables, doing whatever it does, you can amortize that so it only happens once, and then AFL takes a snapshot of the program and starts forking off its copies. So you need to find the point in the program before the target has consumed any of the fuzz data, if you like, the data you're going to be fuzzing, the input, but after it's done any significant heavy lifting during startup. And that's the point where you tell AFL, start your fork server here. There's a little macro. You can see the actual details of how to implement that in that README. Persistent mode will make an even bigger difference to a lot of targets. This allows AFL to not start a new process for every single test case it wants to execute, but instead it reuses a single process in a loop for a large number, some hundreds of different inputs before it spawns a new process. This is really helpful for fast targets because in fast targets, the process overhead can be a very significant part of the overall execution time. So by doing away with that or by amortizing it massively, you speed up the execution a lot. It only works, though, for targets where you can be confident that at the end of an execution, you've reset the initial state. Because otherwise, you're telling AFL, run this loop a few hundred times with a load of different inputs. But if after each execution the state of the program is different, then you lose that sort of reproducibility and you might get a crash which you can't actually reproduce just by running that input. You actually have to run all of the preceding inputs first. So persistent mode is great, but only for targets where you have some confidence that you can restore the overall program state to some initial condition, or there is no global program state. LLVM mode. Initial test cases. So we've seen a couple of these in the quick start. These were the files in the input folder, head and U. They're also known as the seed corpus. The idea is these are a set of inputs that exercise as much of the program's functionality as possible. But it's also ideally the minimal set of inputs that do that. Because the fuzzer is going to start with these inputs and mutate them and splice them together and so forth, if you've already got inputs that are exercising a lot of the program, you're going to get much deeper within the program's state space than if you didn't have these inputs and AFL was just starting almost from scratch. Now, when you've got a moment, follow this link in the slides. AFL can work wonders without a seed corpus. The post here is from the original AFL author, Mikhail, and it demonstrates how AFL was able to discover the JPEG file format with nothing more than a JPEG parser, and it just did mutation after mutation after mutation, and eventually was producing completely valid JPEGs that exercised a huge range of the JPEG file format features. But you don't want to do that. That's not a good use of your CPU time. It's kind of a very cool demonstration of what AFL can achieve, but really you want to find a good set of input files for which to kickstart your fuzzing. So there's some guidance here from the AFL README. It suggests your C corpus should consist of small files. It's just a speed thing. The smaller they are, the faster it will go. The less there is to mutate. And yeah, only use, so this is the minimal set of test cases point. Don't put in redundant files. More is not always better. More coverage is better, but more files is not necessarily better. Sanitizers and hardening are techniques that we can use to find bugs that would otherwise slip by. So if your fuzzer generates a test case that causes the target to hit some bug condition, even if it's some kind of memory corruption or uninitialized read or something, there's no guarantee your program is going to crash. These sanitizers add extra checks into the compile program that will detect conditions that are buggy conditions, things you don't want to happen, and turn them into crashes so your program won't just stumble on. This is useful because a bug that your test case generated by the fuzzer hits, even if it doesn't lead to a crash, that particular test case, it's quite possible that's still a security vulnerability, and an exploit developer could turn that bug condition into some catastrophic security problem. So we do want to detect these classes of bugs. So what have we got available to us? Here's 4 different sanitizers: undefined behavior sanitizer, memory sanitizer, address sanitizer, and thread sanitizer. They're kind of mutually incompatible, not all of them, but most of them you can't run together. So what we do is we run different instances of the fuzzer with different sanitizers on. Briefly, what do these sanitizers do? Undefined behavior sanitizer catches conditions that aren't specified what occurs in the C spec, so things like some signed overflows or using null pointers. Memory sanitizer detects reads from uninitialized memory. Address sanitizer catches a whole bunch of different conditions around memory corruption, so reads and writes to bad memory addresses. And thread sanitizer catches data races in multi-threaded applications. They all slow your program down quite a bit. I think address sanitizer has like a 2 times performance hit, for example. But usually that trade-off is worth it. The sort of simplest form of hardening you can do is just by compiling with this environment variable set. With AFL harden set, when you do a compilation, it will turn on fortify source, and it will use a stack protector for all functions. This has almost no performance impact and detects some additional memory corruption bugs. So at a minimum you want to be using AFL harden, and in practice what you want to do is run with a big mix of all the different sanitizers. So there's some guidance in the README as to how to balance what sanitizers you're using and also what runtime fuzzing options to use when you're running multiple different fuzzers on the same target. And the link's there, you can check that out. We want to get the most out of our machines that we can, and the way to find the most bugs when fuzzing is to do the most fuzzing possible. So we want to use lots of machines and machines with lots of cores. Unfortunately with AFL, getting the most out of multiple machines and multiple cores on one machine is not trivial. You can't just say, here's my fleet, please use it. So we have to do some work. The basic mechanism is to run a single main instance. You run AFL files with the -m flag, and then multiple secondary instances. On a single machine, you'd run one secondary instance per core, and then on multiple machines, you just run lots and lots of secondary instances. On one machine, all the different instances share a state folder, so the out folder. On multiple machines, you have to periodically sync those state folders. And there's some scripts and tools out there that will do this for you, that will cover probably your use cases. You can see links in the documentation for these tools. The reason it's not built into AFL is it's very hard to come up with a way that will just reliably work for everyone's use case. So they decided to not do that. We've already mentioned when you are running multiple fuzzers, we want to run them with different behaviors to get the most out of our fuzzing. Ultimately, for large-scale fuzzing, you're probably going to end up using something like Google's Cluster Fuzz or Microsoft's OneFuzz. These allow you to run on Google Cloud and Azure, respectively, and really scale your fuzzing in a massive way. OneFuzz is pretty brand new. Cluster Fuzz has been out for open source for a year or so now. They will save you a lot of effort writing your own hacky version of a large-scale fuzzing initiative. I haven't used OneFuzz yet, but I have used Cluster Fuzz. It's not super easy to use, but it's pretty good. It's not too much effort. If you are looking at using fuzzing seriously in your organization, then it's worth looking into. Okay, dictionaries are a super important part of effective fuzzing. These are cheat sheets for the fuzzer to say, for this target that you're fuzzing, here are a load of really interesting tokens that are going to allow you to discover interesting states within the target, rather than just waiting for the fuzzer to stumble upon them with its normal mutations. There's a bunch of different sources for these. So AFL comes with a dictionaries folder for a bunch of different common file types. So if your target uses one of these file types, then that's a great starting point. You're kind of sorted. There's a cool new feature with the AFL-Clang link time optimization compiler. It statically, as it compiles, finds comparisons against fixed tokens and builds those in to the executable in a little dictionary that it passes to AFL Fuzz at runtime. So that's neat. It's not going to be perfect. It's going to likely capture a bunch of stuff that you don't care about. But for a zero effort feature, that's quite cool. libfuzzer has another collection of static dictionaries that you can use. There's another runtime way of dynamically collecting a dictionary for your target called libtokencat. You'll find it in the AFL directory. It does sort of the same thing that the link time optimization auto dictionary does, but at runtime it looks at calls to memcomp and strucomp, and I'll pick them up. And finally, of course, you can just go trawling through the source code. And now you know everything you need to know about AFL to start finding real bugs in real software. So here's a collection of 6 different real bits of software and 1 fake bit of software, all of which have bugs in that you can find with fuzzing. Some of them are very famous, like the Heartbleed one and the SendMail one. There's a recommended order that you do these challenges in. They're all in the challenges directory in the workshop folder. But tackle them however you prefer. The libxml one is kind of a classic example of a perfect target, so that's where it's recommended as number 1 on the list. Within each challenge folder, you'll find a trio of markdown files, readme hints and answers. Read all of these, I recommend, sort of before the end of the workshop if you think you're not going to come back to it, or at any rate whenever you think you're finishing with the workshop. have a read through these different files. They'll give you a lot of different suggestions on how to approach fuzzing real-world software. As we do the workshop, start with the README. Read the README for whatever challenge you're doing. It'll tell you what the target is and set you up with how to compile it. If you get stuck or you just want to speedrun the challenges, then read the hints file, which will give you some further guidance on how to make a test harness for this target and where to focus on within the target, that kind of thing. Maybe how to fuzz it, like what runtime options to use for AFL. And then finally, if you want to see an example test harness and the details of the bug in some cases, then open the answers file. But like I say, don't beat yourself up on reading the answers. They're all there, intended to be read. So don't. It's up to you how you want to learn. If you learn best by solving the problems yourself, then stick to the README and maybe the hints. If you want to read through it all and then go back and try and implement what you've read, then read them all. So we're going to spend a significant amount of time on this. I don't expect anyone to finish all of the challenges. There's more than we would normally get through in the workshop. Obviously, you're free to carry on your own machines post-workshop. After some time working on these, I'm going to come back and we'll go through some more advanced topics in using AFL and finish the presentation component of the workshop. And then if we've got some time left at the end, I'll stick around in Discord and we can carry on doing the challenges. Welcome back. Let's carry on. I'm going to do some more guidance that's going to help you with your fuzzing. So first topic is finding error conditions that don't lead to crashes. We already talked about sanitizers to turn tiny memory corruptions into definite crashes of the harness. There's some other things we can do too. So the crux of the technique is you find some automated way to detect the problem in your program and then you crash. So you think of some bad thing that can happen in your software, a user's able to elevate their privilege somehow. If you can concisely check for that within your software that doesn't require human intervention in any way, then you can run that test after processing the test case or during the middle at multiple times, however it works. And if you detect the bad thing has happened, then you just assert and cause the harness to crash. So here's a few examples of where you could do this. One is you're writing a maths library or crypto library. You create a fuzzer for all the different APIs, and it runs the test case on your new library, and it runs it on some existing library. Pick OpenSSLs, your languages, standard library, whatever. And it asserts that the outputs from these two operations are the same. If they're not the same, you've got a bug. You don't know where your bug is. It's either in the library you've just written or the library you're comparing against. But either way, maths is absolute. So if a given input leads to two different outputs, you know you've got a bug somewhere. You can find invariants within your own software, like this next example here from OpenSSL. The square of a number is defined as the number times itself. So if you've got two different routines to implement that, you can just assert that the square of a number equals the number times itself. They used this to find that CVE there in OpenSSL. Shell shock is another famous bug from a few years ago now. I don't think this was found through fuzzing, but it's an example of the kind of thing you could find. This was where environment variables within Bash were parsed improperly or handled improperly. So you could have found this by writing a test harness that asserted there were no writes to the file system, and then used the test cases as inputs to environment variables. And people did reproduce this using fuzzing and I think found other bugs too that were related to it. So just to repeat, come up with conditions that you can think of that are bad conditions in your software and turn them into crashes manually. And then your fuzzer can suddenly discover them. Okay, some collection of extra tips. If you've got a network target, something that's listening on the network, AFL can't fuzz that natively. So the easiest technique often, certainly the most generic technique you can say if you've got a network target, is to turn it so it's not a network target anymore. Write a wrapper that listens to standard in or a file rather than the network. Some programs have an inetd mode, which is like an old Linux operating mode where they were already configured to listen on standard in because the operating system would convert the network call into standard in for you anyway. So if your target has inetd mode, then that's great. You can just run it in that mode and AFL will work natively on it because it's listening on standard in. And final option here is dynamically intercept network system calls using a tool like Preeny so that your target thinks it's listening on the network, there's no actual software changes there, but in practice those read functions are reading from a file instead. I think I've already mentioned this one. You have to disable checksums in whatever form they come at, or else your fuzzing won't progress very far. The Q directory has uses beyond just AFL's internal use. After a long fuzzing run, the Q directory ends up being an amazing corpus of test cases that lead your program to do different behaviors. Every single entry in there causes your program to run in a slightly different way. You can be imaginative and think of uses for these. The baseline use for this Q directory is to do coverage analysis on it, so that you can see what parts of the program you fuzzed and what parts you haven't fuzzed, and therefore give you some ideas as to, is there some configuration of this target that I need to change so I can hit these other bits? Is there some blocker that I can get rid of in the source code? Coverage sanitizer is LLVM's coverage tool. gcov is another one. Beyond coverage, you could just use this as a big set of automated test cases, regression tests if you like, that your CI line just runs for you in case at some point you introduce a bug into your software that these existing test cases cover. But beyond that, see if you can think up of uses for a large, diverse set of input files that exercise your software in different ways. Another tip here, if you interrupt a fuzzing run, just with Control-C, you want to go back to it, then you can run the same command line, but instead of saying the input folder is this input folder, just use this -i- notation, and AFL will bootstrap itself back up to where it was last time. Its design is to be robust rather than fast, so if you do Control-C and then resume with this, you won't immediately be back where you were. You have to wait whilst it runs through every single test case in the Q directory. And it can do that so it can handle changes in your binary. You can recompile the binary in between doing this. I said we're not going to cover triage in any great detail, but here are some very brief tips. So address sanitizer traces can be helpful. They'll give you more information than just, there was a seg fault. AFL tmin is a really cool tool that comes with AFL. It will take a test case and it will try and shrink it into the simplest, easiest to read form of that test case that still leads to the same execution trace as the original test case. So if you've got a bug, you've got some crashing input that AFL has found, or indeed from any source, some crashing input for a target, if you run AFL tmin on it, you will end up with a much easier to understand test case. We've already mentioned that the AFL's unique bug counter does not identify what humans consider to be unique bugs. So if you can, perhaps the easiest, or at least the most effective way to tackle this and actually understand how many unique bugs you have is to fix them as you go along. So AFL has found a bug, you fix it, you carry on fuzzing, and repeat ad infinitum until there's no more bugs found. That way you don't have this challenge of, I've got 1,000 crashing inputs, what bugs do I fix? How many bugs do I actually have? You might have come across this already with ASAN enabled fuzzing. You need to tell AFL what the limit on the amount of memory your target is allowed to allocate. If you're using ASAN, the easiest way is to tell it you have no limit, because ASAN requires it to sort of virtually allocate a vast amount of memory. But there is a risk with this. Your target program might allocate a vast amount of memory, and then your system will become unstable. And that's not what you want. So usually you want to use a memory limit when you're fuzzing if possible. It'll protect you against this system instability risk. But it will also lead to false positives, because an input could legitimately cause your target to want to allocate a large amount of memory, and AFL will stop it and it will crash. If you do end up with a big collection of crashes, then you can write some scripts to improve the experience of triaging these crashes. There's some steps you might want to run through with every single test case, like get the input and the output from the program, run it with different sanitizers and collect those outputs, get a backtrace from GDB, that kind of thing. So a very common question with fuzzing is, when do we stop fuzzing? When is enough? And this is a big challenge with fuzzing compared to any other kind of testing you're doing where you know when you're finished. My preferred answer to this is never. You've never stopped fuzzing. You've never finished fuzzing, rather. Allocate an amount of resource towards fuzzing the software that you're developing. And as the software changes, you just keep fuzzing it. Obviously, that's not always a realistic answer. And if you're in a different circumstance, like you're fuzzing someone else's software as part of a pen test or something, you need to decide you've finished at some point. So AFL has a built-in indicator that suggests you might be finished, and that's the cycles counter. When the last new path found was several cycles ago, and there's no pending path, AFL doesn't have anything on its to-do list, it'll turn that cycle counter green, and you can use that as a suggestion that maybe fuzzing isn't going to find anything else. It's certainly not always true. There's multiple cases of bugs being found months of fuzzing after those conditions hit, but it's an indicator that you can use. If you want to stop earlier than it's gone green, it hasn't gone green, and you think you've been going for a very long time, there's an intermediate stage where it goes blue, which it goes blue when the last new path was over a full cycle ago. Is another indicator. Oh, sorry, there's some other conditions before it goes blue as well. It has to have met some minimum amount of fuzzing. You can also look at the output of AFL plot. It's a really nice little tool that will show you the progress of your fuzzing campaign over time, and just use your intuition to try and decide whether you think now is a good time to stop or not. Before you do stop, make sure you check the coverage of all the files in the Q directory. See what parts of the program you're hitting, and then use your judgment to say that, yes, I'm content that we've at least fuzzed all the bits of software that I consider to be interesting. Or vice versa, you identify some functions that aren't being hit, and then you have to work out how to hit those. So let's talk about some limitations of fuzzing in general compared to other means of testing. So we just talked about one of them. It's hard to know when to stop. You can keep throwing money and electricity at this problem, and there's never a clean time when you can say, okay, now we're done. It only tests, if you're doing fuzzing, it only tests exactly what you tell it to test. It's not like a magic box that you can throw software into and it tells you, good, I've tested the whole software. It tests what your harness tests, which is the target in its exact configuration, and the exact mechanism through which you feed your inputs into the target. There could well be lots of other bugs that aren't being exercised simply because of the configuration of your harness. There's also some categories of bugs that fuzzing probably won't find, and we talked about the checksums before, but there's no guarantee that fuzzing will lead your target to explore its entire state space. It's pretty good at exploring state space that you never would as a human tester, but it's not necessarily going to get it all. And then finally, another one that we've also touched on, fuzzing will only catch errors that your harness can detect are errors. You might hit lots of problems with your test cases that a human could look at the output and go, oh no, what a terrible security vulnerability. But if your target doesn't crash, then the fuzzer will just breeze on by and you'll never notice. So that's limitations of fuzzing in general. AFL specific limitations to do with this tool. So it only looks for crashes. I just said that fuzzing in general will only find crashes. That's not true. Fuzzing in general will only find conditions that can automatically be detected. AFL's case, that is crashes. AFL will only send test cases via standard in or files. You have to work around that with your harness. AFL only runs on Linux or OS X. There is a Windows fork of AFL called WinAFL. I understand it has some challenges with latest versions of Windows, but I've never used it. AFL++ also includes Chemu mode and a Wine integration for that, which is pretty cool. So if your target runs under Wine, then you can use Chemu and Wine. It'll be slower for sure than running it natively, but you can still fuzz it. AFL is designed around the assumption that you can build your target from source. Now, these days there are actually lots of other mechanisms that come with AFL++ that allow you to fuzz binary-only targets. There's a README on this within the docs. Chemu is the kind of the default mode. I believe you can get pretty good performance with Chemu, and its persistent mode. Only like half the speed of native fuzzing, something like that, which is pretty cool for being able to fuzz targets that you can't compile. And there's some other options that are significantly slower, but they will work for non-Linux targets as well, like Unicorn and DynamoRio. So AFL, we're going to get stuck on magic values. Again, not quite the same as checksums, but just like magic bytes, for example. And we've talked about some different ways to do this. There's some links here. Auto dictionary that comes with AFL Clang LTO, libtokencap to find them dynamically, laugh intel, I haven't talked about yet. That's a cool optional feature within AFL++ that you can turn on that breaks down multi-byte comparisons into a series of single byte comparisons, which essentially allows AFL's built-in mutators to discover what these magic values are. So I recommend reading about that. It's really quite cool. Doesn't come with much performance impact, really. Yeah. So the coverage guided instrumentation of AFL helps it explore the state space of programs, but it won't help the fuzzer find certain crashes. So whilst it might execute the code paths, that's what the coverage guides it towards, if you see like this little snippet of code here, which can lead to a divide by zero if input is 1, 2, 3, 4, the instrumentation gives AFL no indication that 1, 2, 3, 4 might be of interest compared to 1, 2, 3, 3 or 1, 2, 3, 5. So that the only way it would hit that is just pure chance. And we talked about parallelization with AFL. There's nothing built in there, or rather what's built in is quite limited. So you have to do your own thing, which can be a pain. Let's talk about what makes a good target to fuzz and what doesn't. So here are some attributes of potential targets that make them likely to be good things to fuzz. Parsers in non-memory safe language is the canonical thing you want to fuzz. A C or C++ bit of code that is dealing with untrusted input. It's been the source of countless vulnerabilities over the past like 30 years or something, and it's really what fuzzing was built to handle. Other things that might make a particular bit of code a good target, if it's legacy code, might well not have benefited from modern approaches to writing and software and testing software. So you might well find a good cache of bugs in there. New code hasn't been tested very much, good target. Complex code, likely to be hiding bugs. It's hard to write complex C or C++ code correctly. Code with a history of flaws, it's obviously a good indication that there might be more bugs in there. Code that no one else has looked at before, again, fuzzing is gonna find you bugs. If you fuzz something that's never been fuzzed before and it has any of these attributes, you're very likely to find bugs. So what about what doesn't make such a good target? Keep going on about C and C++. You can fuzz memory safe code, and indeed people do a lot, because denial of service is a real concern, and you don't want your software to crash. With memory safe code, a crash usually just means a crash. It doesn't mean you're going to suddenly have root on someone's system. So the implications of finding this kind of bug are far less severe than with memory unsafe code. But nonetheless, fuzzing memory safe code is likely to find you less bugs and less severe bugs than fuzzing memory unsafe code. It's probably not worth, especially as someone new to fuzzing very popular pieces of open source software. So I've given some examples here of bits of software that really have been fuzzed pretty damn thoroughly. Not saying there's no bugs in there that you could find with fuzzing, it's just unlikely that you, with a limited budget and a limited amount of time, both time and money, to invest in fuzzing, you're probably not going to find bugs in this kind of target. Is it worth fuzzing test components or non-production software? Maybe, if you're interested in doing that, but you're not going to find security issues, most likely. Anything that would normally be considered a security issue, if it's in a bit of test software, well, who's going to exploit that bug? It doesn't really matter that there's a security bug often. And then I threw this last one in. I was trying to think, is there any software that doesn't take an input? Because if it doesn't, then you can't fuzz it. And I thought, well, what about the date tool on Linux? You just type date and it tells you what the time is, so it's got some kind of kernel input that tells it the time, but maybe not much else. Anyway, it turns out that's not the case at all. Date has all kinds of inputs from environment variables and command line switches, and indeed has had security vulnerabilities in the past. So if you can think of some software that doesn't have an input, then it's not a good fuzz target. But most software has some kind of structured input. So where to go from here? You now know how to fuzz software with AFL. And if you're not comfortable with it, hopefully you will be by the end of the workshop. And the best thing you can do is just to start fuzzing software. So if you're writing software, write a test harness around it and use AFL to fuzz it. Doesn't have to be across lots of machines or across lots of cores. Just run it on your own machine, do some fuzzing. Ideally, check that test harness in and get it to run in CI for some period of time. If you're reviewing something, if you're reviewing a colleague's software, and you think maybe this is amenable to fuzz testing, write a little fuzz test harness around it. Run it for half an hour, see what happens. OSS Fuzz is an initiative by Google which allows open source developers to utilize Google's massive compute infrastructure for free. They run their own fuzzers on a large list of open source software. You can write an integration for open source software, whether it's your own or someone else's. You can submit a PR for someone else's software to integrate it with OSS Fuzz, and if they find bugs, they'll report them into your issue tracker, and you can fix them. They've even included OSS Fuzz integrations into one of their vulnerability reward projects, so just the act of creating a high quality integration, it can be eligible for rewards. I suspect at this point most of the software that they care about has already been integrated, but if you find something that doesn't have an OSS Fuzz integration and you think the security of this software is important for people at large, then that's definitely an option. I mentioned this right at the start. The other contender for best fuzzer, best general purpose fuzzer, is libfuzzer. It becomes part of LLVM. It has a different approach to fuzzing. You write your test harnesses in a slightly different way. You just write, rather than your main function being the harness, you write a dedicated LVM fuzz1 input function. And it has kind of two main advantages over AFL. One is that it's faster because it's all in process. It doesn't fork a new process all the time. So it's kind of like AFL's persistent mode, but all the time. And the other is that it's more well suited for integration into automated pipelines because it crashes on the first, or it stops executing on the first crash it discovers, rather than AFL with its nice interactive text UI. LVM or libfuzzer just runs with very little output until it finds a bug, or doesn't, in which case it just carries on. So definitely worth checking out. I mentioned OSS Fuzz. The test harnesses you have to write for OSS Fuzz are libfuzzer test harnesses. Okay, and that's all I've got to talk about for today. Before I go through this list of resources that you might find useful, I'm going to highlight the thing in red. Please go to this URL. I'll paste it in Discord as well. Your feedback helps me make this workshop better. If there's anything you liked about this workshop, you can probably thank past attendees for their feedback for making it good. Okay, so where can you learn more if you want to learn more? I've already mentioned AFL's documentation. It's really good. It's probably your first place you should start if you like this and you want to learn more about it. libfuzzer, there's some links there, and people have done tutorials and workshops on how to use that. This video I recommend. Give you a good overview of how one experienced fuzzer uses AFL at a fairly large scale. There's a mailing list where you can ask questions about using AFL and search and find other questions that other people have asked in the past. There's this Smart Fuzzer Revolution talk, which gives you a nice idea on what's happening in the world of fuzzing and the move towards structured fuzzing. This Fuzzing Art, Science and Engineering paper is like a systemization of knowledge paper that covers a lot of the advancements in fuzzing over the past few years. If you're interested in the academic side, this is the best place to start for sure, rather than just searching Google Scholar or whatever for different papers. There's lots of papers on fuzzing. This is a nice coagulation of them into one place. There's a fuzzing book, free open online book that has broad coverage of the fuzzing topic, so not just AFL or libfuzzer, but fuzzing in general. There's some more challenges if you like these challenges and you want to try and fuzz some other targets and see if you can find the bugs. Then there's a link there that'll take you to some. For more information on how to triage the crashes you find with fuzzing, there's a link there to a blog post that someone has some good guidance on how you might approach that challenge. And then here's links to ClusterFuzz and OneFuzz for if you want to deploy a lot of compute resources or expose a nice, relatively easy to use interface to other people within your organization for doing fuzzing on your own infrastructure. These two options are your best bets. And that's everything. So the workshop doesn't end just now. If you're finished, then I hope you enjoyed it. If not, carry on working on the challenges, and we'll be there in Discord to the end. Thanks very much. And welcome everyone. Thanks for joining. This is my first virtual workshop. I hope you enjoy today and come away with a useful new skill. Alright, so this is the Fuzzing with AFL workshop. You're going to come away from today knowing what fuzzing is, knowing what AFL is, American Fuzzy Lop, the tool we're going to be using, and being able to use it to fuzz the programs of your choice. So what's the agenda? We're going to start off with an intro to fuzzing and what AFL is. Then we will start with fuzzing a little toy program, not a real program, but just to see how the tool works. And then spend a little bit more in-depth time looking at what happened there and how test harnesses work in general, so you understand the mechanics. Then I'm going to talk quite a bit about the practical aspects of AFL, the different options you've got, the different challenges and how to overcome them. Then we're going to start doing some challenges. So these are a set of real-world vulnerabilities that have been pulled together for this workshop that you can rediscover with fuzzing. So these are CVEs in software from 2000, I think, to current day. And together we'll rediscover these vulnerabilities using AFL. Then we'll sort of wrap up with a bit more of me talking. I'm going to cover some of the more advanced topics of using AFL, point you at a lot of resources for where to go if you want to carry on learning, and then that'll be the end of the presentation material, but it won't be the end of the workshop. There'll be another hour or so where you can carry on with the challenges, and I'll be available in Discord to continue supporting that. So what are we not going to cover? The history of fuzzing is interesting, but we don't have time to focus on that today. Fuzzing targets that you don't have the source code to, or that only listen on the network and you can't modify them to listen via some other mechanism. Both possible, but not the focus of today. Today we're going to focus on open source software that you can modify, or software within your own companies that you have the source code to. We are going to be looking at specific techniques that are highly focused on individual targets. You can obviously get good results by tailoring your approach, your approach to fuzzing in a deep way to your target, but we're going to be looking at generic mechanisms that will work across a broad range of targets. To that end, we're also going to stick to AFL, which is a generic fuzzer for fuzzing a lot of different targets, and a little bit of libfuzzer as well. And I'll explain why we've picked that in a bit. You can find a lot of bugs with fuzzing on your machine. If you want to find the most bugs with fuzzing, you do need to expand onto lots of different machines, scale your fuzzing. It's kind of linear. It's not linear at all. But the more machines you have fuzzing, the more bugs you're going to find, straightforward. It's a big topic, and there's lots of different options. I'll highlight some of the options and the good approaches, but we won't actually practice with doing that today. Once you've found bugs with fuzzing, you need to understand how serious they are. Are they exploitable? If they are, what can you do with them? That's the whole topic of crash triage, which then follows on into exploit development. We're not covering that. It's nothing to do with fuzzing specifically. It's a generic topic. It's an important one to learn if you do want to go more than I've found a bug, if you actually want to understand the details of that bug. And then finally, we're not going to cover cutting edge research in fuzzing today. Okay, so a bit of background to fuzzing and why it's useful. As we go through this, if you've got any questions at any stage, just ask them in Discord. We have to wait to any particular moments, though I will inject a few pauses from time to time to give us a chance to catch up on questions. So at a very high level, any software can be thought of as a function that takes some input and gives some output. It applies to any different scale of software, your PowerPoint presentation software all the way through to a couple of lines of code. There's some input and there's some output. As we know, sometimes an unexpected input can lead to a security flaw. It's quite hard to identify what those unexpected inputs are or if they even exist. The entire multi-billion-dollar security industry exists because that's a hard problem. There's lots of different ways to try and find bugs in code. There's some categories here on the screen. Dynamic analysis is one such category where you look at a running program and through your looking at it, you try and determine if there's a bug there. A security bug in particular is the type we're most interested in. Fuzzing is a type of dynamic analysis. So you run your program And at its simplest, you run it with some random input and you see if your program crashes or not. If it doesn't crash, you run it with a new random input. If it does crash, you found a bug. So that's all fuzzing is at a high level. Random inputs, see if it crashes. It's surprisingly effective. Like even at that really, really basic level, truly random inputs, just see if your program crashes. You can find a lot of bugs. Certainly you could find a lot of bugs in the past before fuzzing was a broadly applied discipline. So it's evolved a lot from its initial form of literally random inputs and seeing if it crashes. But that's still the core of what everything that we're going to be doing today. So in a bit more detail, how do you go about fuzzing a program? First of all, you've got to pick what software you're going to fuzz or what part of a particular program you're going to fuzz. Work out what your inputs are to this program as part of the program. Pick a tool that's going to help you do the fuzzing or write a tool. Make your tool and your target that you've selected work together so that your fuzzer can actually fuzz this specific target you've picked. Fuzz for a while until you've decided you're finished, and then triage all the results. So this is what we're going to be focusing on. A little bit of target selection. We're going to learn about what makes a good target for fuzzing and what doesn't. And then the core focus is on identifying what these inputs are we're going to fuzz, connecting them up to AFL, the fuzzer, and doing the fuzzing. The picking a tool bit, I'm going to suggest you use AFL, and again we're going to come to that. And I've already mentioned the triaging that we aren't going to be doing. To expand a little bit on that, one of the great things about fuzzing is if you found a crash, that's irrefutably a bug in almost all cases. You have some input and the program crashes. You've got a bug. You can use your usual debugging techniques to work out what that bug is and how serious it is. But unlike a code review or a static analysis tool that says, I think this might be bad, here you've literally got an input that crashes your software. So to some extent, triage is less important depending on who you are in the role. If you're an exploit developer, you're trying to find a bug so that you can exploit this bit of software, triage is critically important. If you're a defender and you're just trying to improve the assurance of your software, triage is less important. Find the bugs, fix any bugs you found, fine. Whether they were exploitable or not, now you fixed them. So what is fuzzing good for? Fuzzing will find you bugs that can be triggered by some input and lead to some crash. That input probably has to be in some kind of structured form or some kind of data, as opposed to someone clicking a mouse, because it makes it easier for the software to generate it. And in particular, what fuzzing is good at is running a lot of tests, far more than any human will run. We're talking tens of thousands of different tests per second. There's a big list of examples here of different types of software that fuzzing has found bugs in, and you see that they fall into this category that they all take some kind of structured input, and a crash is usually considered a bad thing in any of these. So American Fuzzy Lop, AFL, here's the blurb. I'm not going to read it. This is the blurb from the original author of the tool. But some bits that are worth talking about. It's a security-oriented fuzzer. You can fuzz for different categories of bugs. Fuzzing is most well known for finding security bugs, so it's particularly good at that. And this tool makes trade-offs that focus on finding security bugs as opposed to other categories of bug. It says it's a novel type of compile time instrumentation here. In 2013, the end of 2013, about 6 years ago, when it was released, that was true. It was novel. It's no longer novel. Lots of other tools have copied this type of compiled time instrumentation, but it's still a good one. Uses genetic algorithms, fine. And it finds clean, interesting test cases that trigger new internal states in the targeted binary. And I'll expand on that in a second. So yeah, it's known as AFL or AFL. A technicality, if you like, the original AFL is no longer maintained. Elgam Tuft, the original author, stopped working on it a couple of years ago, and now AFL++ is like a community fork of the tool that is maintained. So that's what we use when we talk about AFL. It's actually AFL++. And why AFL specifically? It's the joint best general purpose fuzzer. And these days you can have a debate about that, and you might have a preference for a different one, but it's certainly up there as one of the best general purpose tools for fuzzing C, C++, and Objective-C programs. What makes it the best? There's kind of two categories. It's effective, it's a good fuzzer, and it's easy to use. So what does effective mean for fuzzers? It means it's fast. That's a critically important attribute for any fuzzer, is how many test cases per second can it run for a given target. And it's also clever, so it picks its test cases to run against the target with a very cunning algorithm. And it does that trade-off pretty well. Speed is sort of supreme when it comes to fuzzing, but if you can pick your test cases well as well, then great. And then easy to use is really important, especially if it's your first fuzzer that you want to use. And AFL really shines at that. Provided you have the source code, then you can write a test harness for your tool, and AFL will just fuzz it for you and give you some good feedback on what it's doing. The other primary candidate for best general purpose fuzzer in this category is libfuzzer, which is part of the LLVM toolset. It's another great tool inspired by AFL, uses similar algorithms, but it has a different approach to test harnesses, and we'll talk a little bit more about it towards the end, but it's another one to keep in mind. Okay, so this is the densest slide in this workshop. You don't have to worry if you don't follow this, and I'm not going to spend a huge amount of time trying to explain it, but just to give you an overview of how does AFL do what it does. So it's a coverage guided fuzzer. We saw in the original blurb, it used a novel type of compile time instrumentation. Well, that instrumentation tells AFL about the code path that is executed on any given test case. So AFL runs the target with a test case, and it observes what basic blocks within the program get hit, and how the flow travels between those basic blocks. It uses that knowledge to inform what test cases it's going to run next, and it favors higher coverage. So if it sees a test case that hits a new basic block that has never been hit before, a new statement, say, in the program, or hits it via a different route that hasn't been reached via before, then it will consider this new input an interesting input, and it'll use it in the future as part of its genetic algorithm in creating new inputs. Yeah, it's going to skip entries that provide a subset of coverage. So if it runs a test case and it sees this test case led the program to do nothing new compared to previously, it hit the same set of basic blocks in the same order that some other test case did, then it's going to deprioritize that test case and probably not run it again in favor of more interesting ones. It also prioritizes speed. I've mentioned already once, and I'll mention it a number more times, that speed is really important when fuzzing. So even if a test case is interesting for a target, it hits some new basic blocks. If it's really slow, AFL is going to deprioritize it compared to interesting test cases that are faster. Because we want to run as many tests as possible, and we don't just want to run interesting ones. So it has some mutation strategies. I talked about these new test cases. Where do they come from? You give it some starting set of test cases, at least one, and then it has some mutators that take its existing test cases that it's ran and generates some fresh test cases based on these mutation algorithms. It can splice test cases together, it can just flip bits, and lots of other ones. You can also give it a dictionary. So let's say you're fuzzing something that has a JSON input, you can give it a dictionary and tell AFL curly braces and quotation marks and colons are interesting values for this target. And it'll use that dictionary as part of its mutations. And this is a quote from the tool again. Let you read it. So that's another way of saying that there is no elegant description of how does AFL run that captures everything it does. It is in fact a collection of hacks, but it's a collection of hacks that will find bugs for you. Okay, so before we get on to the workshop environment, let's have a little pause. If you've got any questions on what we've covered so far, ask away, and then we'll move on to the workshop. So this is the focus of today, is actually fuzzing software. There's a pre-prepared environment for everyone who wants to use it. You can edit files directly in this remote environment, SSH in and then use a text-based editor like Nano, Vim or Emacs if you're comfortable with one of those. Personally, I like using Visual Studio Code's remote SSH plugin. You just tell it, here's the host I want to talk to, and then you edit as if it was on your own machine, but actually it's doing all the editing on the remote machine. So that's a good one if you like Visual Studio Code. Or you can edit locally, just like any normal file. There's a couple of options here. You can clone the repo and edit using your preferred text editor and then SCP it across or rsync it across. Or just use Git, so fork the repo, make your changes locally, push them up to GitHub, and then on the remote machine do a Git pull and pull them down that way. So lots of different options depending on what you want to do. Or if you don't want to use the virtual environment that's been prepared and you want to run it locally, then you've got a couple of options here. Run the Docker environment on your own machine if you've got Docker installed. There's a command line there that you can copy. Or if you want to install all the dependencies and stuff on your host, then just clone the repository and get going that way. I can't offer support for that scenario because everybody's host is going to be different, and it's not a good use of my time today to do Linux debugging challenges for everybody. So I do recommend you use either the prepared environment or local Docker environment, whatever you prefer. And those are the ones I can support. But the list of dependencies for using AFL++ is not that large. So if you do want to set it up locally, then by all means go for it. So I'm going to send you all via DM an IP address and a password. So if you check those now, and then you should just be able to SSH in as the fuzzer user. And we're going to get started with the first practical. So this is the quick start practical. All the instructions are in the repository. Take a look at them under quickstart/readme.md. And fuzz your first program with AFL. AFL is already installed in the environment, so you don't need to do any of the compilation steps for AFL itself. You just need to compile this quick start binary under AFL and then fuzz it, see if you can find any crashes. Okay, let's have a pause on the video. We'll get back to you in about 10 minutes. Okay, let's do a walkthrough of the quick start. So, got the quick start readme up. Right, so that works. So what actually happened here, I told make to build the quick start program, and I told it to use this compiler instead of its normal built-in compiler. This is a compiler that's installed on this system. It's the AFL version of Clang, the LLVM Clang compiler, which just has some tiny changes in it that allows it to instrument the program that we compile. We also told the compiler to do some basic hardening modifications to the program as it compiled it. Things like putting a stack guard on. It worked. So let's run it. Cool, and it compiled. The vulnerable program tells me that it's got some features, so I can uppercase bytes. Oh, I cannot. Okay, that's because it's looking at it. It's treating these as bytes, I think. Let's try a pre-prepared one. Alright, the pre-prepared one worked. Okay, a single digit perhaps. Oops. Uppercase. Okay, well clearly this program is full of bugs and it's not doing what it tells me it's going to do, but whatever. Wow, yeah, it's full of bugs. However, so we've got this inputs folder with some pre-prepared inputs in it. The one I just tested was this one. And for those of you not familiar with this syntax, it says run the program vulnerable, and its standard input, replace that. Instead of the normal terminal standard input, we're going to give it the input from this file here. And so it takes this input, runs it through the vulnerable program, and the vulnerable program outputs this. Fine. Let's look at the head input. Okay, fine. This one looks like it's maybe a bit less buggy. Anyway, so there we go. There's a tool. It works-ish. Let's find some bugs in it. So we compiled it with instrumentation. Scroll down to the instructions. Let's see. We already have some starting inputs, some seed inputs that will give AFL a head start on how to run this program. We're going to tell AFL to use an out directory and fuzz this vulnerable program. Off we go. Oh no. Oh yeah, thank you, AFL. So that's AFL telling us we've got a crash handler set up and we don't want it. So I've just disabled that in the background. Your environment shouldn't have that. All right, we are fuzzing. And we found a crash. AFL thinks we found 4 unique crashes. That number is climbing. It hasn't actually found 5 unique crashes, but we'll come to that in a bit. Let's see, how many instructions per second is it doing? It's doing about 4,000 here on this single core. Good, either way, AFL is running the vulnerable program with lots of different inputs. It is finding crashes. So let's call that done. Control C to quit out. And let's take a look at what AFL found. So we told it to use the out directory. Actually, let's open them in VS Code. It's not open in VS Code. Oh, here they are. 7 different crashes, 4 different IDs. Let's look at the first one. Okay, apparently if you run the vulnerable program with this input, it's going to crash on you. What's that? 7 8s. Let's see if we can reproduce that. Head 1, 2, 3, 4, 5, 6, 7. Oop. Oh yeah, sure enough. So we got a seg fault and some address. So there's some kind of memory corruption going on inside this vulnerable program. And if we go and look at the code for it, we might be able to work out why that happened. Find the head function. Where's the head function? There it is. Yeah, it looks like we're going to pass this test. Okay, and it looks like there's probably a bug here. Looks quite likely that this input here is not being validated at all, and then we're just using it to write to an address in memory. So we found a real bug. Well, an artificial bug, because I wrote that bug in. And if we wanted to reproduce that without typing the input in, because we'll find that there's various crashes AFL will find with some crazy input files that you don't want to have to type out by hand, we can just use this input redirection feature of bash again and run vulnerable with that input, and we see the same error. A little tip, if you're trying to do this, I find it a little bit easier to just specify the number here and then put a star, so that way I can easily run it with different inputs without having to type out all the different details in the file name. So you can see there's a few different behaviors of the crashes here. Looks like all of these are pretty similar. There's a different one. This is a Stack Overflow this time instead of a seg fault. So triaging these crashes, leave as an exercise to the reader. You can go and find out what these bugs are in the vulnerable program if you want. All of your reproducible inputs live in this crashes folder. And that's that. Let's take a moment to look at this status screen in more detail, because you're going to be spending a lot of time looking at this, and it has a lot of important, interesting information on it, and it has a lot of curiosities on it that you can largely ignore. So, very top here tells you what program you're fuzzing, in case you're fuzzing multiple ones. This overall data and the process timing here is useful to know about. How long you've been running for is important, and these two, the last unique path, the last new path and the last unique crash, are super important in trying to work out whether you've finished fuzzing or not. We're going to come back and talk about that later. Up here, overall progress. A cycle is a complete loop through all of the inputs, all of the mutations that AFL wants to do, and it will test not just all of the inputs it's got in its initial folder, but it'll also test any inputs that led to a new path. And once it's done all of those and it's exhausted all its new paths, it calls that a cycle done, and it'll go back to the beginning. Total number of paths, unique paths it's found through the program. So it may have tested thousands of different input files, but all of those thousands of different input files only led to 15 different ways of execution through the program. It's also found what it thinks are 5 unique crashes. It's definitely found a number of crashes, and its own heuristic thinks that there's 5 unique crashes. So unique here means took a different execution path through the program than any other crash. It doesn't mean what a human means when we say there's a unique bug. And it's extremely difficult for software to identify unique bugs when we mean human unique bugs. But it's a useful-ish metric. It depends on the program and on the crash. In this particular case, it's definitely identifying the same bug via different paths. There's not 5 unique bugs that I'm aware of in this vulnerable program. Hangs, it also has a little timeout. I think it's, I forget the time now, I think it might be 1 second, after which it considers the program to have hung, and it will record that. And they all fell into one of 5 different buckets of different paths that they went through the program. And then the final area that's particularly interesting is here. The total number of executions, we're up to 60,000 here, and the execution speed in number of test cases per second. This is super important. The total executions is useful in the knowing when to stop indicator, and the execution speed is something you're always trying to maximize as you design your test cases and pick your targets, because the more test cases you run, the more likely you are to find a bug. Okay, everything else is not too important. If AFL thinks something is important, it will highlight it in red for you. So it's found some crashes. This is highlighted in red as an indicator that something might be wrong. In this particular case, nothing's wrong. It's just we're fuzzing an extremely trivial program, which is sort of out of the norm for what AFL considers should be the usual case. You can find out all about this data screen in AFL's docs, which we're going to come to. They're really good for learning about the interface and indeed how to use AFL. Yeah, so just to recap, important stuff under process timing, important stuff under overall results, findings in depth, somewhat interesting, stage progress. We're not too concerned about the first 2 bits, but the total executions and the execution speed, very important. Everything else, largely ignore unless AFL tells you to pay attention to it by making it red. So now is a good time for questions about that quick start process that we just ran through. You also might want to consider some of these questions. In particular, what would have happened if AFL didn't have that head seed file? You can experiment with that if you like, just delete the file, move it out of the inputs folder and rerun AFL. See what different behavior you get. Will it still be able to find the bugs associated with the head functionality of the program? And if it can, how will that differ? And then if you look in the vulnerable source code, in the vulnerable.c file, you'll see there's an Easter egg in there. How might AFL ever find that? Is that something we can find with fuzzing? What are our options there? And don't worry if you don't have time to consider these questions, we are going to come back to the answers to these later on. Okay, let's talk about test harnesses. So most programs that you want to fuzz, you won't just be able to do what we did with the Quick Start program, which was compile it with the AFL compiler and then run AFL fuzz on the program. Because AFL has some particular requirements on the format of the program, how it behaves, so that it can get its test cases into the program to be properly executed. Most of the time you're going to have to write a test harness for that program, which is like a wrapper around the code that you want to exercise, that you want to test, that will allow you to hook up AFL to your program. So what does a harness have to do? It has to do all of these things that are listed.
Welcome, everybody. Thank you for your time, and we're very excited today of all the activities that we have this week and going into the weekend at the GrayHat conference, and especially the Red Team Village. With me, I have Philip Wiley. And Philip, why don't you go and explain some of the activities and the briefings that are happening in the Red Team Village today?
Hi, Omar. Hello to everyone. We're looking forward to this. It's going to be a great conference this year. I'm really looking forward to the talks that we have on day one. It's a really great way to kick it off. We have George Orchias and David Maynor doing their talk, External Threat Hunters and our Red Teamers. We're also, another one that's really exciting is Savannah's talk on You're the Weakest Link, attacking organizations through the human element, some social engineering there. So we've got something for everyone. We've got 2 CTFs in the Red Team Village. One of them is being hosted by HackerOne. It's a bug bounty CTF for our bug bounty summit that we're offering this year. And we got some cloud talks too. John Helmus is talking about bypassing AWS policies. And throughout the whole conference, we've got like 12 CTFs. So this is really, almost makes you think of something like a DEF CON conference with all we have to offer this year.
Yeah, it is amazing the number of villages and also the number of activities among all villages. Some they have CTF, some other ones they have briefings or both. Some they have other challenges. So it's extremely exciting. And another thing that you also mentioned, related to the Bug Bounty Summit, we have some ad hoc interviews and panels that are part of the Bug Bounty Summit. So I strongly recommend for you to go to our website and get more information about those throughout these 3 days of full of action. Now, can you tell me a little bit more about both CTFs? Why 2, and what are the difference between them and them both?
The one of the CTFs is more beginner level for it's good for all levels, and it's kind of a Jeopardy style CTF. While the one for HackerOne is more bug bounty related. So this would be more similar to what you would see in one of the hacking events that a bug bounty company would host.
Okay. Now, the other thing that I want to remind everybody is that we're having a lot of conversations, and as a matter of fact, started several weeks ago, and a lot of people are excited about the conference and all the activities, especially in the Red Team Village. So we have 2 Discord servers. I know that there's a little bit overwhelming because every village also has a Discord server, but at grayhat.co, so that's the website for GrayHat, we have information about each village and their website, their Discord server, and so on. Of course, for the Red Team Village, is really easy. It's redteamvillage.io/Discord. The GrayHat, the main GrayHat Discord server is, you can go to it at grayhat.co/Discord and also, participate in the conversations. And as a matter of fact, that's where most of the people for the conference are going to be congregating and participating in the chatter, right? So both for the CTFs, for the briefings, GrayHat also has different trainings, that are separate from the villages that are happening as we speak. So with that said, thank you and enjoy the conference. Welcome back. Our next presenters are two good friends of mine, Jorge Orchilles and David Maynor. Jorge and David are very well-known security professionals in the industry and good friends of the Red Team Village. Their talk today is titled External Threat Hunters and Red Teamers. Thank you so much, Jorge and David, for supporting GrayHat and the Red Team Village. The floor is yours.
Hello, everyone, and welcome to our GrayHat talk on external threat hunters are red teamers. I am here with Dave Maynor, who has a lot of experience doing red team and is now an external threat hunter. And we've been collaborating on this for a number of months now, and we'd love to share it with you. This is the first public presentation we give of this talk. How are you doing today, Dave?
Oh, I'm doing great. I'm excited. I can't wait to go through this.
Awesome.
So let's start with the TLDR. Yes, this talk is about actually using red team tools in tradecraft for external hunting, right? This isn't about phishing. These are real use cases for purple teaming that we feel like will be big in the future. Now, what we're presenting to you is a concept that probably most people won't have a use for today, but this is where we see it being in purple teaming going in 12 to 18 months.
Yep, and interestingly enough, this is also very purple, as you said, of where coming from the red team side, you learn these tradecraft and these methods of doing things, and you use a number of tools, and then you start leveraging them as you go into other areas like external threat hunting, which is what Dave does now. So it's been a fun collaboration. So why don't you tell us a little bit about yourself, Dave?
Well, I've been in the security industry for around 20 years or more now, I guess. I started out doing DevOps, moved into exploit development, research, to boutique penetration testing, and that kind of led me to threat hunting now, but particularly external threat hunting is what I'm doing now. I have a lot of history in this area. Most recently, I've been involved in the TrickBot takedown with Microsoft and a number of other vendors. Before that, while I was at Cisco Talos, I ran the threat intelligence group for Europe and Middle East, which means I spent a lot of time tracking advanced actors out of, state-sponsored actors, of Russian, Iranian origin.
Yep, and I saw this week, actually, on Monday, the U.S. finally indicted a number of Russian threat actors for their work in NotPetya, and I know you were heavily involved in that response.
Yeah, no, it was great to see somebody finally do something actually call the people out for what was the most devastating and costly attack in computer history.
Yeah, that's phenomenal work. It's such a pleasure to be here presenting with you. And I'm George Orchilles. I'm the Chief Technology Officer at Scythe. Been doing offensive security for about 11 years now. 10 of those were at Citi. I originally started doing system administration work, then got into offensive security, doing vulnerability assessment, built the pen test team, then red team, and the past 2 to 3 years been doing a lot of purple teaming. So it's really up and very, very similar, always trying to be innovative and talking to others and seeing how they are using various tradecraft to make our industry better. And who better to do that than with Dave. So really an honor to be here with him. So this is our agenda. This is what we're going to talk about today. Like any talk, we're going to bring some basics if you've never heard of red teaming or external threat hunting. We don't know the audience, right? You're all virtual. So we'll give a quick intro on what those are and what we mean when we say red teaming and external threat hunting. And then we're going to kind of compare and contrast the tools and tradecraft of red team with what external threat hunters do, and how red team sets up attack infrastructure and how external threat hunters set up infrastructure. And then using command and control as well as analysis and refinement. So, and we have a demo, of course. Can't do a GrayHat without a demo. So we'll show some stuff off, or actually Dave will show some stuff out. So here we go. Welcome. What is red teaming? Red teaming and the Red Team Journal, which by the way is back. Shout out to them. Definitely follow them at Red Team Journal on Twitter and redteamjournal.com. They've been around since 1997. And to me, they have one of the best definitions of red teaming, which is the practice of looking at a problem or situation from the perspective of an adversary. And really, the red team differentiates itself from penetration testing and vulnerability assessment and analysis and exploit development in that it doesn't only look at technology. It's also measuring people and process. The customer is also different. Generally, the customer in a pen test is the operations team or developers. In this case, it's the blue teams. And a lot of red team efforts are manual. There's a lot of tools that we use. You've heard of offensive security tools. I'm a co-creator along with Bryson Bohr and Adam Mash on the C2 matrix, which is, we'll talk about here, but there's 57 command and control frameworks on there right now. Of course, we always want to automate. Actually, Dave in his demo today that you will see does some automation. So it's fantastic to see. And we do this based on intelligence. We do red team engagements. Really, if you're a consultant, an external red teamer, you're generally called in once a year. Or if you're an internal red teamer, and depending on the maturity in your organization, you might be doing this continuously, like Tim Malcolmvetter, for example, in his organization and others. So that is what red teaming is. Dave, can you tell us what is external threat hunting?
Right. So a lot of people are familiar with the concept of threat hunting now, which is basically just taking a hypothesis and proactively going through your logs in internal data sources to figure out if there's an unknown attacker lurking in your network. External threat hunting is the logical extension of that, where we do kind of the same thing, but not in our network. We're looking out beyond our perimeter across the internet. So we're not just looking for things that may have already attacked us. We're looking for actors that may be interested in compromising us in the future, and using this as a proactive opportunity to learn more about their TTPs and tools, techniques, and procedures, how they operate. So when they would attack us in the future, we've already briefed our purple team on how they operate in different ways to find these attacks. The big difference, though, being you're looking out beyond your perimeter instead of just in your internal systems. I run a team that does this now, and there is no actual end to this. Like, we are constantly doing it. We hunt, we revise, we evaluate new actors. We revise maybe on a quarterly basis, but the hunt never ends for us now. And in addition to just blue, red, purple teams, our information can also be used by corporate officers for risk and compliance, and actually to drive business decisions. Right. So a lot of people will echo chamber of infos that will start off with things like, oh, you don't need to, these are new fancy things. You don't need to do this. You've got to get your basic one-on-one security down. That's completely right. This solution, or what we're talking about, won't be right for every organization. In fact, most organizations, it probably won't be right for. However, it will, for the organizations, there is a maturity fit and a capability fit. This is the next tool in your tool chest, and it will help ecosystem-wise, as large companies that do this find more information about attackers, publish that in the community in general. Information filters down to everybody. So this really will, we feel like, be a driver for ways to get more information in the future about attackers. There's no real easy way to do this if you haven't done it before. And I say a lot, this is more art than science, and that's kind of a failure on my part. But uh, a way to show that this concept is really still in its infancy and is maturing. What we really want is more science than art. We want rigor. We want calculatable metrics. We don't want gut feelings all the time. However, they're very important in this process. Uh, this is kind of hard to quantify for your organizational impact. Uh, However, the ability to forecast after a threat actor trends early and how they will impact your organization does pay dividends in rewards from your risk officers when it comes to things like insurance, your ROI, staffing, things like that. But the real interesting thing here is that when I started hunting bad guys, I didn't come from a mathematical model background or a traditional threat hunting background of intelligence. I came from the background of red teaming, where I would look at a network and say, if I were breaking into this, this is how I would do it. Lo and behold, other people would do that as well, the actors primarily. So my whole evolution in threat hunting has really been driven by a red team perspective, which has led me to using red team tools, techniques, and procedures to better evade bad guys' detections and better to catch them.
When we look at the needs, and here talking with Dave, for months on this, and he obviously has the red team background as well. Red teams have a number of different needs, especially when you start scaling up your teams. And I went through this when I built the red team at City, where at first we were just a couple of folks and we didn't really have much documentation. We didn't have a process. We were just kind of going and getting in and moving laterally, pivoting through infrastructure. And it wasn't until the first full zero knowledge red team engagement when we were doing deconfliction, which is the process of identifying if red team activity is real bad activity or not, that we realized that how important documentation was and logs were. So that's when we started standardizing our tool sets and standardizing our logs and making sure that we were logging everything the red team operators are doing. So as we grew to maybe four people on the red team, you had all four working on a particular item, a particular engagement. Then you were still communicating with everyone. You kind of knew what everyone was doing. But then how do you scale that? What happens when you get to 12, which was the current size of the red team when I left? You're working on multiple engagements at a time. You need logging not only in the tool set itself, but you rather have some central logging where you can see what everyone's doing at any given time. So this became really important to us as red teamers. And it also is very important to Dave and his team, because again, he started doing external threat hunting as a few people, but then you started growing as well, and you needed that consistency, especially when you're going after bad guys, because OPSEC is important in both cases, but we can debate on which one is more important, but definitely very important to be consistent as you go. So when we talk about red teaming, we cover a lot of planning, and that was also the case for external threat hunting. So I teach a 2-day red team course with SANS Security 564, and about a fourth of that class is about planning. And a lot of people don't see that. A lot of people think that red teaming is just going in and getting access to a system and moving laterally and meeting an objective. And they might think the same about external threat hunting. You just go in and, hunt for adversaries, right? But that's not the case. Planning is very important. So as we were talking about process and frameworks, and again, building this consistency up, making sure our teams were following it, we created this little table. And as we do planning for red teaming, one of the first things we have is goals and objectives, right? What is the goal of the red team engagement? Most of the time, this is around gaining business value or giving the business value. What are you trying to prove? Most of the time is what would happen if this adversary were to attack us? How far would they get? What would we detect? Are our people ready? Is there a process for response? And as you do this in external threat hunting and you plan external threat hunting, you also have goals and objectives, right? You are going after a particular threat actor, which leads us to cyber threat intelligence, which is very important for red teaming, and particularly adversary emulations, where we pick a particular adversary that is likely to attack the target organization. It has the capability, the intent, and the opportunity to attack. And then from there, the cyber threat intelligence team provides us the adversary behaviors, the TTPs, so that the red team can then create a plan, an adversary emulation plan, and execute it. Well, in external threat hunting, you also need to rely on cyber threat intelligence. In this case, it's to formulate a target list of adversaries you're going after. But again, you're not just going full out looking for any adversary, you're picking a particular target. And the next thing you start discussing in red team engagement is the scope. What are we going after based on the goals and objectives and to maintain it? And normally red teams have wide scopes, and in your external threat hunting, you also have a scope. When you start planning these out, especially if they are zero knowledge red team engagements, you have an exercise coordinator or a project manager that will manage all the different things that are going out around. You have to manage the senior managers or the sponsors of the engagement. You have to manage the cyber threat intelligence coming in, the red team, the blue team. You have to have the daily coordination calls just to make sure that everything's going well. Same with external threat hunting, especially as Dave and his team scale, they need a project manager there as well. And then we have rules of engagement. Now, we both have rules of engagement. Some are similar, some are not. In red team, you don't want to affect real business processes. So when we emulate ransomware, for instance, we're not going to destroy backups and actually ransom the company and not let them operate. And we're not going to bring down infrastructure. While it's still possible to do that in a way, it's still possible to emulate ransomware in a way that you don't do that. Those are generally the rules. In external threat hunting, you don't get into a knife fight with a threat actor. You don't break the laws, which is also true for red teaming. And never, ever forget the purpose of the exercise. And this is valid both for red team and external threat hunting. And then attack infrastructure. We spend a lot of time in red team talking and building attack infrastructure so that it's resilient, so that it's operationally secure. And of course, external threat hunting does this as well. And then when we're done with our exercise in red teaming, we do analysis and response to see how the blue team responded, if they followed their process, the people followed and did what they had to do. And then at external threat hunting, they also do analysis, but they also do refinement. So here you can see that our planning process is very similar. So we're going to dive into this a little bit more. And Dave, why don't you take us through how you formulate a target list of what adversaries you go after?
The most important thing while doing this is intellectual honesty. Everybody, I feel like most people in security have heard the, oh, well, you know, we're an APT threat, but not real. You know, we're under threat from an APT, but not really. Most APTs will, you know, they have a standing intelligence requirement, right? Things that they'll go after constantly. Like in lieu of, you know, anything else to do, they'll find these types of targets and hack them. And that, you know, if you're one of the orgs like critical infrastructure, telecom, finance, right? You know, it is a concern. A lot of people, you know, the APTs are not realistic threats. However, we're going to focus on the people that is realistic threats for, because those are also the people who will more than likely have external threat hunting teams, right? So you have to be intellectually honest. You got to say, what do I have in my organization? What is it about my organization that would satisfy intelligence requirement for a sophisticated nation state actor, right? If you're in a telco, it's pretty obvious. You have all kinds of information about people's communications, phone, internet, IP, whatnot. Critical infrastructure is the same way. If you can turn off a power grid, that is a computer network attack target for APTs. So you have to really look at your organization. You have to figure out what it is that you have these people or these threats would want, right? So then you have to do enough research to figure out what sophisticated actors are looking for, right? Like so. If you look at the breakdown, for instance, of APT 28, 29, and various other nation-backed entities out of Eastern Europe, right? You can almost do a clean breakdown of saying like 29 does higher value political targets, where 28 can do a variety of less or so political targets, economic targets, and what I would call effect-driven attacks, kind of like NotPetya, right? So when you understand the APTs, these sophisticated actors around the world, you'll be able to take what is special about your organization and what groups are looking for that type of specialness, blend them together. Now, it's worth noting that nation states aren't the only players in this sophisticated game, right? There's some crimeware groups that are very sophisticated, like Fin7, for instance. In addition to that, we're actually seeing the rise of cyber mercenary groups, right? Like groups that don't have a political, or who aren't aligned directly with a nation state, but sell tools, techniques, or procedures, basically murking for cash for whatever they're being paid to do. So in those two cases, the figuring out and the formulating your target list are a little different because Fin7 will have different intel requirements than APT 28, which will have different intel requirements than the cyber mercenary group. Now, you also don't want to just focus on their current capabilities. Or you want to be able to look at where they're going technologically, attack-wise, and you want to be able to not just be able to respond to what they're currently doing, but be able to abstract behavior and apply it, behavior from different groups and apply it to more groups in the future, right? For instance, a new account takeover attack may become popular, and you may see that in a particular group. You take that behavior, you abstract it, and apply it to more groups, and think about how they would respond to it. This is really a long, drawn-out explanation for going. You have to be intellectually honest about your targeting.
Awesome. So, we both build attack infrastructure, and we can talk literally for days on how to build attack infrastructure. But from a high level, we generally, from the red team side, we choose and procure some external hosting service providers. We like using cloud resources for that, things like AWS, Google Cloud, Azure, DigitalOcean, etc. on the red team side. So we have to acquire this. And in external threat hunting, you're also going to acquire some type of infrastructure, not necessarily in the big hosting providers, but in the hosting providers that are giving these adversaries their infrastructure. Then we generally purchase domain names. Rarely do you see organizations that just allow access to IP addresses. Then we generate domain certificates, and that's because we want TLS certificates. We want OPSEC. If we're going to do phishing, we might need to set up mail servers or procure hosted mail servers. Oops.
I got big all of a sudden.
Yeah.
Emphasis.
So we might have to set up mail servers or procure mail servers to send phishing emails. We have to set up credential theft sites for that target. If we're buying new domains, we need to create reputation for those domains. We need to categorize those domains. And then we need to set up our command and control. And we'll talk a little bit more about command and control shortly, but pretty much you set up various command and control servers and you set up redirectors. You also want to customize these C2 frameworks. You want to customize their profile, how they connect, what they're sending back and forth, etc. And lastly, one of the things that most red teams are using nowadays, and this comes really when you're scaling up, is the use of Red Elk for central logging and blue team detection. We're going to cover Red Elk shortly in a couple of slides. But as you do all this, you need to have operational security. You want to ensure that all your external systems are locked down so only your red team or your external threat hunting team can access the administrative interfaces. You want to ensure that payloads can only come from the target environment that you're hitting. You want to ensure that web properties are not attributable back to you, especially when you're doing external threat hunting. You do not want any attribution back to you, either from the hosted infrastructure you've built, from the domains, from the certificates, from anything. And you want to ensure that you're practicing what you preach, right? We're always telling people to harden their systems, to encrypt their systems, do the same. And then from the red team side, you of course want to vet your payloads and your techniques. You want to have all the indicators of compromise to aid in the blue team's lessons learned process or analysis and response process, and also detect when the blue team is investigating you. Is there anything you want to add to OPSEC?
Oh yeah, no. So there's a real term called fourth-party collections, and basically that means why steal stuff yourself when you can steal it from somebody who's already stolen it, and that's a real thing, right? If you don't have to deal with the layered defense of a company, if you can just find password hashes, critical emails, whatnot, sitting on a red team server or a threat hunting server somewhere, like as a bad guy, I would rather steal those than go through all the effort of having to break into the company. So, the operational security is actually very important.
And as we talk about operational security and setting up command and control, we also want to talk about Red Elk. Red Elk is an elk stack originally created for red teaming. And big shout out to Mark Smee and the Outflank team and everyone that's contributed to this project. This is not our project. We use it. And of course, we work closely with Mark and their team on this and have permission to talk about it and share this because it's an amazing project. So really the goal of this is to be able to aggregate all the logs that from your red team operations. So you're going to have multiple command and control servers. You're going to have multiple redirectors. You might have a phishing site or a credential theft site, right? You want to log all of that in one place to give your red team lead one view, but also maybe the white team or the managers or whoever else needs the view into what is happening all the way down to that log level, but not actual access to do anything with it. And the second goal is that it alarms the red team when the blue team is investigating you because it also queries some external security service providers. Now, talking with Mark, he mentioned that they are releasing version 2 of Red Elk, and it's going to have some internal hunting capabilities, things like data from Blue Check, Jupyter Notebooks, Neo4j for Bloodhound data, etc. So we're very excited about Red Elk, and we're going to show you a little bit more about it. So this is what an attack infrastructure may look like. And again, this comes from Mark Smee and the Red Elk team. You see the C2 servers are up on the top right. There's multiple C2 servers. You can actually have different command and control servers. You can have a Posh C2, which is what Dave's going to talk about. You can have a Scythe server. You can have, right, there's 55 different C2s documented in the C2 matrix. And then you have redirectors. The redirectors are on the left, on the top left here. These are generally reverse proxies. You might have domain fronting using some CDN network. And this is generally where the target network is going to communicate to. They communicate to your redirectors, and that forwards traffic, if it's coming from the right network, to your C2 servers. And then within that network, those endpoints are reporting things to the SOC. Things like indicators of compromise, maybe some alerts, maybe some endpoint detection and response, or network detection and response. And that SOC is submitting and analyzing these samples to external service providers. So what you have here is Red Elk. Red Elk will ingest, it's an Elk stack, so ingest logs. You ingest logs from the C2 servers, which means the C2 server needs to have the ability to, one, log, which is very important, and also the ability to have these logs in a consistent manner that can get ingested by Elk. Same with your redirectors. You're going to be ingesting that. And then Red Elk has the ability to go out to these security service providers and see if any of your IOCs are being looked for, which would give you an indicator that the blue team is onto you. And lastly, in the bottom right, you see the red team looks through Red Elk. You can also have the white cell there having visibility. White cell is generally trusted agents in blind red team engagements, could be a manager of a team, etc. So this is kind of what your attack infrastructure will look like. Obviously, it grows quite a bit. You don't just compromise one system in the target network. You'll compromise a number of them. You might have more redirectors, more C2 servers, really depending on the engagement. So all of this leads us to command and control. And command and control is the influence an attacker has over a compromised system that they control. Generally, it comes with a communication channel that allows you to manipulate that target system. And the way that most of these work is that you set up a listener, which is your C2 server. You set it up to go through redirectors and whatnot, and then you create a payload. That payload gets executed in the target system through any way that you gain initial access, and then it heartbeats back to the C2 server. And these heartbeats are important because generally what most adversaries do and most red teams use is HTTP for communication. And HTTP is not a consistent communication. You send a GET request, you get an OK back. You send a GET request, you get an OK back. You send a POST, you get a 302 back, right? That is what you want your implants to be doing as well. So you tell your implant to call back at a particular time, every 5 minutes, every 30 minutes. And then you also want to add jitter, which avoids this pattern of every 30 minutes. On the 30-minute mark, it will then do a percentage of that. So if you say like 50% jitter to a 30-minute heartbeat, you will get a call back between 15 and 45 minutes. And the important thing about using command and control, and talking with Dave about this, is the ability of having a consistent shell. So you can create implants on various operating systems with the same C2 framework. And all of this is shown here in the C2 matrix. You see there quite a bit. This list has grown. There's 57, I think, C2s. I checked on it yesterday. I actually added another one yesterday. And you can create these agents in Windows, Linux, and Mac. And that consistent shell is going to be important for your operators because then they can follow and be consistent as well, which also means that the logs that they do are consistent. So with that, with a common command and control, you then acquire infrastructure. You want to tell us a little bit more about this, Dave?
Sure. I could do a week-long class on just different ways of acquiring infrastructure. It ranges from a PO through your company all the way down to burner cell phones and disposable credit cards, or even more shady, offshore gold will work. But there's a whole lot of different ways you can acquire the infrastructure. We don't do anything that's illegal. Right, most of what we're doing is a 1 or 2 level redirection from who we really are, just to make sure that if an attacker were to compromise a host provider or whatnot, it wouldn't have a giant red arrow right back to who we are. One of the more exciting ways to get infrastructure is actually resource sharing with intelligence partners. External threat intelligence really has a lot to do with making good partnerships with other organizations, companies, vendors in your space, and being able to work on issues collaboratively. One of the interesting use cases for what we're talking about is in a case where a company might not have the threat hunting capabilities that my team does, but are still at risk. They could set up a Docker environment, a Docker server basically in their DMZ, and allow us to deploy our red team or our C2 basically there and pretend to be a part of their infrastructure. You can do that with actually, there's no end to what you could do with it. We've pretty much used Docker, but ESX, VirtualBox, any virtualization platform would work for that, right? Mutual C2 hosts that, mutual hosts that are shared by organizations are also possible. And if people are wary and fail, we don't want to allow you in our IP space. This can be done with something as simple as a DNS record. If you think about like your recon phases in red teaming, right? People will often find DNS records that point to IP addresses that aren't in your in the company's normal environment, with the idea they may be less secure, less patched, less managed, right? And you can kind of use that to your advantage. But the point is, you have to get an infrastructure. You got to get a place to hold up and call your own in order to really be able to reach out and touch these bad guys. Obviously, you don't want to do it from your corporate environment directly. And one of the things I want to point out is your goal here should be not to make an attacker interested in you that's not already interested in you, right? You don't. Part of the reason that we're going through all these obfuscation levels and whatnot is you, if you're really tracking an actor in depth, they're going to uh, be able to figure it out pretty soon. Much like as a threat hunter, I can tell you what bad guys are doing. Bad guys using the same techniques can pretty much find out what I'm doing, right? So we don't want to tip them off. And the infrastructure acquisition really should be anonymous or obscure enough where it doesn't kind of really point right back to who you are. And you don't want to leave any crumbs laying around that if an attacker was not previously interested in you, you've made them interested in you. That would be a failure condition for these types of hunts. And now I'm going to show a demo of what we've been talking about and some of the technical resources. Uh, this this demo I'm about to show you is one of many C2 setups that I've built. One of the useful things about this technique is that you can change your C2 or your profile as much as you want to avoid being identified by an adversary. So, like I said, this is built with Vagrant. This is a Posh C2 demo. As you can see, basically, I built two boxes to get deployed. Both one's Ubuntu or one's Kali. Uh, they have a private network they get deployed to and are able to communicate. One is specifically a logger. It captures all the logs for everything we're doing. And the other one I call the ops box, or the box that I'm actually doing things from, right? And neither one was very hard. Neither of these are very customized, with the exception of pretty much everywhere I can, I have security tools set up to capture my own actions, not just what an adversary does. For instance, my Suricata setup. Uh, Now, this is important because one of the reasons that I'm doing this, or this is a good technique, is to capture as much data as possible about what you're doing. Uh, so you can have a log of all your external hunt activities, but also you're able to collect and analyze your technique, revise it, get better at it. So, like I said, I'm using Vagrant, uh, and we can use a number of different cloud providers The cloud providers at this point aren't really that important. They're disposable or throwaway infrastructure. So when I say acquire infrastructure, I mean, well, we're legally acquiring it, whereas an adversary would not be. But these are all legally acquired, and all the logs from Suricata and whatnot in this demo are being copied back to my logger box, where it's running Elasticsearch via FileBeat. All right, so why am I using Posh C2? All right, so this is an example. These are 3 implants that I have in 3 different boxes around the world that I can at any point I want connect to, issue commands to download files, ping, uh, retrieve statistics or whatnot from a botnet as if I was one of the victims masquerading. And one of the reasons that I'm doing this is that botnet operators are getting smarter about banning IP addresses and whatnot that they're not familiar with or that they're not expecting connections from. This is an attempt to stop researchers uh, like like us. So this is a way to get around most of that. So as I said, here's 3 different uh, implants I have around the world. Uh, Most of this I can issue commands almost as if I was just at uh, a normal command line. Uh, and with the Posh C2 implant, there's lots of different options I can use for these. In addition to just the built-in functionality, you can load a script that gives additional threat hunting capabilities. So this enforces OPSEC, and it's very easy to move around and do. In fact, if you take a look at what is required, this blob is really all that I need uh, to move between machines. So we'll acquire infrastructure, we'll let them sit, soak in, whatnot, and when we want to use them, all I really have to do is log in and drop this blob, and upon execution, it will just show up in my implant list. Pretty easy. So in addition to just the ease of use and bypassing access restrictions, this is a great way for new researchers to have guardrails for what they can do and also record everything that they're doing. And I keep talking about recording everything, and that's very important because this is an example of the Elasticsearch instance I have running uh, in this environment. Uh, Now, the Elasticsearch instances the data is not stored on any of the C2s. It's tunneled back to an internal box it's stored on, but it gives us the ability to go through different different data and see not only what we were able to retrieve from uh, a botnet, but also what things we were actually leaving behind. So uh, Kibana now has some nice sim like capabilities. So basically, this is an evening of hunting that I use with both Suricata and Zeke. We're logging to the instance. And when you think that you know everything that your box is doing, it's good to take a second and see what data is being left behind because the adversaries that you're hunting can often hunt you in the same way that you would find them. And a lot of how I would find bad guys are passive DNS, and this is a good example of uh, insight into what I'm leaking. And I want to wrap this up just by showing there's a lot of different ways to use this data. But one of the things I find most useful is being able to correlate this to web server logs and whatnot from the C2. So where are the web server logs? So for instance, all the data I'm collecting, this is what the C2 communications look like URL wise. So as you can see, not a very easy pattern for a bad guy to figure out. But all of these are getting all the URLs that I'm hitting, every keystroke I type, every DNS request I make, every packet I send out is getting logged to Elasticsearch for later analysis. Servers, all the keystrokes and whatnot, is you really do want to be able to look at and refine your own process. Snipers have a term for this. It's called DOPE, or data on previous engagements. If you're not collecting the data, how do you know what you're going to get better at? And part of this infrastructure setup, the logging and whatnot, is all about seeing what was done in a consistent manner and being able to revise and get better at it.
Awesome. And with that, I think we are out of time. There's the references of various things we went through. And thank you all for coming. Thank you for attending. Thank you, Dave, for letting me collaborate with you on this. It's been a lot of fun. And we hope you all enjoyed. And I guess we'll be taking questions on Discord.
Our next presenters are Mauro Elrich and Luis Ramirez. Their presentation today is titled Charge, Why You Shouldn't Trust That Power Bank. Now, thank you so much, Mauro and Luis, for supporting the Red Team Village and supporting GrayHat. The floor is yours. Take it away.
Welcome to our talk, Charge, Why You Shouldn't Trust That Power Bank, by Mauro Cáceres and Luis Ramirez at DC 5411. Before we start, we would like to introduce ourselves and give a brief introduction on this talk. My name is Mauro Cáceres. I'm an Argentine hacker. You can find me on social networks as Mauro Eldritch. I'm the founder of the BCA and DC 5411 Argentina and Uruguay. I spoke at a couple of conferences around the world, including the USA, Russia, Brazil, Colombia, Iran, United Kingdom, India, and Pakistan, among others. Now my partner Luis is going to introduce himself too.
Thank you, Mauro. Hi, my name is Luis Ángel Ramírez Mendoza. I am from Colombia. I'm an electronic engineer working at the Birmingham Cyber Arc. I'm a member of DC 5411. I've been a speaker at DESCON, Red Team and Hardware Hacking Village beside Newcastle, Yacon, India, beside Islamabad, Taiwan, Colombia, and now GrayHat.
Well, the point of this talk is to explain bad USB attacks in a different way, stepping aside from the classical bad USB stick approach. We would like, in this case, to explain this type of attack using one of our evil creations, a tampered power bank. This power bank in particular. Looks pretty normal, right? Well, you shouldn't trust that power bank, and we'll show you why during this presentation. This is our first chapter, hardware hacking, the plan. So our plan is to adulterate a power bank to include a hardware hack capable of acting like a remotely managed bad USB, and to maintain the original appearance of the product at all times, keeping a perfect counterfeit. The final product must be able to run a Metasploit payload, giving the attacker full access, and this product must alert the attacker on success. It sounds like quite a lot of rules, right? Well, you'll see soon. Again, this is our power bank and the victim's cell phone. So let's go to the blueprints. Now, my partner Luis, who is the magician behind all this electronic tampering, will explain to us in detail every piece you need to build your own tampered charger and the logic behind it. How does it works behind the scenes? So Luis, feel free.
Thank you, Mauro. List of material: Arduino Micro Leonardo, Zinc 800 AGC module, voltage regulator, standard cable, and SIM card, VA power bank, Arduino ID, patient, love of patient. As we can see, all the pieces are ready for assembly, divided into three groups: battery bank, LSD display to be battery charged, and USB port activation method. All TPs fit perfectly inside the original device. All components are cheap and easy to acquire. They add virtually no weight to it. They live in appearance and touch. The device rating is original function, but had that the piece interact with each other. So, when connecting the cell phone to the power bank, it sends a text message to the attacker, telling him that the device is awaiting for input. The SIM module adds a sender and receiver, having a single phone number while listening the attacker. One activating the Arduino board and the human interface device, triggering the add mechanism. Please download a malicious APK activating it and launch a metaprocessation. In the picture, we can see a text message indicating the attacker that the device is ready and awaiting for input. In this graphic, you can see the configuration code for the power bank. In this one, you can see the code for the downloading the malware. The device shows no sign of tampering and can fool even daily eyes. Ears and field showing no different with the original video. And seeing it is an adulteration and not an counterfeit. It connected proper packaging and serial number. Even the register your device online fashion will still latent world.
So, you have seen that there are virtually no differences on the outside. And there are virtually no differences on the inside too. Aside from the core functionality, which is charging or powering other devices, the secondary functions, such as the LED display, will still work properly and show the remaining percentage of battery charge. So it looks good and it works flawlessly. So to be honest here, will you be able to detect this falsification? Be honest here. This can fool even trained eyes. Now, as you may see, the backlight works correctly. It displays the remaining amount of charge. Everything here looks flawlessly. Again, with a new cable, it works normally, looks normal. So, what's to fear here? Your package is ready. So, what can this tempered power bank do? A summary. It can act as a remotely activated bad USB, use SMS for command and control, run any banded payload, for example Metasploit or Meterpreter, or any custom payloads that are accepted. Right now it targets Android-based OS only, including custom images like the ones from Xiaomi. But we are developing something for iOS too, but this will come as a whole different product actually, due to Apple's own limitations. And having in mind the nature of this device, which is to be shared, to be used in certain cases, in emergencies, etc., multiple phones can be compromised at home at once or in a short time span. Some fun facts for you. Our only limit here is the available empty space that any device has inside. The bulkier the device, the better for us. So keep it minimalist, stupid. Also, taking this as a starting point, it is possible to weaponize any home device. Let's get to the fun part, to the demonstration. The following is a lab demo. This is a sleepy demo. All the inputs and activities have higher delays due to heavy use of sleeps and delays between commands. This is done on purpose, so attendees have a better view and understanding of this process. In real-life scenarios, this process will take just a few seconds to complete. So enjoy, please do not try this at home, and I can guarantee you that no cell phones were harmed during this demonstration. Here we are. As we can see here, we have the victim phone, the hacker's phone, and a laptop. We'll turn on the device, which starts charging automatically. The victim phone is connected. It will start charging now. And this is the hacker phone, which will receive an SMS or which can give a short call. On the laptop, we are running a Metasploit listener waiting. So now an SMS have arrived, and it basically says the device is connected successfully, boss, so feel free and call. The phone is charging as expected. Nothing to suspect here. The hacker then drops a call to the charger. Yeah, I know, this sounds quite odd. The hacker will call the charger. The charger then will start unlocking the phone. It can brute force it, or in this case we already knew the code, just to make these things go easier. Once we are sent into the invoice message, that's when the charger will trigger the payload. As you may see, it will open a browser. In this case, the command and control server will be a local server. It will download an APK. This is an unsigned application for Android. Now, it will emulate somebody, the user in this case, pressing on the options menu and going down all the way to the downloads folder in order to open that APK. This is done for compatibility. That's why we don't press the direct link below at the bottom. Give it a couple of seconds. Again, all inputs and outputs on this demo are really lowered down, really delayed. Obviously, this APK contains a Metasploit payload. Obviously, we are aware that these payloads are pretty much burned up, are pretty much burned, and that almost any antivirus will detect it. But this is just for testing purposes. Now we have the permissions tab, which again we emulate going down and down to the next button. In this case, this is in Spanish. It is siguiente. Now it's instalar, which is install in English. Right after that, we'll receive a reverse connection to our listener. And it's done. So now we have already hacked someone using only a charger. Says info and will give us the Android information. Okay, pretty much okay. As you might see, we are using a debug cable in this case, which is replaced in the final version with the red cable you have seen in the previous photograph. So, okay. Let's continue with the rest of the talk. Future plans. What to expect from the next version. Just in case you were not amused at all by this version, we are thinking on improving it. We would like to add the ability to detect surrounding activity to determine the best time to attack. The visual prompts are sadly unavoidable. Visual prompts are all those windows and menus and things that you have seen prompting on the phone. Sadly, for us, Android implements too some, let's call it time locks, in which unless 2 or 3 seconds pass, all buttons on a prompt will be automatically grayed out and you can interact with them. This is done to avoid what we are doing currently, to automatically click on buttons or tap on buttons. So to avoid that, a simulated tap is that on certain options, on the most dangerous ones, Android, and I'm not aware of iOS, but I'm pretty sure it does too, adds these time locks, graying out the buttons so you have to wait forcibly. On a second hand, we would like to add more communication methods like Wi-Fi, Bluetooth, GPS, and other crazy ideas. We will love to create an integrated circuit for this, so we can have a cleaner final product. But we are still undergoing development on it. And our future plans are to keep weaponizing things, and we would like to go for bigger accessories like power bricks in this case. Now I want to invite you to our hardware black market to see other prototypes created by us. Most of them were presented at DEF CON this last August. On our DC, Luis, Farid, and the rest of the boys like to manipulate hardware to create different kinds of counterfeits and to weaponize domestic hardware. So we really have a good love and a good time doing these things, and we would like to invite you to check them. This is one of our prototypes, Evil Genius, presented at DEF CON. It's a prototype of a tampered bad USB keyboard. This keyboard particularly has a keylogger, a Wi-Fi keylogger implemented inside. So everything you type is going to be sent to a command and control server, and it will automatically look for open Wi-Fi networks near. Take a look at this keyboard, please. Look at it. And now let's go to a stock photograph from an e-commerce site. As you might see, there are virtually no differences. This is another of our prototypes. It's called Sounds Legit. It's a tampered USB speaker. Take a look at it, and now let's see what it holds inside. As you might see, it holds a monster inside. It's the Cthulhu of speakers. This one contains something really similar to the charger, a GCN module to be able to be located via phone or SMS and to interact with it via SMS or via phone call. And it also features Metasploit payloads and custom payloads. So you connect them, you just open up your music app, your preferred one, you fire up your best playlist, and you're hacking. Now let's take a look again at the previous photograph. Now look on a stock photograph. These are the original speakers with a non-stock picture from e-commerce site with virtually no difference. So we are sad to say goodbye, but it's time to close this talk. Our conclusions. Always be wary of any new device, whether USB or not. Anyone could be a victim. And there's people like us who enjoy playing with hardware, so we'll eventually find new things to play with, and you're expecting to play with the most unexpected things. Remote TV controls or Xbox joysticks, whatever. So we are really looking into using the least expected attack vectors at home. With a few dollars, anyone could build or even buy a product of this type. Whenever possible, use preventive measures against bad USBs, and really believe us, don't trust that power bank. Follow us on GitHub and Twitter. If you have any question that you might like to ask privately, feel free to ping us. Also, our DC is pretty much dedicated to open source intelligence, social engineering, and hardware hacking. So if you like to exchange experiences, ideas, or just hang out with us, feel free to do so. You can find us on Twitter as Mauro Eldridge, Larm182Luis, or DC54111, in case you want to get in contact with us. It was really nice to be here. We would like to thank Omar Santos and all the GrayHat team for inviting us. Don't forget to grab a copy of these slides if you're interested at DC5411-charge on GitHub. Thanks again, and if you have any question, please drop them in the chat.
Welcome back. Our next presenter is a good friend of mine, Savannah Lazara. Her talk today is titled, You Are the Weakest Link, Attacking Organizations Through the Human Element. Thank you so much for supporting, as always, the Red Team Village and GrayHat, Savannah. I really appreciate your help in here and looking forward to your presentation. Please take it away.
Hi everyone, my name is Savannah Lazara, and the title of my talk today is You Are the Weakest Link, and it's about attacking organizations through the human element. So before we get started, a little bit about myself. I am a security consultant at Optiv on the Attack and Pen team, which is inside the threat management practice at Optiv. I'm also an ambassador for Hack the Box, and I also help assist with coordinating some of the events for Red Team Village. So at Optiv, I usually perform security assessments. That includes any vulnerability assessments, penetration tests, and social engineering exercises. My expertise is social engineering, so I really enjoyed making this presentation, and I'm looking forward to everyone seeing it. So the agenda that I created for this presentation is broken up into physical engagements, fun pretexting, and phishing. So for the physical engagements, I kind of broke it down with the process, how to case the building, badge creation, and any documents that you need to create for the actual engagement. And then so for the fun pretexting, I broke it down with the process and tips, and then the same thing kind of for phishing, I go through the process and kind of recommend any tips that I do have. So for the first portion, which will be physical engagements, I put together kind of this overview. And so you can kind of see it's like a step-by-step with like the arrow going down and everything. So whenever I receive any physical engagements at Optiv, the first kind of thing that I think is I have to create a game plan. And depending on, I guess, what organization you're at and how much time you actually do want to put into it. So 24 hours prior to the engagement, or you could be putting in up to like 2 weeks ahead of time, kind of just planning it like bit by bit. That's usually what I do. I kind of get an understanding of where this building is going to be located and try to do just like piece by piece to kind of prevent last minute, like, oh no, like what do I do for this scenario, or trying to come up with ideas last minute is just way more stressful than it needs to be. So also preparing a kit that you're going to be taking with you and kind of preparing it too, like ahead of time. So bringing items that be relevant based off of any recon that you've done for that client. So that includes documents, IDs, badges, stuff like that. And I am going to be going through badge creation on the call. So then the next step would kind of be to carry out that attack scenario whenever you're on site, executing the engagement according to whatever plan you did make. And then post-engagement, kind of reviewing how your engagement did go and how you can improve in the future. And I really can't stress enough how important this is, because some people will just go for like each engagement, and you kind of need to look back to see like what didn't go right that you can maybe improve on in the future, because that could really help you down the road whenever you're trying to help improve yourself, but you don't really have any notes to kind of look back on. So the next slide I have is then like a breakdown of all of these elements that I just went through. So for the physical engagements process, I kind of broke this down into detailed descriptions of each component that I discussed in the previous slide. So for creating that game plan, this is where you're going to be performing that heavy recon, kind of seeing what jobs could be available at the client site that are open that they can expect for someone to kind of ask about. You want to see how many employees are going to be on site. So the best way to do that is looking at the aerial view of Google Maps of the parking lot. If this is a place that the client site does not mention that there's not a lot of employees, and you show up there and there's like 2 people and these 2 people just know each other, it'll be very odd that you just showed up and there's only 2 other people and they know that they're not expecting anybody else. However, if there's a bunch of cars there, it's kind of going to be one of those things where you're going to be less noticeable compared to everybody else. And you also want to find those relevant scenarios based on their business type. So seeing if they have like any interns, seeing if they could have any potential contractors coming by, things like that. And then you also want to map out every entry point of that facility, because if you are inside and you need to know how to exit, you need to know where you kind of entered and where you can be able to exit. So for preparing the actual kit, this is just like a term, not like, it doesn't have to be an actual kit, it's kind of what you make of it, kind of bringing anything that you might see as useful for engagements. I do mention in this presentation some of the things that I find as useful. So whenever you're preparing anything you want to bring, you can kind of see based off of social media, any pictures on the company's website, stuff like that. If they're posting a lot, are they using any badges? So you could also kind of use Google Maps of like the street view, like trying to zoom in, maybe be able to see it like that. But mostly it's going to be on the social media with people posting it and they don't realize that their badge is in it and it's on their belt, on their shirt, whatever. So that's what I have on there based off the photos of Google Maps, Facebook, Instagram, etc. You kind of want to see how these badges look, and it's not always going to be on the company social media. You need to kind of dig through people's personal social media. I can't tell you how many times I've found like straight up badges when people just start. I mean, I'm sure everyone else sees this too, but people just post their badges and I'm like, oh, I'm just going to screenshot that just in case I ever need it. And then ensure like if you're going to bring anything special equipment wise that you do have that at least like a week ahead of the engagement. So for the next element that I have here is before your actual attack. It's like the attack scenario. So you need to make sure your point of contact has notified anyone that does need to know on site. It's really bad if the point of contact knows the day of, and I have had this happen where they forget to notify the specific people, because then those specific people are going to be on their toes and it's going to be harder to kind of get through. And then you also want to make sure you kind of have that get out of jail free card. When I refer to that, it's going to be that documentation that your company does have that you carry around, and if anything does happen, it's showing that you're authorized to be there and has all the right legal language to be able to be there. And if there are multiple consultants, you kind of want to map out the building to kind of show if one person's in one building, like what building is your coworker in, like A1 or B1 kind of thing, because there can be engagements where it could be a large area and you need to know kind of how to communicate what building you are in. And then kind of making sure you have all your recon evidence collected prior. So just making sure you've done like a thorough gathering of any of the recon things that you do need, and making a game plan, and also, like I was saying, like casing the building, which is kind of like this done through Google Maps and stuff like that, and getting a good understanding of any of the entry points. So the next slide kind of goes into how I perform casing of the building or buildings. So if there are multiple buildings, I will kind of map it out and kind of show any of the entry points, the employee vehicles, and then like I was saying, like having the numerical like A1 or B1. So in this case, I did B1. This is a stock image, just as a FYI. This isn't like a client image or anything. But I just wanted to use an example to kind of show the one way in, one way out, and then any of the entry points. On some of those roofs, I've seen some of my coworkers have told me that they've been able to get in through there because people don't think about that kind of stuff, and they're just wide open and unlocked, because you wouldn't really think like nobody's going to climb up there. Like that's not going to happen, but people will climb up there if they really want to get in. And so I have all these mapped out with all these buildings and everything. So I just find that it's a really good kind of reference for yourself and for if you have multiple consultants like on an engagement. So that's all I have to say really for that slide. So the next slide that I have is about badge creation. So these are kind of like a preview of some of the badges I have made. I've blurred out like any of the client associations or anything, and then some of these weren't even related to the client, but I kind of used say organizations that were nearby that would kind of make me look like I was kind of meant to be there. So say if you're in an area that has some type of association with, say, a newspaper, any of the business journals, stuff like that, that you can kind of reference to say, I'm here to do this as a reporter, or kind of making fake employee badges, or even a student card as well. So for the first one on this list right here, I was not able to find, say, an employee badge. Like all their social media was very clean. Nothing on there kind of revealed what their actual badges looked like. So I just kind of made one made one up based off of what I kind of thought it could potentially look like, using the exact like RGB colors of the company's like branding, using the company's logo, making it look nice. And it ended up being like almost 85% match. So it was very unnoticeable that it wasn't the exact match of the actual badge. Someone who really was a big mentor for me for this is my boss, Travis. So Travis is the one who showed me all of this about with physical engagements. So all of this kind of came from him. That's why I have like shout out Travis. So we usually, whenever now when I'm performing any of these physical engagements, I really collect a lot of hotel keys, because those hotel keys can be used as actual badges. And I'll kind of like show you too, because I have some of the stuff right by my side, but I was just going to go through each of these items real quick. And then also having a badge clip, PVC card punch, sticker paper, scissors, knife, razor blade, and then using nearby FedEx or Kinko's. And then also, I have it as optional, but I'd highly recommend getting it because it makes it look extremely real, is 3-inch clear Gorilla Tape. So the reason for the Gorilla Tape is because it kind of has, well, it basically is, it feels like the same type of material that would be actually used on a badge, that makes it shiny, water resistant, and it literally makes it look like a real badge. So for the sticker paper that you would initially start off with, it would look like this. This is the one I would use right here. And so you're printing out like that badge that you do create. And then once you have it printed out and you cut it out, you can use this Gorilla Tape to kind of lay it over the actual badge. So you want to make sure you have the right size of the badge whenever you're creating it on like Microsoft Word, Adobe, Illustrator, stuff like that. However, whichever route you want to go. But then once you print it out on the actual sticker paper, you're going to put that sticker paper down on a hotel key. So once you have it on there, you take the Gorilla Tape and you're laying it over on both of those sides. So once that is laid down on each side and you have like the front and the back on the hotel key card and then the Gorilla Tape over it, you're going to take an X-Acto knife. So I have one here as well. So just, there's like a bunch of different little things in here as well, like for the X-Acto knife, but any X-Acto knife will work. And you can use the X-Acto knife to cut out around the actual part where the Gorilla Tape is. So it's the hotel key card, sticker paper, Gorilla Tape, and then you're cutting it out with an X-Acto knife. And so once that's actually cut out, it 100% looks like a real ID. And it's like really crazy. Whenever I first did it, I was like, wow, like this really looks like a real ID. And then so another element is having the actual badge clip or lanyard. So whenever I say that, these are the badge clips, kind of messed up, like, because I ripped some of them off, but some of those badge clips. And then I also will buy sometimes, well, I did buy it, but I will use this sometimes, the clear ID holder, to kind of make it look a little bit more kind of realistic, however you want to make it. And then I also, this isn't on the list, but you can use anything, but I would say like to get something that you do bring whenever you're cutting out these actual badges. For me, I don't really cut them out and tie to FedEx because I feel like it looks really sketchy if someone were to walk by and just see me making fake badges and be like, what are you doing? So I always do it in like the rental car that I'm using for the engagement. And so you don't want to like rip anything in the rental car. So I did it on one of these. It's like something to protect whatever you're cutting on. And so you can kind of see like there's cuts on it from me using it. And this will prevent it from actually like going through on anything in the car. So it's just good to have so you don't ruin any surfaces that you are using. One of the times that I realized I needed that, I was using an actual cardboard box to try to cut on top of, so I didn't cut anything that was in the car or say any part of like the jeans I was wearing, stuff like that. So I just thought that was very useful to have like on the go. And they're like $5, I think, maybe 10. So yeah, that's what I use from the badge creation. And then also the other thing would be the PVC card punch. I have it right here. So for the PVC card punch, depending on if you want to put it in, say, like a lanyard or something, this is all you really need. And then you punch it to make it look like it was one of those things that has the badge on top. So I can kind of show you, like right here, you would see like that, right? That's what it would look like. Okay. So for the badge creation, I'm very OCD about it, but in a good way, because you kind of want to make it look extremely real. Bad badges aren't going to get you in. Just know that. You always want to use the exact company colors. Like, don't use like a harsh, really dark green if they have a very light green. And you can kind of find the exact RGB really quickly. Say if you just screenshot, say something from their website or their colors, and you just throw it in PowerPoint, and then you can like create a shape and say eyedrop in PowerPoint and just eyedrop that color. And right then and there you have the RGB, because PowerPoint will be able to tell you. That's one easy way that I feel like is just a really understandable way for anyone who wants to pull the RGB color, or if the company has any branding guidelines, like kind of referencing those whenever you are making the badges. And then you always want to make sure you're using like SVG graphics or any type of high resolution version of the client's logo. You don't want to have like a really blurry logo on top of the badge and just like, that looks really fake. So yeah, like using a high resolution image is the best way to go. And so say when you are making these badges and you do mess up, I probably mess up like 5 or 6 times when I'm making them, because you have to be so like still when you're cutting badges. And so sometimes I have to remake them. So I always try to have a lot of hotel cards, because I do mess up. Or if you're using a HID card or anything along those lines, it's okay to redo it, because in the long run, you want to make it look as good as possible. So I don't mean this when I say that, don't make your ID look like a toddler made it, but don't just like go with the first version that you make if you feel like there's issues, like making sure all the bubbles are like rolled out, stuff like that, because someone's going to be like, why are there all those bubbles on like that person's ID? Because like in the light, whenever it's reflecting off of it, it's going to look obvious. So just redo it. It's okay. Like, just make extra copies of the sticker paper. It's going to be okay. So the next slide I have is for like document creation. So I've had scenarios where I'll bring like fake authorization documents for whatever like role I'm playing. Like, I obviously have the real get out of jail free card with me, but this is documents relating to the part that I'm saying that, like the person I'm saying that I am that I'm not. So making sure that your fake documents match the scenario that you are doing, because I have had people, I'll be like, I can show you like these documents, and that is what kind of confirms what they think that I'm there for is, when it's actually not. They're just like fake documents I put together and threw on the client's logo. Say if like you're going to be an auditor, kind of looking up like what do an auditor's documents look like, or referencing like someone's like name and then adding that as like a signature and throwing that on the document. And you want to make sure that these look believable, because like the badges, if they look really fake and if someone's looking at them, they're going to be like, yeah, that's not real, so you need to leave. So making sure these look good is always, I would say, I'd stress that, and then the badges as well. So this is kind of like the end I have for the physical engagements. So for the considerations, the things that could go wrong whenever you are like going in and you're speaking with someone inside of your company is you could trip up on words. You could name drop the wrong person. You could deal with the escalating situation. You could go to the wrong building. I have heard that one. One of my coworkers told me that they had gone to the wrong building on accident, and I think they were able to get themselves out of it and kind of proceed with the engagement. But just making sure you're going to the right one. And then commonly forgot items is logging time, collecting evidence, having photo proof of some of the things that you did do. and ensuring nothing that you have is left behind unless you're intentionally trying to leave it behind. So for the logging time part, I usually will use my phone. I'll have like a binder or like portfolio of some sort, and I'll wrap my phone like this, and I'll record it, because whenever I'm doing any of these engagements, I'm trying to play that part, and it's really hard for me to remember any names that someone does mention. And then it also like will show what time it is on your iPhone, because or Android or whatever, because it shows you what time it was recorded, so you can kind of reference that back. So I always do that whenever I am doing a physical engagement, and I found that it really does help, because you can reference faces, names, whatever you need, and showing what you did do in the engagement to kind of be able to back up if the client does have any questions regarding like what you did do during the engagement. Okay, so for the next part of the presentation, I have phone pretexting. So phone pretexting is the same thing as phishing. It's just another term for it to kind of prevent the mixing up of phishing and phishing, because it can sound very similar over the phone. So phone pretexting. So I broke this down for the process into, it's kind of, some of the things I do mention here will be the same, similar things for phishing, physical engagements, and then phone pretexting, like for the initial part with like doing the heavy recon. So the first thing I have here is like researching the client. So you can utilize tools such as like Black Sheep Wall, Shodan, etc. to find information related to the company. Looking at like their subdomains to stuff like that to kind of see what kind of products they're using within their company that's external facing, and then going through any social media posts, trying to find potential high priority clients, and not clients, high priority employees that can be name dropped over the phone, and seeing how people are interacting over LinkedIn. So I know this like sounds very odd, but I've had really good success with it, kind of really stalking and looking really deep into some people's LinkedIns of who is like liking like who's post at this company, because then you can kind of see like they're probably know each other and they're probably talking to each other more so than someone who's not liking someone else's post and stuff like that. And then creating those relevant scenarios based off the business type, which is kind of relevant for all three of these types of components inside of social engineering. And so for the next part, I have for writing the scripts. So whenever you are writing these scripts, you don't want it to be something that you're looking at that you don't want to read it word for word. It's supposed to be something in front of you to kind of have as a reference. Because if somebody asks a question that you don't know and it's not on that sheet, you need to know how to respond. And you need to respond very quickly, because if you don't, it's going to be very obvious that you don't know the answer and you're not who you say you are. So kind of whenever I am in that situation, if somebody says, oh, like, what's your employee ID? I usually pretend that I'm looking for like, oh, like I have it written down, because I mean, that's very common for people to write down stuff like that. I mean, people still write down passwords, but saying you have it written down and then kind of looking through fake paperwork that you have, like just like throwing stuff around like in the back, and they'll kind of think that you're actually looking for it and you do have it written down somewhere, and then saying that you can't find it, and I swear like I wrote it down, like, oh, like it's okay, like we can just give it to you, just make sure you write this one down so you don't lose it again. And so like that's step one, getting the employee ID, because now you have some type of verification that if you're not talking to that one person and say you need to call back for during the phone pretexting process, you can reference that employee ID that was given to you, because now you know how it's formatted, and now you know that it's not, say, it could sometimes that they're not the exact like it's not going to be like your first and last name, it's going to be a unique ID. So always reference that, always write that stuff down. And then whenever you're making these calls, I always record whenever I'm doing calls, because it's good to have a reference of what happened during the call, because like I said, for the physical part, it's hard for me whenever I'm like playing a part and you're like, I'm talking, I won't remember some of the stuff that's like mentioned on the call, so I always record it so then I can just like reference it back, and then that also helps me with what time I made the call and stuff like that. So whenever I am doing these too, I can't like stress enough how important it is to not like start out on the call being like, hi, like my name is Savannah and I'm this and I'm that and I work with the help desk and I need to change your password and can you write all these commands down? No, like, don't do that. always start with hi, my name is Savannah, and then stop. And then they're gonna be like, oh, like hi, like my name is like Austin. And then you can say, I'm with blah blah blah, and then stop, and then see how like they respond, and they're like, oh, okay, is there something like you need? And then you go in and you say, like, we were having issues, say, updating your computer last night. We need to run this update to get into your computer. Can you please visit this link, or can you please type this command? It doesn't have to be that scenario, but that's just like an example of what you can do. Or like saying that they need to log into a portal for something else, something along those lines. But stopping between each of the things that you are saying is really important, because I mean, when you're on a call with a real person, you don't just like say all these things all at once, because then it's like, oh my god, it's overwhelming. Like, don't do that. So you kind of want to make it as realistic as possible to whenever you're doing these actual phone pre-texting calls. So some of the tips that I have for the phone pre-texting is, like I was saying, always record them for reference. And then information from these calls can be very useful whenever you're, say, targeting other victims. So I've like had, for example, one person literally gave me so much information, and it was like one of the first couple calls that I was able to use that other, like the information they gave to me on all the rest of my calls, like saying, oh, like we are using this and that's why it's having this issue, so we need you to do this. So say if someone mentions this, like the type of operating system that they're using internally for their servers or something like that, like you could reference that and say that they need to be updated and so. So you can kind of tailor your scenarios as you're going through the call. So it's always good to write down any information that is given to you. And then creating a log, call log as a template is what I've had right below here. So you can use this template, and then you can kind of tailor it to however you want to, but this is kind of what keeps track of like whenever I'm doing these calls. So I thought it was really useful. So that's like a template that you could use if you want to, you don't have to. So yeah, so for the considerations, things that could go wrong, similar to the physical portion that I did go through, the tripping up on the words, acting as an employee that doesn't work at the organization anymore. So I have had that happen too, to where someone we were referencing still had on their LinkedIn that they did work there, but they didn't work there. And I was like, cool, sorry, that was the wrong person. Like, it was really hard to get out of. And then referencing that, like I was saying, referencing the person that doesn't work there anymore. And then the other thing was commonly forgot, the logging, and then ensuring calls are being recorded before starting. So please make sure that those things are done, because I promise you, like, it'll be a lot better whenever you're kind of going through everything at the end. Because if you're making like 25, 30 phone calls, it's way better to be able to reference recording than to be like, oh, what did he say again? Like, it's just easier to have it as a reference. So for the next portion of the presentation, it's going to be about phishing. So the first thing that you want to do with phishing is set up the infrastructure for it. So you're going to want to purchase a domain that's going to be similar to the client's name, like adding an I, adding an L, just making it look like, if you were to look at it quickly, it would kind of still look like the client's name. Or you can use a domain that you already do have. So using an age domain that can be used across different clients. So it's going to be something that is generic, that they're all using the same technology, and the more that they're aged, the more kind of trustworthy they're going to be with email clients. So you're also going to need to use a EC2 instance, and this is going to host your GoFish and your EvilGenX. So GoFish is a open source phishing framework. So you can kind of release the emails from there and track and see who's open it, stuff like that. It makes it really easy to kind of see what's like going on with your emails. And then also EvilGenX. So EvilGenX is a man-in-the-middle attack framework used to kind of capture the login credentials, session cookies, whenever you have it set up and you're trying to fake an actual portal like Okta, LinkedIn. There's others that they do have, like GitHub too. So it's capturing those credentials in the middle, and then it is going to like forward them along to whatever real website it is. So the person on the other side, like the victim, is going to think that they're actually authenticating to that website. And the session cookie, session cookie is for the multi-factor authentication. So you can steal those cookies when someone has entered them in using a cookie editor in your browser, and you can log into someone's account with that session cookie, because that's how they're using the code that they use for multi-factor authentication. That's their cookie associated with those credentials and the multi-factor authentication. So if you have all of those cookies that you do need to log in, then like you're golden, you can just log right in. Mailgun, so I use Mailgun to set up like the MX records and have SMTP servers, so like a legit one. So whenever you do set this up and associate with your domain, once you have SPIF and the DKIM records associated with it, then you can add the MX records, and it just makes your MX records and your domain just look more legit. And it provides an SMTP server associated with it. And then, so for Mailtrap, this was a tool recently shown to me by one of my coworkers. His name is Tylus on Twitter. So this is this is something that you can use to test your emails. So you can use this as, like, they give you a SMTP server and the credentials instead of like using the one for Mailgun, just as like a testing purpose. So you can add those into Mailtrap, and it's just going to intercept the emails you send. They're not actually going to go to anyone. So whenever you're like actually testing the emails, you could have them be intercepted and go to there, and it's going to analyze one, like your domain, the HTML associated inside the email, and you can see how it's going to be looking on different like phones, computers, you name it. Like it's going to show you how it looks, so you can get a good idea of, is this going to be captured by spam? Am I on any blacklist? Is this domain, has it been burned and I'm just not aware of it? So that you know that before you go through everything and then you find out, like right when you're sending out, that your domain is burned and you're never going to make it past spam. So yeah, those are the things that I recommend for setting up, like infrastructure wise. So whenever you're creating that campaign, you want to gather open source information about the client. So subdomains, social media, metadata. So you can kind of put together like how you want to go in the direction of the actual campaign you are creating. So with the metadata, you can use tools like PyMeta. So PyMeta will kind of like scrape all different types of platforms and then extract any metadata within anything that's publicly available online. So this could be people's names, this could be technologies. It's really useful, and you're able to see some of the things that you would not be able to find if you're just like Googling it or just looking at like LinkedIn, stuff like that. Like this really digs into some of those, that they have PDFs, Word documents, Excel documents. So it's pulling any of the metadata that's inside of those. So the next thing is setting up the actual EC2 instance. So I usually use an Ubuntu distro, and then I set up the security group to allow 80 and then 443 from like any IP, because this is going to allow, depending on like whatever you're using, if you're going to be setting up an Evilgenix fishlet, or if you're going to be setting up like a custom portal, so with like Apache too, so you can set it up through there and have your own web server. But this is just going to be in relation to Evilgenix and then the GoFish. So the GoFish portal should only be accessible by your public IP. You don't want to have this accessible to everyone else, because it's like an administrative portal to manage your GoFish campaigns. So the GoFish port is 3333. And then you also want to make your public IP associated with being able to SSH in. So that's why I have them blurred out, because that's my public IP. So you can do your public IP /32, and then that will associate it with the individual IP. So yeah, that's it for the setting up the actual EC2 instance. So once you have all that set up and then you SSH in, you can kind of start getting everything set up. So also too, before you kind of dig into getting the GoFish and Evilgenix set up, you need to configure the actual DNS records associated with the domain. So pointing the domain to your EC2 instance, setting up Mailgun for your domain so you have like a legit mail server, and then saving the SMTP credentials for your domain that Mailgun does give you, because you'll need this later on for GoFish whenever you are going to be sending out emails. So I kind of created a little table here for configuring the DNS records, the A records, the text records, and the MX records, and you could potentially have other records depending on what types of things you are using. So this is kind of just like a quick reference of all the records. So, like the mail records would be coming from Mailgun, and so like the SPIF and then DKIM records, and then your name server, which would be for your actual Evogenics. It would be for Evogenics, like you need to have these name servers set up for it to be able to point to your EC2 instance, and then the CNAME. So these records, the mail records, will be available for you on Mailgun, and then the SPIF and DKIM, they're kind of given to you, like they're not just like made up. And the CNAME ones, that's for kind of like the www, and then any subdomains you're going to use associated with that domain, that's what those are for. So this just can be used as like a reference guide whenever you're setting up those DNS records. So the next thing that I do have on here is setting up GoFish. So one of my coworkers, his name is Big Boss, and that's his username on GitHub. So feel free to check out other repositories he does have. He created a really easy script to automate the setup for GoFish, and then it also automates the SSL certificate process with certbot. So that just makes it like 10 times easier. So that's the link to it right below there. And then so once you have everything downloaded, you can run the command right there, the gofish.sh, tach-e, tach-d, and then the domain associated that you're using for your phishing campaign. If you are going to use the same EC2 instance for GoFish and in Evogenics, I do recommend setting the phishing port server to 8443 instead of 443, because Evogenics is going to be using 443. So once you have GoFish set up, you want to start getting Evogenics set up. So you can download the repo from that link right there. And then I kind of listed down some of the commands to just get it easily set up. This is usually what I use, or I'll use the Go version and do it that way. But this is just one of the easy ways I thought I could just listen to the presentation. And then so once you have it downloaded and you go to it, you can configure the domain and configure the IP. So that IP is going to be your EC2 IP that's publicly facing, and then the domain that you're using is going to be the domain. And then depending on what type of fishlet you're going to be using, so you can use LinkedIn, Okta, whichever one, you need to add that fishlet associated with your domain, and then you need to enable it. And so once you have all that kind of like set up, then you can create a LURS link. So this is going to be the link that will be used whenever you're actually phishing people. So whenever they click on this link, they'll be redirected to whatever you have as it being redirected to. But this is the specific link that you are going to be using to kind of associate with it inside of like an email, or if you're telling someone to go visit a link, this is the link that you'll be giving someone. And then make sure you also test it too. So if it's like a login portal of like Okta or whatever, just try to test it. Obviously you would need valid credentials, but test it as much as you can, or as much as you're able to. So the next part of the presentation is about crafting the email. So you can either go the route of just doing a really simple email, which is still like good. I've found that it's good success, or crafting it specialized associated with like HTML. Whenever I've done ones that are like really simply formatted, it's like one of those emails that say like you get from someone internally at your company that's like from HR, and you kind of try to mimic like how they have it formatted. It's not gonna be anything crazy, like say like you have an Arial like font like 10, 12, whatever, and it's just like a basic email, and then the link inside of it is like the OneDrive or the Google link, whichever one they're using. You can look at their DNS records to kind of like tell which one they are using for their organization. But just embedding that link in, because that's so common for people to do in emails, like, hey, like the link's below for this, like please check it out, or please review this. And then you could embed, say, the Evogenics like LURS link that I was discussing, and it'll take them to a portal that may have them like log in to their like OneDrive or their Office 365 and have it to where like, oh, like that, yeah, I have to log in. Like they're not even gonna like think twice because you always like have to log into those. Or if you create like a custom HTML like web portal, which I've done that too, and kind of branding it to how that they have their colors and how they have their logo and stuff like that. So kind of referencing some of those things I was mentioning with the actual physical engagements, really paying attention to how their branding is, because if the branding is just like way off and it looks like really fake, like no one's going to enter in their credentials. But if you have it look really good, you can get a lot of credentials. So that's just like a sample little email that I kind of like said, like this information about whatever they're saying related to HR, and then please visit the link below to view the document. And that like link, so it's not going to be like a whole link, it's going to be embedded into the text of the company name, 2020 employee policy, and that will be whenever they click on it, it'll take them to whatever link that you're having them go to. And it's just a very basic email, but that's like how people talk to each other inside of actual organizations. So you don't need to like go really crazy. But if you do need to go crazy and use the actual vendor that is not internal, so it's not gonna be an internal employee, it's gonna be something they use like GitHub or stuff like that, you can pull like actual emails associated with like GitHub that you've received, and then play with the HTML from there, so it doesn't get caught by any spam filters if there's any like links inside of it. So the next thing is testing the email with Mailtrap. So like I was saying, Talis is the one who showed me this, and it's really helpful whenever you're conducting phishing campaigns because you can kind of see the statistics associated with your email. So it's mailtrap.io that you can get this set up, and then instead of using the Mailgun's SMTP server, you can use the Mailtrap's SMTP server before you're actually releasing anything, and so it can intercept it, and then you can test these emails and see if they're going to be kind of flagged whenever they're going through. Like this is used for people who are in marketing. They're trying to prevent from being ended up in spam because they obviously want to hit the consumers with the emails that they're sending out and not just always go to spam. So this helps them with that. So this is kind of like what it looks like, the spam report. It's a scale to 0 to 5. So this one that I had was a 1. You kind of want to be 1 or below to kind of be not rated as spam, at least from my perspective whenever I've used it. And then the next slide I have is checking to see if your domain is burned. So they do have a blacklist report. So this is kind of what it looks like. So you can see the domain and the IP associated with it, and you can see if anything has caught it and it's saying it's listed. So that means you obviously can't use the domain because it's going to be blocked. So that's all I have for the presentation. I really hope you guys enjoyed it. And if you do have any questions, feel free to reach out to me on any of the platforms below. So Twitter, Discord, LinkedIn. I'd be happy to answer any questions. And yeah, I hope you guys enjoyed it. Thank you.
Welcome back. Our next presenter is Vinicius Vieira. His presentation today is about steganography and red team operations. Thank you so much, Vinicius, for supporting GrayHat and the Red Team Village. Take it away. The floor is yours.
Hi everyone, my name is Vinicius Vieira, and this talk will talk about steganography on Red Team operations beyond CDF. I would like to thank the staff of Red Team Village, Omar, Docs, for this opportunity and encouragement to be here today, share with you a little knowledge. Congratulations for this amazing call. So, for those who don't know me, I am a security researcher and pen tester for over 16 years. I am a professor and academic coordinator at FIAP University in Brazil. I am also a veteran and expert in cyber warfare by the Brazilian Army. I have some certifications such as OSCP, CH, and others. I am a CVE holder and exploit writer. My focus is web apps. I really like research vulnerabilities in this area. I am a member of the C5551, the largest DCG in Brazil. A big hug to my dear friends from the C. I am also a volunteer at Red Team Village, and recently I joined the HINAC project, Hacking is Not a Crime, which I believe a lot, and I have great pleasure to help and spread in the world. But let's stop talking about me and move on. Today, we are going to talk a little about what steganography is. We are going to remember some important concepts and see some ways of implement this technique in the field of InfoSec, including some very cool out-of-the-box ideas and how to use steganography. Let's talk about the difference between stego and polymorphic files, aka polyglots. Let's remember what Red Team operation is, the mindset of the Red Teamer, and if it is possible to use steganography in this scenario. And we are going to present some ways of using steganography and polyglots in Red Team ops, mainly for bypass, antivirus, AMSI, EDR, and so on. Let's go! So, what the fuck is steganography? Steganography is the practice of concealing a file, message, image, or video within another file, message, image, or video. In other words, the big goal of steganography is to hide information within another legitimate information. And what is the big key for us as Red Teamer? Cover files. Through steganography, we can cover up payloads, leaving them practically undetectable. So, despite being widely used in technology and having incredible mathematical implementations, steganography is not a recent technique. It started with the Roman army when they needed to send sensitive messages across the battlefield. They shaved the slaves' heads, wrote on them, waited for their hair to grow, and sent these slaves to deliver this message. In this way, even if the slaves were captured, the information would not be discovered. But leaving the history aside and turning to technology, the basic structure of how steganography works is this. We have a message that we need to cover up, and he will start threatening it is a payload, and a coverage file that will receive this payload through a steganography encoded process, becoming a stego artifact. And this steganography may even have a key or not. A clear example for those who have already played CTF is StegHide, that allows you to insert steganography in an image using a key. This artifact will be sent through a certain way to your recipient. Thinking as a Red Teamer, we have different ways of delivering this artifact, correct? And when it is received by its receiver, by the target for example, this artifact needs to go through the reverse process for the payload to be withdrawn. In other words, the technique is simple. And maybe you are thinking, how do I deliver without my artifact being scored? Or how to remove the payload of this artifact to be executed on target? There are some ways and tools that can help us in this process, but we will comment ahead. If you you have played CTF in your life, you should already know that there is steganography image, correct? Even the GrayHat we mentioned earlier is an example of a tool for this purpose. If you have already done HB Stego challenge, you also know that there are steganography audio files. Even HB has a wonderful Stego challenge for those who want to try it. Wherever mathematically it is possible to use steganography technique in any file type. Imagine hide a payload in a network package, for example. Well, this is also a Stego technique used to data exfiltration, and we will see more soon. What needs to be clear here is the big goal of Stego is to hide something in something else. Make sure that you want to hide is only revealed at the right time. Well, talking a little about the implementations technique of steganography, digital obviously, one of the most used is LSB, acronym for least significant bit. This technique uses a very interesting mathematical model because it manipulates the least significant bit in a bit chain. That is, the rightmost bit. Regardless of whether you use a decimal or binary base, the rightmost bit will always be the least significant. The bit whose changed value does not make a significant change to the total value. Look this example of the Mona Lisa where the LSB was changed. Noted that the RGB value of the pixel has changed, but it was such an insignificant change that the human eye practically impossible to detect. There are several other mathematical implementations for Stego, but LSB is the most common. There are several ways to use steganography today, and obviously one of them, and perhaps the most used, is in CTFs. There are many very interesting challenges that make us think a lot to be able to capture a flag. Recently in my class, I talked about SSTV protocol and how it can be used as implementation of audio steganography. This protocol is used to send images through sound waves in a certain frequency range. Our students sent image from one cell phone to another using only audio file. What is video?
Não tem câmera. Isabel, deu uma zoada ali embaixo. Parece até synthwave, né? Aí quando eu dei grupo. Faz uma gravação, manda no grupo.
Pretty cool, huh? This link on my wiki has the Python code and the how-to for this activity. Cool. So far we remember what steganography is and how it is used in CTFs. But do you know the polymorphic files? They are also very useful for covering up payloads in Reddit ops. They are files that can coexist two or more different file types in one. But how it is possible? In this example, we have a polyglot file that is a raw and valid elf. Note that in the output of the file command, he identified it as elf because its header starts with the magic number of an elf. Here we see the entire elf structure through the strings, and it really is a valid elf, you know. But here we have the rar including its header and content. The rar is a valid file, and we have two valid files in a single file. This type of file is very interesting because in certain scenarios where the target has endpoint security that does analysis based on the file type, for example, we can hide a malicious payload that will not be detected. We will see an example of this later. So very cool all this so far. We're already seeing cool things that we can do with Stag and polyglots, but where are the editing techniques using what we have seen here? It is really possible to use steganography and polyglots in Redditing ops. And why would we decide to use these techniques in Redditing operation? Let's talk about it. Here are some of the main attributes of a Redditing. Obviously, they are all important, but for me, one of the main ones would be adversarial emulation. The main focus of a Redditing activities is to simulate the actions of threat actor, not only in techniques, but mainly in mindset. Adversarial emulation would be actions that simulate the real environment of an attack. If your target has EDR or AMSI, you need to model your action to bypass these defense technologies. For this, you must think as a threat actor thinks. You need to perform action as stealth as possible to not be detected. And this is where Stegall and polyglots come in, because they can help the Redditing operator to carry out their actions in stealth mode. If you analyze the kill chain of a Redditing op, we can identify some phases where the importance of acting in stealth mode grows, such as during the initial compromise or exfiltration. They are moments where a small slip can do with what the Redditing operation is discovered and its action is unsuccessful. An important detail here is the pentest's focus is on discovering vulnerabilities and how to exploit them. So the Redditing's focus is to exploit the vulnerabilities in the most real environment possible. That is, its goal is always to be how carry out your actions without being caught. In other words, impersonation the threat actor. And to exemplify everything you have discussed so far, we are going to demonstrate some proof of concept. Start with the use of polyglots in Redditing operations. You are ready? The first one is well known not only for Reddit teamers but also for bug hunters, is the cross-site script polyglots. Not only the web application files but also several modern development frameworks have measures to identify and prevent the most common cross-site script attacks, like a simple JavaScript alert, and many other of these based in signature of a cross-site script syntax. For that, we can change the syntax a bit to bypass these defense measures. A very nice alternative is to use CMA script to write your JavaScript syntax while still using an innocuous SVG element. This technique is very cool and has already brought to me a CVE. The concept here is simple. He'll write a precise script so that the interpreter does not identify the code being injected and execute what we want. So, another very interesting technique for using polyglots is the covert channel. Imagine with me a scenario where the Redditing operation has compromised an environment that has a defense mechanism, such as a Rust intrusion detection system, for example, or simply does not want to leave a trail. Running commands on the fly would not be always solve the problems, and for this we can use polyglots. In this example, we have an image of a very cute kitty, a valid JPEG file. Yes, I used a kitty to appeal to emotion, okay? A Reddit teamer always use a little bit of social engineer. But look at this cutie. This image has a reverse shell, you know? Shall we see in action? This technique can be useful to hide malicious script or cover up tracks left without command history. And the coolest thing is, the skidding payload was not detected in the virus total static analysis. Cool, isn't it? But how to raise such powerful keys? Obviously, you can do it manually using a hex editor, for example, but there are some really cool tools that can help you in this process, like for example, Don't Kill My Cat, suggestive name, right? Snow Crash, which is very interesting, and PolyShell, which focused on developing reverse shell using the concept of the polyglots. Use it wisely, okay? So, and going back to our beloved Stegos, now we will see some really cool ways to use the concept of steganography in Reddit in-ops. One of the main characters of a good command and control system is being able to hide this communication channel to make detection difficult. And what will be better to hide a communication channel than Stego? There are some interesting techniques to hide communication channel of a C2, such as using Twitter message, for example. And steganography has also been used for this purpose for a while, such as the stegogram that had payloads on Instagram images. An interesting C2 framework for adversarial emulation that uses steganography is DALI. DALI is open source and its code is available on GitHub. He used Imager to host steganographed images with C2 commands, in addition to creating albums and on Imager with the response of the agents on each target. Its operation is simple. It uses LSB to embed the commands in the images and submits them to Imager. The client browses to Imager by searching for keywords related to title, for example. Using the results of the search, the client attempts to decode a writing tasking from the image binary data. If all goes well, the communication channel will establish it and very well hidden. And if you want to know more about C2 framework, see the project C2 Matrix by George Orkilis, one of the big names at InfoSec. I'm very grateful for George sharing a little of his work with me for this talk, so thanks, George. So, one of the coolest and perhaps my favorite WOBI data is filtration using the Stego. It's an incredible technique because you don't need much, obviously. When I say a lot, I mean more than the basics of network protocols and a little Python, for example. One thing we see a lot, there are professionals who follow the path of tools instead of the path of solid fundamentals. Tools are amazing, but using them without knowing what's going on is a serious mistake, and it doesn't make you grow as a professional, okay? And talking a little bit about fundamentals, for those who don't remember, of course, this is an example of a ICMP header. Like the other network protocols, ICMP has a data field. And if you don't know, this field is an ideal place to store things. After all, ICMP package traveling on your network is not something malicious, is it? Well, that's where are you wrong. In this proof of concept, I used PyXFill, which is a Python lib to manipulate ICMP packages and insert the contents of a given file into them. Note that I can easily exfilter the contents of this file from one machine to another using a single one-liner Python command. When receiving packages through TCP-DUM, for example, just decode their contents that came in base 64 and have access to the contents of the file that was exfiltrated from the target. There are several ways to exfiltrate data like that, not just in use SMB, of course. You can do this through HTTP, DNS, and much more. And voila. Another very interesting technique is the use of Stigo for bypass in antivirus or endpoint securities. This technique is being used on a large scale in the world of cybercrime because its effectiveness is very great and many malware developers have opted for it. Many famous malware use this technique, such as the Lockbots, Botnet, GrayHat, Voodoo, and among others. Europol has even created a cybercrime department exclusively for research and awareness about malware using Stigo, the criminal use of information hiding department. This is an example of a kill chain for using Stigo malwares. Note that I use for the concept of the payload concealed in another vector, in this case a vector with Stigo in an image roasted on the internet, to increase the probability of not being detected. Dissecting this technique, we have this, a cover file that will usually be a doc with a macro, obviously sent through a phishing campaign, for example. This macro will call a dropper, which will usually be an image with steganograph payload, and this payload will be opened on the target to finally perform your action. Obviously, for this technique to be successful, I needed to be careful with the point of failures. One of these macro that needs to be obfuscated, of course. Many EDRs detect malicious activity in macros before the doc is opened, so be careful with this technique. In this proof of concept, I use PSMH, the powerful PowerShell script that uses Stigo to encode payloads in image and already regenerates a one-line command to execute on the target. My payload will be a simple reverse shell TCP in PowerShell, of course, and PSMH will generate a set alias syntax that will download our image. Of course, in this case, I have already roasted on that image on a server, and PSMH will decode the payload and execute on the target. Okay, my one-liner is ready. I need to change address to my image roasted on the internet. And I use a doc with a macro to run my one-liner at PowerShell prompt, and I'm going to save this file. My macro is ready. With my address, image address. I put some content in this file. My malicious doc is saved, and I will open my listener on the attacking machine. And open my malicious doc. Look that the connection is open and we are inside the target now. And the most interesting thing about this technique is that it is not detected by any antivirus engines. In this case, I submitted my dog to the virus tunnel and it was not detected as a malicious. This technique is very stealthy and very difficult to be detected, and this is precisely why more and more cyber criminals have been using it. Obviously, that is not only PS image, of course. There are other cool tools that use steganography to help us cover up payloads. One of these is Packet Whisper of TriCatch, which has presented at DEF CON 26. It uses Steagle to exfiltrate data through GNS queries. We have the Steagle Dropper that generates Steagle artifacts with encoded payloads, and Spokeflare is a loaded dropper generator. You can bypass the countermeasures of the target system like a boss until they learn the techniques and behavior of Spokeflare payloads. Very, very cool. Well guys, that is it. I hope I have shared something useful to you. My idea here was not to dissect a technique or two, but rather to show the possibilities of Steagle and polyglots, and mainly so that you can see that these concepts can be much more useful than just in CTFs. On this QR code have all proof of concepts presented in this talk. I appreciate the opportunity, and there are my contacts for those who want to chat me. So thanks.
Welcome back. Our next presenter is John Helmus. John is a security engineer and adjunct professor and also an author of a new book that is upcoming related to AWS security. His talk today is Ghost in the Clouds, Bypassing AWS Policies. So thank you so much, Jonathan, for supporting the Red Team Village and supporting GrayHat. The floor is yours.
My name's John Helmus, and I'm glad to be here at the Red Team Village at GrayHat 2020. Today, I'm going to talk about AWS services, and how we can bypass some of the policies that are commonly found in some of these services. So this is going to be a talk that kind of concludes a lot of research that I've done for a book that's coming out in December. So glad you're here. Sit back, relax, hang out with me in the Discord, and let's get going. So, the agenda for today. Well, of course, we have to talk about who I am, right? It wouldn't be a slide deck without talking about who I am, right? So, we're going to talk a little bit about me. Then we're going to talk about AWS. We're going to talk about some of the services that we commonly see in AWS. We're going to talk about how we pen test AWS. And then we're going to talk about policies, right? So we're kind of seeing the trickle effect here in AWS. Then we're going to talk about how we bypass some of these policies. We're going to see a lot of cool screenshots that are derived from a lot of different research. And then we're going to actually do a demo towards the end of the presentation. So I actually got my Kali machine fired up here. We're all good to go. And then at the end, before we go into the Q&A, I am going to talk about a book being released on December 9th. I actually have a promo code for everyone who's in attendance today, so stick around to the end to get a discount on the book if you're interested in that, as well as I'm going to do a sign up for a free signed book raffle. So, if you want a free book, or well, the potential to get a free book anyways, or at least a discount code that you will for sure get, stick around for the end of the talk. So, who am I? Well, my name's John Helmus. I live up here in Seattle, Washington. In the community, sometimes people commonly know me as Moosey. Currently, I work at Nordstrom as a penetration test engineer, or in this case, I'm currently a team lead. I also am an adjunct professor and teach online courses at City University of Seattle and National University. At CityU, I teach various bachelor and master level courses. And at National University, I actually have done some content development for them and currently teach master level ethical hacking, pen testing, and red teaming courses. I'm also an author now. My book, AWS Penetration Testing, is being published by PAC towards the end of the year. And then some of you might actually recognize me from DEF CON. I presented the student roadmap to becoming a penetration tester. I presented this talk a couple times since DEF CON. But that is, if you were at DEF CON, that's where you may recognize me from. I'm also a PhD student at the Dakota State University. I'm getting a PhD of cyber operations. Going to be doing that for at least the next few years. I currently do hold a master's in cybersecurity with a focus in ethical hacking and pen testing from National University. So I'm really fortunate there that I was able to actually be an alumni of the program and then help revamp the program a few years later, even after graduating, as well as teach it. And then out of all the certifications I have, the highest, shiniest one that I got is the OSCP. So I'm going to move my head around here a little bit, as you can see, so that I don't take up too much space of the slides. So we're going to talk about AWS. So what is AWS? All right, so it's a cloud service provider that's based here out of Seattle, Washington. Seattle, Washington is becoming kind of like Cloud City metaphorically and literally, right? With all the clouds and rain that we have up here, as well as all the big tech providers are up here now. AWS, Azure and Microsoft have been here, since they were founded. Microsoft, right? And then Azure has come up. And then Google and GCP are up here. So, the big cloud giants are here. However, AWS makes up most of the market, right? So 60% of the market within cloud is actually pretty much owned by AWS. And what that means is that, out of all the cloud that, organizations are buying, 60% of them are going to AWS. And even a lot of the times companies double down on different services. So what that means is that a company will buy AWS and buy Azure. So you're going to need to have some experience with, at least one of those. And so for this, we're going to be targeting AWS. So 60% of the market means a lot of people use it. So in regards to the way how it's set up, it's a typical infrastructure has a service model. You can go Google the shared security model that's provided by AWS, and you'll see a lot of, different colors and where things are associated with who and who would be the customer or AWS. So, after this talk, if you're still a little muddy about it, feel free to ping me in Discord, or I can, put a link in the Discord to guide you to the illustration of the shared security model. But essentially what it breaks down to is that the owner, and the owner being the cloud service provider, takes care of the hardware, takes care of the security that's built into the services, right? Built into the services. That doesn't mean afterthought where we're configuring the services, it's built into the service. Owners take responsibility of that. And then the customers, we would be the customers, we take care of the data and all the configurations that are used to secure that data. So if you've followed the news in recent years, you'll see that a lot of data leaks have been caused by S3 buckets, which we'll talk about later throughout the talk. But that's due from not taking due care to the services that we're supposed to secure. And we, meaning the customers. So some of the services, these are some of the more common ones that we're going to see, right? And for an introductory level, these are the big ones that you want to start to look at. So a lot of services within AWS that allow us to essentially take, everything that we would build on premises and put it in the cloud. And a lot of companies utilize that to execute their business strategies, especially small and medium businesses that may not have the budget to afford all the hardware that you would need for on-premises. They can use a service such as AWS to help bring up their systems. So what are some of the common services, right? We need to know at least some of the common services and their functions and what they're used for. So S3 buckets. S3 buckets, I always like to think of that as like it's a file system in the cloud, right? And think about it as like Windows File Explorer, where you share files back and forth between users, and you can apply security restrictions based off of users, groups, things like that. S3 buckets are pretty much the same thing, right? Only it's in the cloud. So it can't be any more simple than that. Lambda is essentially, think about that as like kind of like a function in the cloud, where you write functions in Lambda that are able to execute things on demand, or at when they're triggered, they can from an event and things like that, right? So Lambda is really at the dependent of the user and the customer and how they set everything up. So that's one of the big security issues commonly found in AWS environments is Lambda, because it's completely dependent on how we write the code that's put into the Lambda function. EC2 acts as has a piece of virtual hardware. Think about VirtualBox, VMware, things like that. EC2 is essentially that, where you load up an operating system onto it, and then it gets spun up into the cloud. And then it's given an internal and an external. If you request or want an external IP, it'll give you an external IP that can be accessed on the internet, and then it allows you to access that operating system. RDS, relational databases. Think about that as like a SQL database in the cloud, where you can have things running. It can be running on the back end to like a web server that you have running, or something like that. A common configuration is to set up a web server on an EC2 instance and then have the RDS work as the background. Or, I'm sorry, the back end, not background. It works in the background. So now that we know some services and we know at least enough about AWS, let's talk about how we pen test AWS. And this is something that I've spent a lot of time this year looking at and working on to really make a cohesive statement in how you can effectively and efficiently pen test AWS, because you cannot take a normal white box or black box or gray box approach. You can't do that. It's not going to work. If anything, the most usable and effective approach would be a white box test. However, even there, it can be a little different. So what we need to do is we need to focus on functional vulnerabilities when we're pen testing AWS. And what I mean by that is we need to look at the issues that we are incorporating into AWS and into the services that we're using, or in this case, our customers are using, if you're an external pen tester. Why? Because we're the ones developing policies, we're developing those Lambda functions, we're doing all of that to secure the services to, fit our needs so that we can use them to drive our business goals, or for our customers to drive their business goals, right? And make an impact for their organization that positively pushes them forward in the market. However, we make mistakes because we're what? Humans. So we're going to be testing those processes, common issues, and misconfigurations that we find in services and in an organization, right? So what we need to do is look at this from an insider point of view. And for those of you that are, familiar with pen testing and do it for a living, you understand what the insider threat point of view means. And what that means is that we assume post-compromise. However, with AWS pen testing, you don't necessarily need to assume post-compromise, because when you're doing that, it makes some different assumptions that AWS pen testing does not assume. You assume that there's, someone who has access that already has admin level access, or, whatever user level access, and then you start hacking everything, right? You're not going to do that with AWS pen testing entirely. You can, but it's still not going to be effective and efficient if you only focus on that. So what we really want to do is look at this as a non-traditional pen test methodology and really create it into its own. And we're going to, not really talk too much more about this after this. However, I will put the plug in here, of course, that if you want to find out more about that, sign up for the raffle at the end of this talk, or, go buy the book. It's 300 pages full of this stuff that's going to talk about AWS pen testing and how you can effectively execute an AWS pen test for your organization or for a customer organization. Just know that when you're pen testing AWS, that you want to think about it looking at it as like a quality assurance engineer, but with a like a threat adversarial mindset. So to conclude that kind of portion, what I always like to say is that, AWS pen testing plus white box pen testing equals functional testing, right? Or white box testing plus functional testing equals AWS pen testing. And again, if you want to find out more about that, please, buy the book. Like I said, I'm going to have a discount code here at the end that'll give you a nice little discount on buying it for the ebook or the physical copy, and really, dive into what it is that you need to do in order to create an effective AWS pen testing methodology that's going to help you, your organization, and the customers that you work with. Now, enough about my book, enough about AWS pen testing. Let's really talk about the cool stuff and how we're going to actually bypass some of these policies within AWS. So first we need to know the fundamentals about policies. So policies are created by us, the customers, the humans. They're not created by AWS. They're not going to sit there and create policies that fit your organization, because only you know your organization, or your customers know their organizations, and hopefully you know your customers' organizations. So these policies are created by humans, which means what? They have human errors, right? So when we look at these policies, and we're going to look at a few throughout this talk here in a little bit, we're going to see some screenshots of some things, and then also in the demo, where you're going to see that it's pretty self-explanatory. Policies are restricted and granted by two things: users and groups, typically, right? More commonly. And so what that means is that, user ABC might be denied something, but user DEF will be allowed something, or group ABC might be allowed something, and XYZ might be disallowed something. So it's, to think about it simply, think about it with like a Windows file system where you set up a file and you allow either users or a group to access it, or, AD when you create user groups and things like that. It's the same thing there. So bypassing these, right? So typically caused by issues such as overly permissive policies. So overly permissive policies are not, isolated incidents only to AWS. For anyone who pen tests for a living, you understand that over permissive policies tend to allow us to get access to things that we shouldn't, and allow users to get access to things that they shouldn't. So that's really the more common issue that we see with policies. And the reason why we see that, there's a lot of reasons, which we'll talk about in a second. But know that when you're looking at the policies, if there's anything that you are allowed to write to that you shouldn't, then it's not right. So I always like to say, if you can write, it ain't right. So overly permissive policies allow admin to edit access to objects. So objects can be services, or files, or anything within a service, such as like S3, RDS, things like that, or Lambda. So the admins will, set up a policy that allows them to configure an S3 bucket so that they can grab files, and then, when user Timmy and Jimmy get added to the organization of 10 people, and now they got 12 people, they can say, okay, Timmy and Jimmy are added, and they write to the bucket policy, and now Timmy and Jimmy are added. Now the issue here is that typically, very commonly, the admin will, allow anyone to write to that, right? Because they'll just set it up to where they allow anyone to write to the policy, and that's just kind of how it goes, which is not good, obviously, right? And you can kind of like snowball effect that and scale it into, this really, really scary peak where, imagine when it's not just, 12 users, it's 100 users or 1,000 users. And, they're not using like something like single sign-on. They're just using an access key and a secret key and things like that. It can really start to become cumbersome and pretty scary. So common issues, allow to put policies where policies can be amended. So when I mentioned, you can write to the policy, essentially you can amend it and you can allow it to do whatever you want it to do. And we're going to check that out in the demo here in a bit. But just know, again, if you can write, it's probably not right. So I'm going to get a drink of water here. And now I'm going to keep talking. So how do users get access to things, or how are AWS accounts compromised? Typically it's through initial key access. So keys are left out in the open that lead to cloud compromise. So you'll see things in GitHub, Gist, or Gist, whatever you want to call it, right? You get socially engineered through a phishing link, things like that. LFI, RFI, where you're able to retrieve keys through vulnerable web servers or web apps. And what that'll allow you is to get keys that allow you access into the internal system. So that's why we want to make sure that we focus on functional testing, because when we're doing functional testing, we're actually looking at the issues internally, right? So we already assume the keys have been compromised. That's why when we do AWS pen testing, we want to already have the keys or have some kind of access. So here I went ahead and pulled two users. As you can see, the user Musi has admin privileges. So if you look at groups, it says admin. And then when you look at the user GrayHat, they have it looks like S3 kind of stuff where they can access S3 buckets, right? So imagine being able to get keys to GrayHat, which I actually was running this command off of the GrayHat user, and I was able to discover the admin user. So what if I was, an attacker, I would want to see how I could get to to the user Musi. And there's a lot of different privilege escalation techniques we could use, or we could, try to go actually locally find that user and target them. You can use your imagination, but this is a, pretty typical way of how initial access is compromised and gained. So now we're going to start to look at some different things. So we looked at how keys are compromised, how we get initial access, right? So now let's actually start to talk about some of these policies that we've talked about, right? So to kind of summarize before we get into the policies, we've talked about, AWS, the services. We've also talked about common misconfigurations, as well as how, an attacker or a pen tester will get access or needs access to do testing. So obviously, by the way, a threat is not going to just test. They're going to be doing a lot more worse than that, right? So public bucket blocks, right? Never good. If you go and rummage the internet for anything that talks about AWS leaks, a lot of times it's going to come through a public bucket. Allows anyone access to the resources on that bucket. Remember, a bucket's just like a file in the cloud, right? And so if it can be accessed on the internet, what that means is that anyone on the internet can go into that file, or that folder rather. So sensitive data stored in public buckets by mistake. Or is it? So when you think about it, the scenarios that I always like to say when you find a public bucket is saying, okay, the admin put a public bucket out there for, non-sensitive data to get put in. However, someone who is not so tech savvy may have accidentally put some kind of like sensitive data in it because they needed to get it into a file repo really quick, and they just put it in there by accident, realized they put it in there by accident, but didn't know how to delete it, and they went to the next thing, right? And didn't think anything about it. So when we look at this policy and you think about the things that you could store in it, and you can use your imagination based off what I just said, you can look at the policy itself and realize that you can see all these things set to false. What that means is that there's no access control on this, and that we can pull anything from the bucket, including sensitive data, if it accidentally gets stored in there, which is obviously a big no-no. So when you're going out there and you're doing your AWS pen testing, and you're looking at buckets within an organization, one of the first things that you want to do is look for anything that has a public access block, right? And so you can see the command here highlighted in yellow. That's going to pull information off of a target bucket. In this case, we're doing it off of GrayHat public, which for the scenario is the bucket that we had. So to illustrate, too, that this isn't just something in a controlled environment, right? Because that was just a bucket that I spun up really quick and attached an open policy to. I went ahead and attached some screenshots from a tool called GrayHat Warfare. And GrayHat Warfare is a S3 bucket tool on the web, and I'll make sure to put that in the Discord for everyone, where you can actually go on the in here and just, it's like a query engine, as you can see here, where you type in a keyword, you type in some file extensions, and that's it, and you click search. So here, all I wanted to do was look for public buckets on the internet without like any kind of target organization. Just look for public buckets that had the keyword passwords and the extension was txt. So essentially, I'm just looking for password files that are stored on an open bucket. Well, I blanked out the full file path or the full Amazon resource name to the actual file, but as you can see, this is 4 buckets, and I can tell you when I did that search, I got a lot of buckets, right? And you have to kind of go through and see if there's something there or if there isn't, and if you do find something, make sure that you report it. Which I actually found something and I immediately reported it, so that's good. Hopefully that gets fixed. But what I wanted to mention is that, this doesn't just happen in controlled environments. You can go on tools like GrayHat Warfare or just do a public bucket query on your own, and you'll be able to find a lot of stuff just open to the internet that has sensitive data in it. And in this case, I only showed four buckets, but when I looked it up, there were hundreds, if not thousands, of buckets that fit this description. So it's a pretty common issue. So some more policies. So remember how I said if you can write, it ain't right, right? If you can write, it ain't right. So I did blank out some things here, and I actually pulled. I was having some trouble writing my own policies to fit this. So, but I pulled some screenshots from some labs that I had done, and wanted to illustrate some common issues. Right. So the issue here is that, as we can see, there's an ID and a display name. The display name is blanked out because that's the user. However, as you can see, it says permission to write ACP. So that's writing to the access control policy. Remember, if you can write, it ain't right. So essentially what this is saying is that this user can write to the access control policy and allow other users. So guess what? Now that user writes to the access control policy and allows full control. So they went from being able to have some kind of restricted access based on the ACL to now having full control. So again, going back to the last screenshot, first they could only write. Now they have full control and can do whatever they want. They could knock off other users. They could deny access and essentially create a denial of service to the resource just because they were able to write. So when you go out there and you do your AWS pen testing and things like that, make sure that you're pulling ACLs as well, because that's going to show you based on the users of what they have access to. All right, so another common policy, and this one in my mind seems silly. However, we do see it. So this is actually a very, very overly permissive policy attached to Lambda. So remember, Lambda is, code in the cloud, allows you to write and execute functions that allow you to do a lot of different things, basically whatever you want them to do. So what this is saying is that where it says all actions by all resources. Essentially what that says is that it can do anything. It can write, read, execute, whatever on all resources within that environment connected to that Lambda function. Now, you might be thinking that sounds like absurd. Why would you have that? Because it's easier when you're developing Lambda functions to just allow them to do whatever they need to and not have to worry about all the security, because once you start implementing security into them, it makes configuring them a lot more difficult for engineers and administrators. So this is actually a very common issue that you will come across where you see where all actions can be performed, as well as you notice here, this is more directed towards a Lambda function where the Lambda function is allowed to do whatever it wants to. And so I think, what was it, a couple weeks ago from recording this, I did a workshop at ShellCon where I actually showed the attendees how you could get a reverse shell based off of an overly permissive Lambda function. I also have a write-up of how you could do it from a functional testing standpoint. I'll make sure to put that link in the Discord. But know that if you go and look at that walkthrough, that all derives from weak policies built around Lambda functions. And it's not just with Lambda functions, right? We've seen that it's with S3 buckets, and then just know that it's not with even just those two services. It's with any service that you can configure a policy and an access control list to. And now, I'm going to take another sip of water. So now, we're looking at a policy that we're actually going to do a demo on. So this is going to be pretty cool. So let's really look at this. So this is a policy that we pulled from a target bucket. We'll say that we were doing a pen test on a target environment. We discovered a bucket, and so we pulled the policy off of that bucket. if you look at this policy, and we'll highlight some things in the next screenshots, just take a second to look at it. Notice the actions, what it allows, what it doesn't allow, things like that. All right, so really take a second. Wish I could cue some Jeopardy music or something like that. All right, hopefully you caught that. All right, so notice what we got highlighted in yellow. It says action S3 get object deny. So what that means is that we can't get the object, right? The object is that file. Notice how it says GrayHat passwords / passwords.txt. We can't get that passwords.txt, all right? And we want that passwords.txt because we want to prove that we're able to exfiltrate data, right? That's the big cool thing when in pen testing, you know, besides getting a reverse shell or an RC, if you can exfiltrate data, that's, you know, always a win for the pen test team, not such a win for the target organization, right? So really remember that, because we're going to look at that again in the lab, or the demo, rather. And then look at the action that is allowed. We can get the bucket policy, and we can put the bucket policy. So what that means is, because we were able to get the bucket policy, that's why we can see what we see here on the screen. But we can put a bucket policy. So really think about that. In an admin standpoint, that sounds pretty reasonable, and it sounds normal, saying, oh yeah, I gotta get the bucket policy so I can read it, and so I need to know if I can add, you know, user Timmy and Jimmy, and then I'll put a new bucket policy that has them on it. That's cool, great, awesome. However, remember how we had the GrayHat user, and then there was the Moosey user? Imagine being able to escalate privileges to that Moosey user, or being able to discover that Moosey user that, you know, might not even be affiliated with this account, but yet they could actually, you know, take over this bucket policy. So remember that when we're doing the demo here in a second. But just know that this is actually a common thing that you would see in an AWS environment, and it's not good. And we'll see here in a second. So I wrote this cool little description in PowerPoint. It's not my best work, but it'll do. So I wanted to go through the steps of how we would bypass the policy that we just saw screenshots for. So an attacker would attempt to grab objects from the bucket, right? The bucket policy doesn't allow you to get an object, but it does allow you to put that policy. So remember, we're trying to get the object, which is the password.txt file, but we can't get it. So let's see if we can put a policy. Okay, so an attacker would modify and upload a new bucket policy with the ARN of the target bucket. The ARN is the Amazon resource name, which we'll show you here again a second in the demo. And then the attacker puts a new policy on the bucket, right? So we the attacker, or the attacker, would take that bucket policy, amend it, and then put a new one on there, and the attacker is able to exfiltrate data from the bucket. And now it's time for a demo. So I'm going to move my screen over here. And now that we're over here with my head adjusted, now we're actually going to go in and we're going to do the demo. Demo time. Sorry, had to do that. All right. So you should see my Kali machine here. So let's go ahead and we're going to assume that we have access to the environment, right? Because we're looking at and doing a functional test. And let's go ahead and list out some of the S3 buckets that we got. All right, so we can see that we have the GrayHat public bucket, and then we have the GrayHat passwords. So we looked at the GrayHat public bucket in the slides. That showed us that, you know, anyone on the internet can access that bucket. It's no bueno. So we're not going to really worry about that in this demo. Just know that that was the one that where we can, you know, essentially if you wanted to scale it out, you could think about it where you go onto the GrayHat warfare tool and start looking at public buckets that you could use for a target organization or rummaging the internet. So what we're going to be doing is we're actually going to be targeting this one, the GrayHat passwords bucket. So let's go ahead and we're going to call the bucket policy for that bucket. And notice how we get this jumble of stuff. It's great. It's awesome. It actually tells us what we need to do, but it's not very readable. So let's output it a little better. We use that with output text, and then I like to use the JSON tool or the JSON tool module built within Python. Is it JSON tool? Oops, not tool. And there we go. We got a better bucket policy here. So as we can see, we have the GrayHat passwords.txt, or well, the passwords.txt file here, right? But we can't get it. Or so the policy says. However, of course, we're pen testers, so we want to check and see if we can get it anyways. So let's go ahead and see if we can get that. So first thing first is we want to call the bucket. Now we see the file stored within inside the bucket. And now let's see if we can actually copy that. So we're going to go back, copy that file. And I did something wrong. What did I do? I think I did it right. Didn't I? Oh, I missed. I need to try to store it into my local machine, and we don't get that. Notice how we get the forbidden. Right? So essentially what we did is we tried to copy this file right here, passwords.txt, from this bucket, the GrayHat passwords. Tried to put it into our local file directory right here, but we weren't able to do it. Why? Remember, we're denied access to that resource. So let's go ahead and let's pull that bucket policy one more time. All right, so now what we're going to do is we're going to do a simple copy of the bucket policy. So now you can open up any kind of like text editor that you want to use. I like gedit and VI. I'm going to use gedit for this, just because it's nice and colorful and it's easy to read. All right. So let me see if I can. So now, if you see the policy here that we've put, notice how we've just copied the policy that we were able to pull from the bucket, right? Because we were able to get the bucket policy. It's the same thing, only notice here how it says deny. So now what we're going to do is we're actually going to switch deny to allow. And what that's going to do is, essentially, in theory, it should allow us access to passwords.txt. So we're going to go ahead, we're going to save that. And now let's clear this out so we don't have so much mess on the screen. Let's go ahead and reevaluate this, pull the bucket policy again. And still says deny. And I'm recording this late at night, so my head is a little fuzzy. We actually need to do one more thing. So now what we're going to do is we're actually going to put the bucket policy. All right, so we have to put the bucket policy from our local machine. So how we're going to do that is we're going to go AWS S3 API, and then we're going to put the bucket policy. Right, and now we need to annotate the policy that we're going to be doing. So we're going to go policy root GrayHat, and then policy.json, right? Because that's the policy that we made, and now we're going to be putting it on the bucket GrayHat passwords. Okay, so essentially what we're doing is we're putting the bucket policy, and then we're calling this policy. So we're calling this from our local machine, and we're putting it on this bucket. And since we didn't get any like kind of like error or anything, that means that we should be able to get the object, right? We should have been able to rewrite to the bucket policy, or rewritten the bucket policy rather. So to do that, let's go ahead and just verify that we're able to get or change the bucket policy. So now we're going to go ahead and pull the bucket policy again, and notice how now it says allow. So pretty cool. So now we should be able to get this in theory. So now what we have to do in order to get it is we just go back. We're going to go back to that other command and see if we can get it. And notice how we were able to actually download it. We cat out the passwords. And don't let anyone at GrayHat see these passwords. admin. Seriously? So that's essentially in a manual kind of sense of how we could actually pull the policy. There's a lot of other different techniques that you can use. You can write a script to pull this if you want. I think I actually I have this other tab open where I've written a Python script to where if we wanted to try to pull it, we could. So it shows the existing buckets. We want to see if we can do this one. So what bucket would you like to check? Please choose from the list above. We're going to use GrayHat passwords. It's going to give us this stuff. I'm still trying to figure it out, see if you can pull it a certain way to make it in the more fancier output way. But still the same thing. It says that we're able to get the object and able to put the bucket policy and get the bucket policy. So does the bucket allow you to put a new bucket policy? We would type yes. And would you like to steal the objects from the bucket? Yes. So it's going to list out the buckets that are, the files that we want to steal. So we'll go ahead and steal these. And would you like to upload a proof.txt to show that, hey, we were there? Sure. And it says that, yes, okay, we won't upload anything. That might just be an error. And now we should be able to, if we go back, we can list this out. And it didn't pull it. Or I'm sorry, it didn't put the proof.txt. So need to make a couple edits there. But essentially, in the long run, what we were able to do was we were able to pull that bucket policy, put a new bucket policy, and get that password.txt. So that's the demo. Now let's go back into the slides. So what did we learn? Bad policies equal a bad time. Ensure that your policies are not overly permissive. So when you're out there, hacking the cloud, so to speak, make sure that you're looking for these weak policies, these policies that are going to allow you to read and write. Again, the keyword is write to any kind of service and the policies within that service. So AWS does not ensure your security, you do. So when you're working with your clients, you're working for your organization, and anything in there in between, make sure that you're checking policies regularly. Again, regularly, because remember, the cloud is, you can scale up an entire infrastructure in less than a day. So services will be spun up, instantaneously without anyone being notified. So make sure that you're regularly keeping track of everything that's in the cloud within your organization and that it's being tested and checked. And then, to finish off, I wanted to talk one more time about my book release. So my book, AWS Penetration Testing, it is supposed to be released on December 9th. You can go pre-order it now on Amazon.com and packpub.com. I do have a cool fancy discount code here. So as you can see, it says 20 pen test. If you go and buy this on Amazon, and unfortunately it is only for US only, but if you go and buy it on Amazon and you put in that code, you will be given a discount. I believe it's 20%, hence the 20 pen test. Don't quote me on it, but I believe that's what it is. So it'll save you a few bucks. and you can be on your way to learning how to pen test AWS. I'll also put a link here in the Discord chat that will allow you to sign up in the free sign book raffle. So if you want to sign up for that, go ahead and fill out the information in the link that I provide. And then that's pretty much it, everyone. From here, I'm here for your questions. Looking forward to it. I'm in the Discord, or, you know, even hanging out here in the virtual world. Just kidding. So, you know, once again, thanks again for coming to my talk. I really hope you enjoyed it. Really hope it, you know, is a baseline to help engage you into more constructive and effective AWS pen testing. And I look forward to your questions in the chat, and I appreciate you coming and stopping by my talk.
right, welcome back, everybody. Our next presenter is Liron Gray. Liron is a big supporter of the Red Team Village and the hacker community. Leroy, personally, I want to thank you so much for all your support throughout the years. And well, enough about talking in here. I will let you introduce yourself, and the floor is yours. Take it away.
Thank you. Appreciate that. It's a nice intro. Very warm and welcoming. So this is a live talk, if you can't tell. So I will be monitoring like the Discord this entire time because I have it up on the screen, and we can chat while I present these slides to you. If you happen to have seen this talk, I did it, I think, recently. It's pretty much the same content, but now we get to enjoy each other's company, and we get to do all the demos and all the cool stuff. All right, so this talk is called Y'all Trying to Enumerate Azure AD in ARM or Not. This is part of my Y'all Tryna series. I think previously, the last Red Team Village, I did Y'all Trying to Bypass Python 3.8 audit hooks or not. And so I'm just keep this trend going. Ooh. Yeah. So who am I? So my name is Laron. I work on the Azure Red Team at Microsoft. I also go by Daddy Coco Man. So if you see that in the Discord, in the Slack channels, anywhere, you can come say hi to me. DaddyCocoman.dev is my website, and you can also check out my GitHub. I'm also a nerdcore rapper by the name of Oh My. That's an Ohm with an I. You can check out my music too. The musicians always got to promote their Bandcamp and SoundCloud, so obviously I have to do it now during this talk. I was in the Navy for 10 years, and I love Python and Pythonic things. So the agenda for today is we're going to talk about Azure Active Directory. We'll talk about Azure Resource Manager, and then tools for how you interact with both of those services, and as well as a demonstration of Storm Spotter. If you happen to have some knowledge of AAD and Azure, I guess, as a whole already, some of these things are really basic to you. I'm going to be covering the really basic concepts of AAD objects and ARM resources and stuff like that. So if you happen to already have some Azure knowledge, this might be a refresher. You might learn something new. Either way, let's get learning. So Azure Active Directory. There's a bunch of different object types in AAD, right? Azure Active Directory is a access management and identity service that's used to manage your access to resources, as well as your identities in the Azure cloud. So it's basically like Active Directory, but it's in Azure, and it's called Azure Active Directory. Wow. So the AAD objects that you'll find are users, which are the standard members, and you log in as a user as your identity. You have groups, which are a group of objects that includes users, groups, service principals, and any other objects that you would find in AAD. You have applications, which are used to create a template of a service principal, and we'll talk more about that a little later. Then you have service principals, which are a local representation of a global application in a single tenant. This is very important, and we'll talk about this later. But understand the difference between applications and service principals are that you can have an application anywhere, and you have a service principal within a tenant. And then you have devices, and you can have managed devices that can be added to Azure Active Directory. And then you have roles. And roles are the permissions that are defined for those Active Directory objects. So some examples you might find are directory members, global administrators, user account administrators. A lot of these roles have administrator at the end because they show that there's some level of privilege associated with having them. So for AAD users, we have the standard users. They can be internal or external, right? An internal syntax for a user will look like alias at tenant.onmicrosoft.com generally. An external one will look like alias _ the home tenant Octothorpe, ext Octothorpe at tenant.onmicrosoft.com. And so when you're looking at Azure AD, you can clearly see who's a guest user. And by guest, it means they're external to your tenant. And you can see who your normal tenant managed users are. So for example, you can have Laron.gray at stormspotter.onmicrosoft.com, or I have Laron.gray _Microsoft.com, which is my home tenant for work, and it will have the ext suffix to it, at stormspotter.onmicrosoft.com. So AD objects have what's called an object ID. And this is how within Azure, these objects know how to talk to each other, right? They don't really go by like any specific name. There's a unique ID for each of these objects so that it references that specific object and that specific instance of Azure AD. So here we have Kelly Santana, who has his object ID starting with DA8, and Azure will refer to this Kelly Santana object as that object ID. Then we have groups, and groups are, as I mentioned, a group of objects, right? So you can have users, you can have groups, you can have devices, you can have service principals, you can have managed identities, and all these different objects can be considered under one group, and that group, of course, because it is an AD object, is given an object ID. So you can check the members of a group, right? On the left side, we have this is the members of the group, a group called Sales, and we see Caroline Harris, Catherine, Jason. We see another group in there called Sales Cashiers. So now we have nested groups. Then we have Kelly, and then we have Kyle. And if we were to look at all the members, which are unrolled, then we can see that we get 3 additional members, Johnny, Kristen, and Dave, who happen to be part of that Sales Cashiers group. So now you can see the difference between having your normal listing of members of a group, and on the right side, you can see an unrolled listing member of the group, which is really important later when it comes to how privileges are provided. Normally, when you have nested groups, you can find yourself in trouble in any, like even Active Directory, you find nested groups and permissions start going all over the place. And groups can have owners, right, who don't have to be members of the group. So in this case, there is a group called Sales, and the owner of the group is not only Kelly, but a service principal called Sales AED SPN. So that's just something to note, that groups, you don't necessarily have to be part of a group to be the owner of a group. It's like having a domain group and not actually being a part of it, but having permissions over it. Then we have AD applications. So these applications are templates that are used to create service principals for authentication purposes. Applications can be single tenant or multi-tenant. This is very important because multi-tenant apps will be homed in the tenant that they were created in, but the service principal will be created in the target tenant, which means things like Microsoft first-party applications, right, are hosted somewhere in one of Microsoft tenants. But when you use that service in your own tenant, you get a copy of that service principal. You get a service principal, which is a replication, representation of that application, and it's able to get permissions for your own tenant and your own resources. When you create an application, you have that option to be single tenant or multi-tenant. If you are doing something that is multi-tenant, just know that it is available to all tenants by default, whether you own it or not. So that's something to be aware of. In your code in the back end, if you wanted to like secure that, you would have to specify which tenants are allowed to access this application. So here's an example of an application, right? It has SPN in the title because I created the service principal, and the application was also created with that service principal within my tenant. Of course, it has the object ID, and more importantly, it has an application ID. So the application ID is that representation of the application as a whole, and it will always be homed to the tenant that it was created in. So AD service principals, right, are an instance of an AD application somewhere. Like I mentioned, the application doesn't have to be in your own tenant. It can be in someone else's tenant, which is why like you hear about malicious applications that people are making in order to, phish for, Office 365 credentials or whatever, stuff like that. So there are some legitimate uses. There are a lot of legitimate uses, but of course, some people do take advantage of that and having those multi-tenant applications. So the service principals are essentially a service account. You can add credentials to the service principal so that you can log in as an identity that's not a user. The 2 types of credentials are passwords, like so straight up password string, or certificates. If you create that SPN directly, it will also create the application, which is why when I created the AD SPN by name, it also created an application of the exact same name. So on the left, we have the application, which has the application ID. And if you look at the service principal, which is the representation of that application on the right, we have the object ID, which is that service principal, but it also says that the application ID that it's tied to is the same as obviously the application that it's associated with. If you were to look at an application that was outside of your tenant, those application IDs would still match, but the tenant ID would be different because it's under a different tenant that's not yours. Then we have devices. So we have AAD joined and AAD registered devices. So joined are something that's typically a corporate resource, right? You have a desktop that's owned by the company. And so you have those devices that are AAD joined. Then you have registered, which is typically bring your own device. So if you have a cell phone that has a work profile or something like that, you'll be able to see AAD registered, right? Meaning that the company doesn't own the device, but they allow it to access resources based on some AAD identity. So here's an example. Here I have one Azure AD joined machine, Windows machine, excuse me. And then I also have 3 Azure AD registered devices, 3 of which are mine, right? One is a VM and the other 2 are a mobile device. So I have AAD roles as well. And these roles are very important when we talk about permissions because they help define what the permissions are for these AAD objects. And built-in roles have a predefined set of permissions. You can actually look this up in the documentation, but custom roles can be added, but you should make sure that if you create a custom role that you aren't giving it too many permissions. A lot of the permissions are already covered by built-in roles, so you should definitely check that out before you start building custom ones. So for an example, here are some of the built-in roles, right? We have conditional access administrator, which manages your conditional access, right? As the name implies. The most important one, which is highlighted here, is the global administrator, which is basically like your domain admin level for Azure, right? That has all the power to do almost everything, right? There's still one step above that for escalation, but global administrators have that ability to escalate to that privilege almost pretty freely. And there are all these other roles that have administrator in them, again, because they show some level of privilege. Right, so here's what role permissions look like. Here's a role called help desk administrator, right? And this user can change passwords and validate refresh tokens and basically manage the type of stuff that you would expect from a help desk, right? You call the help desk up, you want to get your password reset, something like that, and it's pretty great. These permissions have a namespace, right? They have an object in the namespace, and they have a property and an action. So here's a very user-friendly version of the description and the role. But if we look at what's actually happening underneath, you have these namespaces like Microsoft Directory, and then these objects like users. And it says that the help desk administrator has the ability to validate all refresh tokens for users, or they have the ability to update passwords for users, or read BitLocker recovery keys if you keep those in AAD. So you can look through the permissions that are under each role and get a better understanding of what it actually allows you to do. And it's very important that you don't provide permissions that are too permissive. You always want to keep that idea of least privilege in mind when you're associating these roles with AAD objects. So let's talk about Azure Resource Manager. So Azure Resource Manager is the deployment and management service for Azure resources. Right? It used to be called ASM. There's a book out written by Matthew Burrow, who works at Microsoft, called Pen Testing Azure Applications, or something along the veins of that. And you might hear something like Azure Service Manager. Now it's called Classic. That's what we refer it to. So when we talk about like classic resources, we're referring to the older style of Azure Service Manager. But now we have Azure Resource Manager. And the way it works is that no matter how you connect, how you want to talk to Azure, whether it's through the portal, which is portal.azure.com in most cases, whether it's through PowerShell, the CLI, or through some of the direct REST clients where you're making direct API calls, it all refers to this set of APIs at the Azure Resource Manager level. And these resource managers will talk to what's called a resource provider and perform some action on that resource. So for example, there's a resource provider for data store, there's a resource provider for web app, virtual machines, and service management, and all these other services. And the Azure Resource Manager will talk to those providers in order to help manage your resource. So there's some terminology you need to know. A tenant is a representation of an organization. And that doesn't necessarily mean that you have one tenant per company, right? A company can have multiple tenants, but it represents some, usually high-level organization or some sort of environment, or whether it's like a production environment or a testing environment inside of a organization. It's really up to the company how they want to organize their own tenants, but that's usually how it's done. And then you have subscriptions. And subscriptions are a logical collection of resource groups, and they're usually separated for billing purposes. So if you have a company where you have a sales department or an IT department, you might put them under separate subscriptions in order to make sure that, certain departments get certain funding, and then, making sure that they're not, spending too much money or whatever. And then you have resource groups, which is a logical collection of resources. It's pretty self-explanatory, I think. And then resources themselves are any manageable item in Azure. So that includes virtual machines, storage, key vaults, but also it includes subscriptions and resource groups, because those are also considered manageable items in Azure. So is a tenant for the most part, but subscriptions and resource groups are also considered to be a resource in the pure terminology of it. And then we talked about resource providers a bit, and that is a service that provides for a type of resource. So if you create a storage account, then you've allowed the Microsoft.storage resource provider into your tenant. And then we have role-based access control, which is the permissions that a user can take on any specific resource. And that resource is defined in what's called the scope. But these are not the same as the Azure Active Directory roles that we talked about earlier. So here's an example of some resource providers. And every resource, right, has one, right? It needs something that says, please go give me this resource and, allocate this space for me. So you have things like, Microsoft.batch if you're using the batch service, or compute if you're using like, virtual machines or functions and stuff like that. The ones I have highlighted here are the ones we call the classic resources, right? That came from Azure Service Manager in the past. So, for example, we have Microsoft.compute for current VMs, but if you have some of those older VMs, then you have the Microsoft.classic compute, or you might have a Microsoft.classic storage if you have the old ASM storage accounts. Just something to note, not particularly important for the rest of the talk, though. Then we have what's called the control plane versus the data plane. So operations in ARM are divided into two categories, and that's the control or management plane and then the data plane. So the control plane is for managing the resource within ARM, and those requests are sent to the resource provider. The data plane is for managing the operations of the resource within the resource provider. That should be resource provider at the end. So for example, on the control plane, you can create or delete a virtual machine. When on the data plane, you can RDP to that machine, right? On the control plane, you can create and delete a storage account, but then you can read, write data to the storage account on the data plane. So you can kind of see where that's going, right? The control plane is management of the resource, and the data plane is management of the data within that resource. This is a very important concept for role-based access control, very important. So role-based access control is the authorization system that's built on top of ARM that allows you to provide identities access to Azure resources. It's based on three parts. You have the security principal, which is an AD object. So it can be a user, it can be a group, a service principal, a managed identity. And I forgot to add the slide again, of course, but a managed identity, we need to talk about this, but a managed identity is an identity that you can give a resource so that it can interact with your other resources. And that identity is managed by Azure Active Directory. So for example, if I give a virtual machine an identity, right, I can say this virtual machine is allowed to talk to this storage account or this key vault. And that identity is managed in AAD. It's very similar to how you hear about like the AWS metadata instance, right? You connect to that IP and you grab the access token. It's exactly the same concept. And so you have those security principles, and then you have the role definition, which is the collection of permissions that you're applying to this security principle. And then you have the scope, which is the set of resources that you're applying it to. So some general roles that you might find are contributor, owner, and reader. You'll probably see these three the most because they're very generic. And a lot of people, when they first look at Azure, are looking at these because they're very basic and they're easier to manage. But what you want is something that's more specific, right? You want the specific RBAC roles because they allow you more control over what you can do with not just the management plane, but also the data plane. So for example, if you look at storage, right? If I want someone to be able to read, write, and access on have those permissions on Azure file shares, that I can give them directly the storage file data SMB share contributor. So that would give them the ability to just have access to that share without giving them access to everything else that comes with the storage account, whether it's on the management plane or the data plane. And those, once you start getting into those specific RBAC roles, you should make sure that you are applying them correctly. As I mentioned, role definitions can affect both the management and the data planes. The way that they're defined is by what's called actions and not actions. So actions are something that you can do on that plane, and not actions are something that you can't do. But it's important to note that not actions are not like an implicit or explicit deny, right? If you have something that is in your actions and you also have something that is in your not actions, you actually have the actions will actually take priority. So if you happen to have some overlap somewhere, since you do have that access in your actions, you are able to do it. Right. And management access is not inherited to your data. That's why they're separate. So the actions do not imply what's in the data actions, and the data actions define what you can do with your the data plane kind of stuff. So in the storage blob data reader, we have the ability to read the containers, which is at the management plane, but we also have the ability to read the blobs within the containers, which is at the data plane. The permissions to read the containers in the storage account does not give you permissions to read the blobs and the containers in that account. So you have to manage these permissions separately, right? If you were to individually assign this, you have to understand the difference between those. So here's an example of what an action on a resource might look like, right? This one is a storage account. And if I wanted to take a snapshot of a blob, which is sort of like a version control thing that's offered in Azure Storage, that I need the permissions to write to blobs, and I need the permissions to add, or I need the permissions to take an action on the blob. And that's the fourth line here. I should have highlighted it. Sorry about that. So an action that you can look up when you start looking in through Azure documentation is assign these set of permissions, and you have to make sure that the permissions are what you're looking for. I'm going to give you an example. Sometimes the names of these roles can be misleading, right? So here we have storage queue data reader, which allows you to read and list storage queues and queue messages. And someone hit me up about this about like 2 weeks ago, and I was trying to look through, and I tried to find as much information as I could for them. In this case, what they wanted to do was they wanted to be able to read messages, right? And they gave it this permission for data reader. They wanted to be able to get the messages, right? So when you get something from a queue, it requires you to read it, but it also requires you to delete it, right? You're popping something off a queue, so you have to be able to delete it. Well, the reader role only gives you permission to read, right? And get messages, in order to get the message, requires you to have either the ability to perform an action, right? An action process, or it requires you to have read and delete. So the reader role, does not give you the permission to delete. And so this wasn't the appropriate role for him to use because he wanted to get something from a queue. And it's defined here as well. What he was actually looking for was the storage queue data message processor, which allows you to either read or take some action, or you could have created a custom role to define those two actions themselves. But it's just important to know that sometimes the name of the role doesn't always do what you think it does. So it's important that you look at the actual permissions that are associated with those roles. So here's an example of applying some RBAC to a group, right? We have these 80 objects that are part of this marketing group. And the marketing group is assigned contributor access to a scope, which points to the pharma sales resource group. And the marketing group has full access to all the resources within the pharma sales resource group based on the contributor access. But contributor does not allow you to assign RBAC roles to others. So if you wanted to be able to do that, then you need the owner level, which is one step higher. So interacting with ARM and AD and ARM. There's a lot of tools out there. The most common one that you'll see, right, ever is going to the portal. So portal.azure.com if you're in Azure Public, or here's some of the other links that are associated with their specific Azure instances. Then you have the CLI. The CLI is written in Python, and you would log in with the AZ login command. When you do that, you have access tokens that are stored in your home folder /.azure/access tokens.json. Now, it's important to note that because the Azure CLI is written in Python, when you install the Azure CLI, you're also installing Python on your system. So if you're worried about being, your host security, right, and not being able to see what people are doing, it's just important to know that there is an instance of Python on your system if you're installing Azure CLI anywhere in your network. And this is what it looks like, right? I can list the key vaults that I have in this particular subscription, and it's pretty self-explanatory. You have the AZ command, and then you have the resource type, and then you have some action on the resource. Here's another example. I can also interact with Azure AD. So here I'm showing the user Kelly Santana. We also have PowerShell, and there's a lot of PowerShell modules for Azure. So we have AZ PowerShell, which is the newest version for interacting with Azure, and this is what I recommend that you use. It can't coexist with the Azure RM module because there are some conflicting things underneath. I'm not entirely sure what they are, but they just tell you that you can't use it with Azure RM. And the command syntax that you would see is connect-AZ account if you were to log in. The AZ PowerShell always has the verb in that PowerShell commandlet is always starts with AZ. Azure RM is the older version, which is now being deprecated, or at least you should. If you have Azure RM in your environment, you should try to update to AZ PowerShell. And it obviously can't coexist with AZ PowerShell, and the syntax for that verb would include Azure RM in it. Then you have Azure AD, which is for how you interact with Azure Active Directory. It currently works with Microsoft Graph. If you had the newer version, a couple of versions ago, which is just a couple of months ago, it did not. Azure AD also works with PowerShell Core. And the reason why you should use this now is because there used to be a PowerShell module called MS Online, and I've seen a couple of blog posts mention it and use it for like talking to Graph. That one has been deprecated, so you should move up into the new Azure AD PowerShell modules because it has everything now that it didn't have a few months ago. It also doesn't work in PowerShell Core. And then you have Azure PowerShell, which sounds like what you would want if you were interacting with Azure, but it's not, because that's only used for classic resources. So it was created originally for the Azure Service Manager, and it still works, right? If you have classic resources, this is what you need to use in order to interact with those. And we talked about like the resource providers earlier, right? If you have those classic resource providers, you should be using Azure PowerShell in order to interact with that. Then we have the Azure SDKs. They come in a bunch of different languages. They're broken up into the management plane and the data plane libraries. And there's also been a lot of refactoring over, especially this year. So if you happen to have some older scripts or tools, you should make sure that you test the new libraries before you implement them, because a lot of things have changed, including managing identities with the SDKs and how a lot of the properties of the objects that represent resources work. So if you're making something new, like this isn't a worry, but if you have something older and you want to update, just make sure that it'll actually work and is compatible with how you've managed your code. If you go to azure.github.io/Azure SDK, you get a list of the SDKs, and you'll get a list of the libraries and their current versions. And then you have the REST APIs, right? And there's a lot of APIs, so we're not going to talk about all of those, but just read the docs, fam. Like there's so many, and they tell you what you need to send. They tell you what you're going to receive. You can check that out on docs.microsoft.com. Let's talk about StormSpotter. So StormSpotter is what people have been calling, and the day that I posted this and it went out on Twitter or whatever, people were calling it's Bloodhound, but for Azure. And that's basically what it is, right? It creates an attack graph of Azure AD and Azure Resource Manager, and it puts all that information into a Neo4j background or database. It's written with Neo4j in that mind. It's also written in Python, and it has a front end that's now written in Vue. So it enables red teamers and pen testers to visualize attack surfaces, similar to how Bloodhound does. And I'm sure most people here are familiar with Bloodhound. So you can visualize an attack surface and some pivot opportunities within any given tenant. It can also be used for the same purpose for an audit, for someone who's doing an audit or some defender to look and make sure that things underneath the permissions granted to to identities aren't too broad, right? Make sure that you're following that least privilege implementation, all stuff. So make sure that defenders can also use StormSpotter to do the same thing that an attacker would and have that same viewpoint. It's not an official Microsoft product. It's not an official Azure product. I saw a lot of people calling it Azure StormSpotter, but apparently there's like a whole legal thing about like using Azure in names and stuff like that. So it's just StormSpotter. It's still in beta, and we are currently working on trying to improve it a lot for an official 1.0 release. But you can check it out now at GitHub. So why does it exist? Well, it's because you need to understand the configuration of your environment in order to understand the security of your environment. Relationships are easier to understand when they're visualized and not like in a Excel sheet or something like that. It's a lot easier to see something in a picture than it is to read something in text. And of course, Bloodhound is obviously like the standard for that, right? And that's what is proven that you can look at a graph and understand it a lot more than you would looking at all the CSVs that come from like dumping LDAP or something like that. So would you rather look at this output on the left, right? It's it's nice and colorful and all great, but here's a better representation on the right. So it would actually take 3 different commands to show what's in this picture on the right. The one on the left just simply shows who the owner of the service principal is, and it listed as Kelly Santana. So this query is against the sales AAD SPN, and as it just so happens, Kelly also owns that SPN as well, service principal. There are some requirements for using StormSpotter though. For AAD, you need to have read access to either Azure AD or Microsoft Graph. So Azure AD is what's considered a legacy permission, right? And we're not talking about Azure AD, Azure Active Directory as a service. We're talking about specifically the Azure AD permission in application, if you will, right? It's considered legacy because it uses graph.windows.net as opposed to graph.microsoft.com. Microsoft is trying to move everyone over to MS Graph because Azure AD will be removed at some point. But for the purposes of StormSpotter, we actually try to use the Azure AD permission first because there's more information in there that hasn't been yet replicated to MS Graph. And eventually, once all that information moves over, then they will just use MS Graph primarily. But until then, it tries to use Azure AD and a specific API version in order to do the enumeration for AD. If we look at Azure Resource Manager, you need to have reader access to at least a subscription. And that's because enumeration of resources occurs at the subscription level. So if you were to log in normally and you see something like you don't have permissions to any subscriptions, if you're using Azure CLI and you have to use the allow no subscriptions flag, then in order to log in and to be able to interact with Azure, then this isn't going to work for you. You need to have at least subscription level access. And currently, only the Azure CLI logins and service principals are supported, but there will be support for more login types over the next couple of months. So I'm going to give you a demo of Storm Spotter, right? So we're going to say we found creds for a user named Kelly Santana. Maybe they posted their picture up and on Instagram of like their password or something and said, wow, look at my cool sticky note. Or I don't know, however we got it. We found some creds for Kelly Santana. And we've discovered that Kelly has access to read Azure Active Directory and also has access to some Azure resources. So we're going to look for a path for lateral movement using Storm Spotter. And keep in mind, everything that I'm going to show you can be done at the command line level, right? Or through some other tools that exist out there. But graphing is definitely the way to go. So let's where is my VM? There we go. All right. So I've actually already logged in as Kelly. It's up here in my prompt. And I can just show you. And so you can see here that Kelly Santana, we're logged in, and we're in the Storm Spotter tenant, which is indicated here. All right. So first thing I need to do is I've already gotten the tool from what's the place? GitHub. Yeah, got the tool from GitHub, and I've already downloaded it and all that stuff. Cool. So the first thing I need to do is I need to run the collector, and the collector gets all the information for you, and it puts it in some SQLite files. So in order to run it, we provide some basic binaries that are that contain all the packages, so you don't have to pip install anything or anything like that. They come in what's called the PYZ file, self-contained packages, Python zip app package. And so in order to run it, we can just do Python sscollector.pyz, and you can go check out the options in this if you wanted to. But I'm just going to run the CLI. And what the CLI does, the CLI option does, is it uses the currently logged in account for Azure CLI in order to do the enumeration. So the first thing it did was authenticate, right, with the CLI credentials. It successfully logged in. So it started to do enumeration for both Azure Resource Manager and for Azure AD. Notice that we went to graph.windows.net first, as I mentioned, right? If this didn't work, or maybe I was using a service principal or something that didn't have access to it, then I would go over to graph.windows.com. Oh, it is important to note that because Azure AD is now a legacy permission, by default, if you were to create a service principal, it doesn't have access to that. It will have access to MS Graph, and the access that you have are pretty simple. So you would have to, if you wanted to test this out, you would actually have to give yourself permission within Portal or something before you do this with a service principal. Users generally have access to AAD, so there's no worries there. So then it starts querying for all the different resource types, users, service principals, applications, roles, and groups. It finds a subscription, so it starts enumerating that. What it also tried to do was enumerate management certificates, which is a classic thing, right? So Azure management certificates for managing resources and subscriptions are sort of a classic thing. Generally speaking, you want to find this as a warning and not have access to it. If you happen to have management certs of that style, I would suggest, if you can, to try to update to newer resource types. But generally, like, this warning is fine, and you should expect to see this. If you don't see this, that's something that you should definitely look into if you are a pen tester or a red teamer, or even a defender, right? If you want to make why does this account have access to these management certs. Additionally, you'll find some, here are some resources that Kelly can see, but doesn't have access to be able to get information about, right? So they just printed out, it's could not access. And what these particular resources are I enabled Azure Security Center. The name has changed. Azure Security Center, I think that's it for this tenant. So she can't see these resources that are, or she can't access the resources that are related to the security center. You actually need a specific permission for that. So that's fine. Kelly knows that they're there, but can't really do anything with them. And then once the query is done, all the output gets put into a zip file. And if we were to look at that zip file, it might be kind of small in the stream, so sorry, but it's actually, popped up over here. It's actually just a bunch of SQLite files. So you get one per AED object. You get one for RBAC. You get one for the tenant, which contains information about the tenant and subscription. And you get one per subscription. And you can handle all this data outside of StormSpotter if you wanted to, right? All the information is now downloaded for you to use elsewhere in some other script. So that was one of the things that while I was rewriting this, we wanted to make sure that sort of decoupled what the ability to collect the information from the ability to ingest the information, so that you can handle this on your own if you wanted to. All right, so now that we have the zip file, we're going to start up StormSpotter, and it is Docker based. So I'm just going to Docker compose up, and it doesn't take very long. I actually deleted it just before this talk, so you can see how fast it actually comes up. I guess it's kind of cheating. I forgot to delete the cache, so maybe that wasn't a good example. Ignore what I just said. So anyway, so it's starting up. It started the backend, and the backend's sole purpose is just to parse the files, the resulting files from the collector. Then you have the front end, right, which is what you interact with, and then you have Neo4j and the background. So let's bring up browser real quick, which I thought I already had open, but I did not. As it wants to take forever to open. There we go. Yeah. And I'm going to bring this over here. There we go. I'm just going to go to StormSpotter real quick, which is sitting on port 9091. So here's our login screen. I'm going to make it a little bigger because I think resolution and stuff like that. So the default password is password. You can change that in your configuration if you want to. And it's going to log in. It's going to make sure that you have access to Neo4j in the back end. And immediately we see no results found. That's because we don't have anything loaded in our database. So let's add something. You can drag and drop here into this this field right here. So we can upload it directly. And it's uploading, and in the background, it's processing. So already we can see that there's some nodes coming in from this node summary database. At the moment, I still don't have a way to show you on the front end that the parsing is complete, but excuse me, that'll be done down the line. For now, if you wanted to look and verify, you could actually check on the back end, and it'll tell you that the ingestion was complete if you just look at the logs. All right. So the first thing that I want to do is, as an attacker, right? I want to generally when you open up like Bloodhound, you want to know who the domain admins are. Well, we can do something similar, and there are some preset queries up here on the right hand corner, and I want to know who the global administrators are, because that's the level of access that I would hopefully want to get to. And of course, it is ciphers, right? So I'm matching AD roles that are members of the group, company administrator. It actually wasn't the wrong password. I had accidentally pressed delete instead of enter. Whoops. So already I see that I have 5 global administrators. So it's labeled as company administrator. If you access ARM, or if you access ARM through like a command line tool, it's going to come back as company administrator. But if you look in Portal, it's labeled global administrator. This is documented stuff, so it's just something to note as I'm talking global administrator. Company administrator is the exact same role. And so we have a couple. I'm going to ignore myself, and we'll ignore my manager Craig for a bit, and then here are the 2 accounts that we're really interested in. We have one account called Chalk Olate, and as I click on something, right, it gives me information on the right side about that object, right? There are some properties that are are placed in the table. But if you wanted to see the entire object as it comes back from the ARM or the AAD endpoints, you can actually click on raw data. This is supposed to be like JSON formatted, and it's not working. I haven't figured it out yet, but for now, like you can look through and look at all the properties of this object. So we have Chocolate, and then we have Global. What a weird, unique name, right? And there's information about both of those in here. So next, I want to see me coming back. I know that I've logged in as Kelly. So what does Kelly have access to? And so we can look up AAD users, where the name of the user is Kelly Santana. Let's return that. I think that might be a little small, so I'm gonna zoom in just a little bit more for the stream. Right, and I've gotten this user back named Kelly, right? This is who I've logged into. So if I right click, right, I have a couple of options here. What I want to know is what Kelly has a relationship to. So I'm going to start from Kelly and I'm going to expand outgoing. And we get a couple of things here, which are really interesting, right? So we see that Kelly owns the sales group, and we show that earlier in the slides. Kelly owns the sales group, and Kelly also owns the sales cashier. So my logic, right, tells me that Kelly is probably the sales manager, right? So it makes sense that they may have access to all these sales related objects in here, right? I can individually click on each one of these, right? And show that Kelly has access to these sales objects. Makes sense, that's cool. But what's most interesting is that Kelly has contributor level access to this subscription called StormSpotter, which is really curious, right? Does Kelly need contributor level access in the entire subscription? Maybe, right? If this StormSpotter was sales, right, then it might make sense. But let's see what's in the StormSpotter subscription. Also notice that these icons, right, are based on the actual icons you would find in Azure, right? So here we have the icon of a user, the icon of a subscription, icon of a resource group. And so that's why I can, without really looking at any other thing, I can immediately tell what the resource type is. So under this subscription for StormSpotter, we have a couple of interesting things and all these resource groups. Most importantly, there's a resource group here called Glow, which is very interesting because we found a global administrator earlier named Global, right? So let's determine what's inside of this resource group. We're just going to keep expanding. We're going to build this relationship so that now we know that Kelly has contributor level access to the subscription. And this subscription contains this resource group, Glow. And under Glow, we have a couple of things. We have a key vault, which is entitled Lots of Creds, which sounds pretty interesting. I want to know what kind of creds that the global administrator is holding in there. But I also see that there's a virtual machine in here, right? So there's a virtual machine called I Like Being Admin. There might be some more interesting things in there for us to look at. So we can sort of already tell that that I Like Being Admin has this IP address. The way that I've decided to organize resources in StormSpotter is that if it is contained within a resource group, it's going to be a direct relation to the resource group object. But if I were to keep expanding this out, right, I've expanded the virtual machine, and it connects to a VNet, and it connects to a NIC card, to a NIC. And then you keep expanding all these objects out. You'll eventually get to the point where you'll see that here is the IP address for this I Like Being Admin virtual machine. So you'll get to that point eventually, but at first it may not just be clear. So I would suggest that when you are looking at IP addresses, you either expand incoming to see what they're attached to, or you expand outgoing from the virtual machine or the VNet icon. There currently is no VNet icon in here, a virtual network icon. It just hasn't been added yet, so it's represented by an X. It doesn't mean that the object isn't there, it exists. It literally means that I don't have an icon image for it yet. But so those will be added at some later point. All right. So but what does this mean though, right? So this means that Kelly, who is in sales, has the ability contributor level access. And if I wanted to see what contributor meant, I can just click on the edge and I can look over here and it'll give me the actions and the not actions. Whoops, didn't mean to do that. It'll give me the actions. Asterisk means everything, and not actions mean I can't do these things. And these are the permissions that will allow you to change the RBAC roles over a resource. And it tells me that I have full access to all resources, but doesn't allow me to access the roles for Azure RBAC. So that means that I, as someone who is a sales with manager identity, can go to this resource group and I can have, contributor level access. I can manage the global administrator's virtual machine, which is wild, right? So let's try something, right? I'm still logged in as Kelly. And I'm going to do this, right? I have AZ VM user update, and I'm going to create a new administrator on this global administrator password, right? As just, someone who is not in the IT department. And I need to give it the name of the virtual machine, which is I like being admin, the resource group, which is Glow. I need to give it a username, which is temp admin, and I need to give it a password, which is this is a secure pass 123 bang bang. I'm going to run this. So what I now have is an IP address. I have a username and I have a password. If anyone, right, this is kind of weird for someone who's on a red team to show all these things at once, but I'm not really worried. And the reason is because if you remember earlier, Kelly did not have permissions to see those security resources. And in those security resources, I have what's called a JIT policy or just-in-time policy. And I actually have to go myself to the portal and give my IP address permission to RDP into this particular resource, which I actually forgot to do and forgot to set up. So I'm going to do that right now real quick. Sorry about that. But in the meantime, right, we see that we have a new user called temp admin, and we've just given ourselves administrator level access to this VM. Excuse me while I set up this JIT policy. There was another thing. Well, I do this, I guess I'll just keep talking. There was another thing about the key vault, right? So at the management level, right, I have the ability to control things about the key vault, but I don't have access to change owner on the key vaults at the management plane. But on the data plane, things might be a little more interesting, right? So on the data plane, you have the ability to provide access to secrets or keys or certificates, and all that is something that might be of interest to you because key vaults are obviously where you keep secrets. And if you are a developer or something along those lines, you really should keep your secrets in a key vault because that is the best place for you to manage almost everything. Notice I'm still talking as I'm setting up this JIT policy because I forgot the password. Oh man. And then let's do this. And the request was approved. Okay, so now I have the username and I have the password and I have the IP address. So I'm going to RDP into this machine, not as Glow, but I'm going to do it as temp admin. I hope. When things go wrong in live demos. All right, there we go. All right, so I'm going to use a different account. I'm going to use temp admin. I'm going to log in with this secure password. and it showed up on this other screen. So let me bring this over here. And now here I have access to this VM that is used by the global administrator. And I already had this open, so I might as well keep it open. If I were to go look under the users/Glow folder, and I were to look in the .azure folder, I can see that Glow has used the Azure CLI in order to log in and do whatever that Glow Bowl does. And there are some access tokens here. These have been expired. So there's not Azure CLI access tokens only last for an hour, which is another thing. If you're using Storm Spotter and you get that error, it'll be fixed. I promise. I thought I fixed it. Apparently I did not. So Azure CLI tokens only last an hour. And I can go and grab these access tokens from Global, and then I can either apply it to my own profile, and I can run Storm Spotter again in order to see what additional permissions and resources that I have. But there are none to show. But from this, I've basically taken the identity of the global administrator from here. So Storm Spotter is a really good way to demonstrate that, right? I could have done all this via a command line tool, but it's a lot easier to show when you're looking in a graph like this about how you get from one node to the other. Let's do that. From one node to the other. So definitely check out Storm Spotter if you are doing some Azure enumeration, or you just want to go see what your own tenants and subscriptions look like. Things to consider. Azure AD and ARM permissions can be pretty complex. So make sure that you understand the permissions that you're giving to these roles. Make sure you read them thoroughly. There's the generic ones like, contributor, owner, and reader are pretty self-explanatory. But when you talk about like specific RBAC roles for ARM, that's definitely something to look into. And when you look at the administrator roles for Azure AD, just make sure that you're not applying it too permissively, right? If you have nested groups, right, that might be a little dangerous. So just something to look out for. You should regularly audit your permissions to look for changes, to make sure that changes to your resources haven't been made that you did not expect. And of course, follow the least privilege rules. So you don't need access to an entire subscription or a resource group to access a resource, right? You can give a user specific permissions over just a resource, and that's all they have access to. They don't need access to the entire resource group or the access to the entire subscription. So like when they try to log in with like AZ CLI, for example, they won't, they'll get that, you don't have access to any subscriptions. That's fine. That's kind of where you want most of your users if they don't need those type of accesses anyway. So that's it for my presentation. You can find me online at MCOHMI, almost everywhere. My email is daddycokeman@gmail.com. And if you happen to add me on LinkedIn, just put GrayHat RTV when you add me so that I know where you're coming from. And thank you. That's all I have. I'll be in the Discord, looking for questions and all that stuff.
Awesome. Thank you, Leroy. Great presentation. And thank you again for all your support throughout the years. I want to remind everybody that to please continue the conversation in our Discord server. The links are in the bottom of the screen. And basically, we will gonna go in a break right now, and the next presentation will start in just a few minutes. Thank you again, Leroy.
Thank you.
Welcome back. Our next presenter, his name is Rohit Sengal. And Rohit today is going to talk about a very cool tool that he created, an open source tool called Docker ENT or Docker Ent. It's basically a tool that you can, run to perform, security assessments in Docker environments. Thank you so much, Rohit, for supporting the Red Team Village and supporting GrayHat. The floor is yours.
Hi everyone. So today I'll be talking to you about the tool that I've recently created in open source domain. It is Docker Ent, and this is a tool and a framework to analyze security issues inside the running containers. And proudly, it's the only open source tool which has a flexibility of a pluggable infrastructure, and it can go inside the Docker container and identify the security misconfigurations. So I'll be presenting that tool to you about today. And in today's presentation, I'll cover very short stuff about who am I. Then I'll start talking about the Docker Ent as a tool, a quick overview of what tool does and why do we need this particular tool and how this tool can help an organization securing the runtime configurations of a Docker. Then I'll talk about the checks which are already present in this Docker Ent as a tool. Once that is done, I'll talk about the technical details of how you can create your own plugins. Once that is done, I'll show you a quick demonstration of how easy it is to use this particular tool through web interface and command line interface as well. Once that is done, I'll talk about the future work and the scope, what we can do, how we can leverage that particular tool, how we can contribute this tool back. So yeah. So before starting, I would like to emphasize a difference between the tool and a framework. So I have written this as a framework instead of a tool. The idea was behind we have compliance check or runtime configuration container checks according to the needs of the organization. So I thought of coming up with a framework so that which is customized according to the need of an organization, and so everyone can customize it and use it. But in the tools perspective as well, I have given few set of plugins for scanning Dockers right now, and I'm working on scanning Docker networks. So yeah, those plugins are already there. This is from the tools perspective, but it's more of a framework than a tool that I'm proposing here today. I hope you will like this tool. So let's start. Okay. So who am I? So I'm a security engineer with all around 4 years of pure security experience. I have done masters from system security from IIT Kanpur, and I started with bug hunting, but now I'm on the other side of the table. I actually try to secure applications for organizations. So I'm currently working with Visa right now, but yeah, I'm on the other side of the table. But I started my career of security with bug bounties and bug huntings. I'm a OSCP certified professional. I am into pen testing. I do source code review, design reviews, and I do a lot of development. So when I said about development, I do closed source development as well for my organization, and I do open source development. I love writing tools for community. So few of my very popular open source repositories are here. So I have written a trash email, DOT proxy, cloud marker, BinXP, Kubernetes in 30 minutes, and this Docker Ent is one of those. So if you are curious to know about my tools, you can just check out my GitHub repo. The link is shared in the presentation. This is my GitHub username. If you want to connect with me on LinkedIn, happy to connect. So this is my Twitter handle. And if you want to know more about me, you can log into my website and check. So this is all about Rohit Sehgal as a person. Now let's talk about what is Docker ENT. So I'll try to cover as much as I can in this particular presentation. So the idea of the Docker ENT started when I had to scan a particular Docker runtime configuration. It was during the pen testing process, so I had to identify the security misconfigurations. Now the thing was, there were more than one instances of Docker running in the system, and I had to repeat all those set of instances for all the running instances, set of scripts for all the running instances. So I thought of why not automate this particular part? Why not automate the report generation part so that in a go, I mean, anyone just simply few clicks away, I mean, you can get the report handy, and you can directly identify which containers are running with non-compliance option, which containers are running the compliant option. So I thought of designing a framework, and I call it as Docker ENT, Docker Ent. So it's a Docker runtime security scanning tool, to be in short. It's a framework more than a tool. So it's a framework written in Python, and it has been designed to keep in mind so that you can write your own custom plugins very easily and quickly. And it has also been designed keeping in mind so that anyone who don't have knowledge about the Dockers, who don't have knowledge about security, can quickly adapt to this particular tool. Deployment part has been kept very simple. So that's the beauty about this tool. So what it can do for you. So this can scan running containers in the system with a security misconfiguration. It can perform Docker level checks, and when I say Docker level checks, it can check if the namespace are okay or not, if the namespace has been properly mounted or not, why the namespace has been mounted, so it can create an info alert out of it, and it can also provide you control groups related misconfiguration. It can audit result for you, and best part out of it is that it is really customizable. So I'll talk about why I call it as a really customizable tool in the upcoming slide. But yeah, this is what Docker ENT can do all stuff for you. And yeah, it's a DevSecOps friendly tool as well. So I mean, let's say if there is a DevSecOps person who want to just analyze the containers, the set of containers which are running the production, so they can quickly set this up. There is no need to set up this tool actually, so they can quickly spin this up, and after spinning they can just get everything out handy. And at times in production systems, I've noticed that there is no access to web interface and all those things, so I've designed Docker into keeping those things in mind. I'll talk about these things in the upcoming slide, but yeah, these are the few facts about Docker ENT. And sorry for that. Yeah, and one more thing is that at the end of the day, if you see every cluster which is made out of containers like Kubernetes cluster or Docker Swarm cluster, at the end of the day they are running Dockers, and at the fine grain level they are performing the Docker level checks for those cluster as well, can give you an insight about how secure your cluster is. So if you see, it can perform the cluster level checks as well, but it will not directly go inside the cluster and perform. It will rather scan all the Docker instances which are running in your system and give you report for that. So at the end of the day, it can help you secure Kubernetes cluster. It can help you secure the Swarm clusters as well. Yeah, it's a framework, and it's a framework similar but powerful to Docker Bench, because if you see, Docker Bench is more of a script rather than a framework. So it is some way similar, but it is powerful than Docker Bench as well, and I'll talk about that thing in the upcoming slide. So yeah, in the next slide itself. So let's try to differentiate Docker ENT in Docker Bench. Okay, so if you see Docker ENT, as I talked about already, it will help you perform runtime configuration checks. It can perform the checks by going inside the running containers and doing stuff out of it. Like, let's say if there is a application properties file which is having plain text credentials, so it's a compliance issue. So this can go inside the running Docker, scan all the configuration files, scan all the properties files, and then give you the list of passwords which are already present in there. On the other hand, if you see, Docker Bench will only perform the CIS benchmark checks. Now, when I talk about CIS benchmark checks, they are and they are not related to the runtime configurations. So there are few checks which talks about the runtime configuration, and there are few checks which just talks about the host configuration of that particular Docker daemon. But Docker ENT is, I would say, is like an overlapping superset of Docker Bench. It's not the superset in it incompletely. It's not like independent tool out of Docker Bench, but there is some overlap that is happening. And it can also perform checks by executing commands at Docker, which Docker Bench is not capable enough of. So if you see, if I just draw about the Venn diagram of both the tools, it will look something like this. I'm not comparing if a tool is performing more scans for a particular container, but yeah, this is how it would look, and there is some overlap happening. And the independent part of these tools is that it can perform container internal checks. It can go inside the container and perform the checks, whereas Bench can check host level hardening checks. So these are the few things that make these tools different, but yeah, there is some overlap which is there, and the overlap is the runtime CI's benchmark checks only. So that is how this thing works. Yeah, so this is how the Docker ENT is actually different from Docker Bench. Okay, so let's talk about how easy this Docker ENT is to start it quickly. So that's the beauty of it. So you can install a Docker ENT with pip, because I have packaged it through pip as well, and I plan to do upcoming releases. But yes, there are there might be few set of plugins which are not in the package or the release right now, so you can run from the source directly if you're curious to know about the latest packages which are being latest plugins which are being developed actively, or you can call it as a nightly builds. So for nightly builds you can run from source, or if you want to run a stable build, you can install it through pip. Installing through pip is very easy. We have all done in our cases. So you just have to run pip install docker ent. Once that is done, it will download the dependencies as well. After doing this, just run docker ent -w. So docker ent -w will spin up a web interface or web application for you, and the web application has been created through Streamlit interface, because I'm not at all into UI development and web application development. So I have taken the offerings from Streamlit, because they allows you to create web applications by writing Python classes and Python code. So thanks to them. If you can just run this, it will with -w option you can quickly get the web interface for you. And yeah, if you have stuck anywhere, just do docker ent -help, and it will give you the set of options that it has and all. The other option is building from source and running from source. So I've tried to make things simple for everyone. So just clone the repo. I have provided the make file in it, so you can just do the make deps and make virtual environment. I activate the virtual environment, and then you can run it through run it as if it's an install module. So you can just run it through Python -n docker ent -help. So yeah, if you just provide -w option in here, it will spin up a web application for you. If you don't provide that option, then you will have to provide -d option, which will perform the docker scan on the command line itself. And if you provide -d nw, which will perform a docker network scan. So right now there are no plugins for docker network, but yeah, this is how it looks, and this is how simple is it to use docker ent in the current scenario. And this is the main reason I say that this tool is actually flexible enough so that it can be used by a Python developer, a hardcore Python developer, or security engineer, or a DevSecOps person, because the simplicity of tool is like it can be installed quickly, it can be run very quickly, and it can generate the report in a go as well. Okay, so let's now talk about what sort of checks it helps you perform. What checks are already there in the tooling part of it, because as I mentioned, it's more of a framework than a tool. But when I talk about the tool, also there are few checks which come in this framework itself. So these are a few of the checks. But yes, if you want to know about the latest checks which are there in it, so you can directly go to this particular link. It will give you the list. So yeah, this is the set of these are the set of plugins or the checks which are already in there. So there is a command history, file system, network, and so on. These are the links to those particular files. And if you see the last two columns is the feature and audit. So if you see few of the plugins have audit field missing, or it is written that there is no audit available for that particular plugin. So those plugins do not provide you any audit results, rather they'll just give you info results. So yeah, let's talk about each of them quickly. So command
name is Chloe Mastagi, and today we're going to talk about how to start a movement for hacker rights. And this is a workshop brought to you by Hacking is Not a Crime, which is an organization that I have co-founded. So let's dive into this, shall we? I'm going to turn off my camera because there's a lot of stuff we're going to cover today, and I only have 2 hours of your time, or maybe it's a little bit less. But anyway, if you have any questions at all, feel free to reach out to me. I'll be in Discord and whatnot. This is a recording, and it is the middle of the night while I'm doing it. Hence, you see a lot of shadows going on. But anyway, I'm so thankful for GrayHat for allowing me to do this workshop. This is my first ever workshop, you guys, in the hacker community. So I'm thrilled for this. Just note that this is going to be more on a human element, not a technical element. However, there is definitely some strategies that have been pulled in from my experience and from the work that I do in my career. So let's do this. Remember, stopping video, but I promise you I'll be online for you. All right, now let's dive into the good stuff. The reason why you're attending this in the first place. So I'm going to share my slides with you. Hold on 1 second. Boom. All right, let's begin. So once again, this is how to start a movement. Hacking is not a crime workshop. Before I begin, I just want to reiterate that this workshop is something that has came about from Hacking is Not a Crime and the mission that we're working on. But I also want to say that this workshop is completely dedicated to all the hackers who have been scared to disclose, to all the hackers who've been prosecuted for trying to do something good or doing their actual job, to all the people who are in the fight to bring rights for hackers, and to you, because you're attending this. So there must be a part of you that is interested in how to change the situation that we're in, or you just didn't even think that hackers didn't right, or what are hackers again? Anyway, we'll cover all that, I promise you. So for those that do not know who I am, my name is Chloe Mastagi, and I'm an InfoSec advocate and activist. I'm a co